Warning: the experiments performed in these lectures can be dangerous. Any attempt to perform these experiments on your own is undertaken at your own risk. Your lecturer is Professor Lonnie A. Gamble. Professor Gamble is a founding faculty member and co-director of the Sustainable Living Program at Maharishi University of Management in Fairfield, Iowa, where he has taught since 2003. He has a B.S. in Electrical Engineering from North Carolina State University. Professor Gamble is a co-founder and former board chair of the Sustainable Living Coalition and has founded half a dozen companies in the areas of renewable energy, telecommunications, sustainable building and development, and sustainable agriculture. He regularly writes, speaks, teaches, and develops curricula in these areas of interest and has received numerous teaching and service awards. In addition, Professor Gamble has a consulting practice in the design of high-performance buildings and renewable energy systems.
When thinking about sustainability in your life, what do you need to consider? The short answer is everything. Every dimension of your life can be reconsidered in terms of sustainability. This includes material dimensions of life like energy, food, water, housing, transportation, and city-rural context. Let me give you some examples. How might this affect your choices in purchasing a home in the sustainable future? Well, instead of buying your electricity from a utility company, you can produce your own electricity with solar panels on your roof. Instead of buying gasoline for your car, you can drive an electric car powered by energy you produce on your roof. Instead of heating your home with fossil fuels, your home can be designed to collect and store solar energy. Instead of buying all your food at the store, you can produce some of it in your backyard and buy the rest direct from local farmers. Instead of buying water from the water company, your house and yard can be designed to collect, store, and process rainwater. Instead of driving everywhere to get the necessities of daily life, you can live where everything you need is a short walk or bike ride away. But we aren't just material beings. We are social beings, needing to love and be loved. And we are spiritual beings, needing a sense of purpose and meaning. So there is a non-material aspect to sustainability. Two, actually. One which deals with social institutions like education, governance and economics, concepts like work, relationships, and a sense of purpose and meaning. And another non-material aspect that has to do with understanding our purpose in life. Without purpose and meaning, sustainability doesn't make sense. If there's no purpose or the purpose isn't good, sustainability makes no logical sense. Every aspect of human endeavor needs to be reconsidered in terms of sustainability, and it's bigger than anything else that humans have ever done. It's bigger than the communications revolution, the industrial revolution, and probably as big a revolution as going from hunter-gatherers to settled agriculture. We are in the beginning stages of a 50 to 100-year transition, and at the end of that time, we'll wake up with a different relationship to each other and to nature, a new set of eyes to look at the world, a new conception of how the world works and our place in it, a new worldview. Like the agricultural and industrial revolutions that preceded it, everyone on Earth will be involved in the sustainability transition. Today, sustainable ways exist side by side with non-sustainable ways. Think of buildings. Over the past few years, there has been a convergence towards sustainable building. In 2014, it's pretty hard to find an architecture program that isn't rooted in the principles of sustainable design. Today, buildings use 50% of the energy that flows through the economy, and the American Institute of Architects has a plan to bring that to zero. The American Institute of Architects Architecture 2030 plan requires that all new buildings be designed to produce as much or more energy than they use by 2030. The Architecture 2030 plan is not just a dream. It's the official policy of the American Institute of Architects. Design is the first signal of human intention. If we get the initial design right, then we often get cascading side benefits, what Wendell Berry calls solving for pattern. If we get the initial design wrong, then we are left to deal with cascading side effects. Let's look at city design as an example. If we design a city so that the necessities of life, school, work, shopping, social life, and entertainment are just a short walk or bike ride away, then we get the side benefits of regular exercise, social connection, less use of fossil fuels for driving, and less cost and less space for car infrastructure like parking and roads. If we design a city so that the necessities of life require driving, we get side effects like extensive car infrastructure, more car accidents, time wasted driving, expense and pollution from automobiles, and social isolation. Let's take a look at building design. If we design a building that is well insulated, is oriented properly to the sun, and has windows placed to capture solar energy in the winter and daylight all year long, the building will provide a lot of its own heating and lighting. If we don't design these features in, they are difficult and expensive to retrofit later, and we will be stuck with a series of those cascading side effects I was just talking about, including high energy bills to operate the building and lower comfort levels. In the future, there won't be separate sustainable options. It'll just be the way we live and do business. It's what I've dedicated my professional and personal life to. I live rooted in the abundant flows of natural systems. What does that mean? Well, I live in a home I built myself from straw bales. My home is powered by solar and wind. I haven't paid an electric bill in 22 years. It doesn't seem like a big deal to me, but I got a standing ovation once for saying that to an audience, so I mention it in lectures now. I harvest rainwater for water supply. I haven't paid a water bill in 22 years either. You could do this, really, it's not so hard. I grow some of the food I eat every day just outside my kitchen door. I even grow food in the winter in simple structures I will show you how to build and use. And I live in Iowa. I took everything I learned at home and I scaled it to the size of a neighborhood, largely because friends were coming to me and wanting to do something similar. A project called Abundance Eco-Village. We'll visit it and I'll talk more about it. The point is, again, it's not that big of a deal. As Bill Mollison, the developer of the permaculture sustainable design methodology, said, though the problems of the world are increasingly complex, the solutions remain embarrassingly simple. I think it's true. My colleagues and I at Maharishi University of Management created a new academic discipline, sustainable living, which is a transdisciplinary, hands-on, solutions-based approach to the broad range of challenges and opportunities that face humanity, like managing global warming, addressing economic instability and inequity, and protecting against ecological collapse. My goal is to show you how we can begin to favor the principles of sustainability in your life, to become a participant in the sustainability revolution, in as big or as small a way as you can. We'll explore growing food at home, using solar energy, harvesting rainwater, and even rethinking investments. Rather than being passive consumers, we can become co-producers of food, energy, building materials, and more. In the past 50 years, the supply chains that provide us with our material needs have become global in scope. We've gone from getting our food, shelter, and energy from within our local communities to sourcing our needs from a global marketplace. This made sense when energy was cheap and global warming wasn't a concern. But we've got a whole new set of technologies that provide us with local solutions, like harvesting solar energy from our rooftops, and new approaches to urban agriculture and organic agriculture that allow us to grow food in and around urban areas. Part of sustainability is going back to getting energy, food, and building materials sourced locally and sustainably. We'll explore ways to relocalize in your home and community, like growing food in your backyard or on your porch, developing relationships with local farmers, planting fruit trees in public parks, generating your electricity from solar energy, harvesting rainwater, and building a home from local natural materials. We do all of this in my community. If we get more of our needs met locally, the good and bad consequences of how we provision our lives become visible, and we become directly aware of the consequences of our actions. We create interest in economic activity in our communities. The places formerly used to get the stuff we need can be restored to wetlands, wildlands, and beauty, providing essential services for all life on Earth. Cultivating them as wetlands, wildlands, and protecting their beauty becomes our role, not exploiting them to satisfy unsustainable needs and wants. To talk about the practical details of sustainable living, we need to start by discussing the concept of sustainability, the design of sustainability. The classic definition of sustainability, and the one I'll work with more or less throughout the course, is meeting the needs of the current generation without diminishing the ability of future generations to meet their needs. This definition comes from a report called Our Common Future, also known as the Brundtland Report, which was commissioned by the United Nations in 1987. So sustainability means that we need to consider the impact of our current use of natural resources, materials, and energy on future generations. For example, we can make electricity from fossil fuels, or we can make electricity from solar energy. In the case of fossil fuels, it's a store of energy that we're using up, and what we use means less for future generations. In the case of solar energy, it's a flow of energy that is replenished daily. Learning to use it now leaves future generations better able to meet their needs for energy. Sustainability involves dedicating significant resources to the regeneration and renewal of the human and natural systems that we and our children and their children depend on. To understand this better, we can think about the link between energy, entropy, and sustainability. Sustainability really is all about understanding energy. Everything of use to us requires energy. Houses, clothes, and cars require energy to make and energy to use. All material things are concentrated energy. That's what Einstein said with his discovery of E equals mc squared. Even human usefulness, our thinking, our working, our creative minds is all about energy. Even our social relationships with one another, even our spiritual relationships all require and use up energy. We have to have biological energy to fuel the body and the mind and the spirit. In addition, we need energy to make humans productive. We're born as helpless little babies, and we need to be nurtured, cultured, and educated. All this takes energy. The first law of thermodynamics says that energy is neither created nor destroyed, so you might think that we can just use it over and over again. But the second law of thermodynamics says that every time we use energy, some of its usefulness is lost. Whenever we use energy, it always changes form. And it always changes form in a particular direction, from a more concentrated, organized form to a more dissipated, disorganized form. Here's an example. Explode gasoline in the cylinder of a car, and it's the tendency of energy to disperse that drives the piston and drives the car down the road. It's that dispersion that fuels our bodies from food. You could use the energy over again. You didn't destroy it, but it's less concentrated, less organized, and therefore less useful. So no matter how efficient we get in recycling and conserving, we are inevitably moving toward entropy. We're depleting usefulness. We're using up the ability of the planet to support life. Once we deplete the usefulness of nature and society, there is no place else to get more. So it seems that we may have to do three things. First, slow down our use of resources. Second, explore alternative sources of energy. And third, learn to create human systems that regenerate and renew. Systems that work within the great ecology of nature, like the hydrological cycle, the systems that recycle materials, and the systems that maintain the fertility of the soil. The great news is, of course, that we have a big, beautiful source of energy that offsets the inevitable loss of usefulness to entropy. What is it? Solar energy. We have solar energy to regenerate and renew. We have solar energy for sustainability. That's our alternative energy source. Now, what about slowing down our use of resources? How does that work? Unfortunately, many people think it's all about cutting out and cutting back and self-denial. Sustainability is not about doing without. It's about learning to work within the abundant flows of natural systems. Now, what does that mean? Sustainability is about efficiency and substitution. We need to be more efficient at the way we're using energy and materials. We need to substitute toxic ways of doing things for non-toxic ways that work with nature rather than against. But efficiency and substitution are not enough. We need to create systems that, like nature, use solar energy to regenerate and renew the lost usefulness caused by entropy. Then we can begin to create systems that work with and celebrate nature's abundance today, creating the possibility for future generations to do the same. The definition, you remember, that we've been working with. Much current discussion about sustainability under the heading of efficiency and substitution is about making the human ecological footprint smaller. The ecological footprint is one measure of ecological impact. Ecological footprint is a calculation of the amount of land needed to source the material for your life and to sink your wastes, year in and year out. The average American has a 24-acre ecological footprint, but the U.S. only has 9.6 acres available per person. So we run a deficit of 14.4 acres per person. That's about 14 football fields of deficit. 14 football fields more than we really have to get what we need and dispose of our waste. Our ecological footprint currently in 2014 is out of sight and out of our control. It also reaches all over the globe. This is what unsustainable looks like. We make up this ecological footprint deficit by harvesting resources faster than they regenerate, dumping carbon into the atmosphere instead of sequestering it, and using the productive capability of other, usually poorer countries, often in the global south. If everyone used resources the way the U.S. does, we would need 4 Earths, and we've only got 1. Looking at the whole planet, there are 4.7 acres available for each person on Earth. This is called the fair share ecological footprint. According to Dr. William Rees, who developed the ecological footprint methodology, we've been in ecological overshoot since around 1970. Overshoot means that the annual demand on resources exceeds what Earth can regenerate. We're using up the Earth's resources at a greater rate than they can regenerate. One of the biggest challenges to maintaining a small ecological footprint, some might say the biggest, is the mindset that fossil fuels are a renewable resource. So when we gauge tolerable distances, we think in terms of driving a car or flying a plane. Sure, we'll buy our avocados from Peru, bring in our mangoes from Chile, we'll drive across town to see a movie or 2 towns away for a night out. But what if when we're thinking about buying a house, we asked how far it is to walk or bike to the closest grocery store or place of worship instead of how far it is to drive? Whether the soil in the backyard was suitable for a family vegetable garden instead of just lawn? Where the rainwater cistern was located, assuming there is one. Here's where localization is important for sustainability. If we can get our human needs met locally and sustainably, we will leave more of the planet for natural systems and the other life forms we share the planet with. If you'd like to calculate your ecological footprint, there are online sites to help you do that. It is important that we live within the biophysical limits of the planet. We only have so much incoming sunlight, and we need to share it and the other physical resources of the planet with other species that live here. It starts with trying to live within the biophysical limits of our homes and neighborhoods, within a fair share ecological footprint. Taken to its logical consequences, of course, this idea of ecological footprints takes us to the conclusion that the Earth would be better off if we were all dead. But fortunately, human footprints can have a positive impact. To be sustainable, our reduced footprint not only needs to be small, it also needs to be regenerative. What if the byproducts of human activity were regenerative? Examples of regenerative byproducts include wetlands, wildlands, and beauty. Our reduced footprint needs to be beautiful because it's easier to care for and love things we consider beautiful. E.O. Wilson states that the mass of ants on the planet is more than the mass of humans. Yet we don't look down from an airplane at ant colonies and bemoan the negative global effects of ant society on the future viability of the Earth. Because ants work with nature, their homes are built of ecological materials, and they don't use fossil fuels. Their footprint is regenerative. Ours can be too. Sustainability is about how we celebrate nature's abundance and diversity to create a life that is regenerative in a physical sense, using solar energy, but also regenerates and renews the human spirit, which is subject to its own laws of entropy and regularly in need of regeneration and renewal. The best place to start thinking about sustainability is right at your front door. Whether you live on an acreage in the country or in an apartment in the city, you can begin to make the shift to sustainable living. Sustainable living is a process, not an end goal. Our understanding of sustainability continues to evolve, and with it, our lifestyle. There are surprising advantages to sustainable living in the city. I mentioned my home in the country earlier, powered by solar panels, water supplied by harvesting rainwater, food production integrated into the landscape, and it's made of local natural materials. Sounds pretty good, huh? But contrast this with my friend Ben Stallings, who lives in an apartment in the city while I live in a rural environment just 3 miles from town. Ben has never owned a car. He's always managed to live in a place where he could walk or bike to get all his physical and social needs met. He found my community as part of a 3,000-mile bike tour around the U.S. visiting eco-villages, intentional communities, and other places on the forefront of sustainable living. He takes the train instead of flying. He lives in an apartment building, and he shops at the farmer's market just down the street from his apartment. His energy bill is about 1/3 the Iowa average, partly because he shares apartment walls with others. Even though he doesn't grow his own food or have solar panels, his ecological and carbon footprint are less than mine. In my rural location, I have to drive to get all my needs met. Even though I generate my own electricity, I am dependent on a worldwide network of suppliers to build and repair the equipment I use to generate my own power. Some argue that New York City is the greenest place in the U.S. People live in compact apartments, the shared walls resulting in fewer materials to build and less energy to run. Most people can get their needs met by walking, biking, or public transport and don't have a car. The proper urban context multiplies the benefits of green technologies. The cutting edge of sustainability is making dense urban and village environments the most attractive places to live. Sustainable living is often thought in terms of boundaries or limits, and for many people, limits are bad. But the infinity of life is lived within the boundaries of a body and the laws of physics on the earth. In design, boundaries are the drivers of creative solutions, of richness and diversity. The toughest design problems are those that have no design constraints. Gravity can be seen as a boundary, or celebrated as the force that holds people to the surface of this beautiful planet and sets the Earth in just the right orbit around the sun. In contrast to the limited stocks of fossil energy, nature's flows are abundant. Here's an example from my life. I use solar energy to heat my water, and I get my water supply from the sky by harvesting rainwater. If I know it's going to rain again soon, and it's a sunny day, I can take a shower all day long. The water will be replenished by rain, and the sun comes up every morning. If we live within the generous bounds of nature's laws, we've got plenty. This bread is stored solar energy in the form of biological energy. When I eat it, it provides energy that drives the biological processes in my body. The biological energy in the bread is used in many different ways: thinking, moving, doing physical work, before it eventually is turned into body heat and waste. I could use the bread flour in a different way. In this case, I dispersed the flour into the air and lit it with a flame, causing the explosion you just saw. I blew up the flour without getting anything of use to me out of the stored solar energy in the flour. Rather than blowing up the wheat or eating it, we could plant the wheat. The wheat plant diverts energy from growing stalks and leaves into producing grains, into giving back for future generations. Like the wheat plant, humans need to dedicate energy to renewal for future generations. But we don't have to plant all the wheat. We can use some for bread to meet the needs of the current generation, and we can use some to plant for future generations. One seed can yield 75 seeds in just a few months' growing time, using solar energy, the fertility of the land, and water as inputs. Nature is fecund and abundant. We've got plenty for ourselves and for future generations if we use resources and energy wisely rather than blowing them up. Here's a diagram that illustrates the abundant flows of solar energy that powers nature's economy. Imagine a box big enough to hold all the solar energy the Earth receives in a year. The smaller box represents the quantity of solar energy that drives the hydrological cycle. Wind energy is also solar energy, and this box represents the amount of solar energy that drives the winds. The small box here represents the amount of solar energy that plants use. Through photosynthesis, plants use solar energy to create biological order and structure on the planet. And biology works in concert with geophysical processes to continually recreate and maintain optimum conditions for life. In that sense, the order and structure of this piece by Vivaldi was forged in the thermonuclear reactions in the center of the sun. The changes we need to make in our lives for sustainable living lead to a different way of life, a different way of thinking about the world and our place in it. But that doesn't imply a diminished quality of life. In the wealthy countries, we've gone past the point where increases in material wealth bring corresponding increases in human well-being. Increases in well-being in the industrialized countries come from the developments in the other dimensions of sustainability, like better relationships and a sense of purpose and meaning. The academic literature on happiness indicates that the correlation between happiness and income begins to break down somewhere around $10,000 to $15,000 per capita annual income. As a thought experiment, consider this. In the US, we've doubled productivity since 1970. But what have we done with that increased productivity? Well, mostly we bought more stuff. Another way of thinking of this is that we could have a 1970 material lifestyle and work only 20 hours a week, leaving more time for family, friends, reflection, and volunteer work in our communities. If we stay on the same economic track, in another 50 years, we'll double productivity again, leading to twice as much cheap stuff. Will your life be better with twice as much cheap stuff? Or could it be better if we took more and better advantage of this increasing productive capability by spending more time cultivating new skills, eating better, fresher food, making more friends, building closer ties to our family and neighbors? I'll leave that to you. Sustainable living is applicable across a wide range of scales. So far, we've been talking about individual efforts at sustainability, but there are some things that need to be done at the level of the community and beyond. I have the good fortune to live in a community that has a wide range of sustainability efforts going on. Community leadership plays an essential role in integrating sustainability into a community. The Great Courses team and I met with Fairfield, Iowa's Mayor Ed Malloy, who is dedicated to sustainability in his role as a mayor and also in his personal life.
My name is Ed Malloy. I'm the mayor of Fairfield, Iowa, and we're standing in front of my 10.5 kilowatt, 42 panel solar array that provides approximately 65 to 70% of the electricity during a full year for my personal home. And this was installed a year ago, something that I had been very passionate about for many years, but was able to get it to a point where the economics of installing this made quite a lot of sense because the cost of materials had come down significantly, and also in partnership with our utility, Alliant Energy, there were some very nice incentives offered, rebates towards these panels, and also some incentives from the federal government and state, which made it very easy to make the decision to do something that I've wanted to do for some time. What's very important to me is to always move in the direction of living closer to nature and natural law. And the energy that the sun provides is free. It essentially is what gives life to our entire planet and to the entire solar system. So this small piece of connecting the sun to our home is something that is very gratifying, and also just in a very quiet, peaceful way makes me feel good about that greater connection to nature and to natural law. We live in an extraordinary community where when something like this becomes evident to our citizens that there is some greater value and that there's some greater enhancement in living closer to nature, we take full advantage of these opportunities. Over the last 2.5 years, we've seen our community develop well over 300 kilowatts of solar power in both the commercial and residential sector, and we see ourselves as a model, as a place where we can demonstrate for small communities all over America how easy it is and how sufficient and efficient this transition can be to a more renewable energy future. So we're very, very happy about what we've been able to do for our home. We encourage this all across our community and really invite anyone who would like to come and see how we've incorporated it into our community of Fairfield, Iowa, to come and see if that could be modeled elsewhere in America.
As I quoted to you earlier, though the problems of the world are increasingly complex, the solutions remain embarrassingly simple. Our goal here is to leave the increasingly complex problems for others to explore and focus on the solutions. Imagine a huge tank of oil, the size of a football field and 100 feet tall. During this half hour together, the world will use the energy equivalent of 5 football field-sized tanks of oil 100 feet tall. That's a lot of energy. But during the same time, the sun will shower the earth with the energy equivalent of 38,000 football field-sized tanks of oil. That's a huge amount of energy. Yet only a tiny fraction of the energy radiated by the sun hits the earth, about a billionth of the total. From a human perspective, the sun is unimaginably powerful. The awesome forces of nature are powered by a daily dose of sunlight, and the human economy can be powered by sunlight too. When I say solar energy, I mean solar energy in all its forms. Solar electricity, solar heat, wind energy, hydroelectric energy, energy from moving water, and biomass energy, which is derived from plants. The sun is the driving force behind all these energy sources. The sun heats parts of the earth differently, causing the winds to blow, and the sun drives the hydrological cycle that is the basis of hydroelectric power. There are financial benefits and satisfaction that come from using this green energy, solar and wind, that you capture at home. Remember the definition of sustainability from the first lecture: meeting the needs of the present generation without diminishing the ability of future generations to meet their needs. In order to leave opportunities for future generations, we need a source of high-quality, concentrated energy to offset the effects of entropy. Solar energy is what nature uses to offset the effects of entropy. Plants take sunlight and create order and structure through biology. People also use solar energy. For the last 100 years, we've been using solar energy in the form of fossil fuels to power our economy. There is a limited supply of fossil fuels, however. Not only are they a finite resource, we've also learned that burning them up creates problems for us and future generations, including pollution and global warming. So the direction in which sustainable living looks is to the sun. This device, called a parabolic mirror, takes 1 square meter of sunlight and concentrates it to the size of a silver dollar. 8 minutes ago, these flames were thermonuclear energy on the surface of the sun, transmitted across 94 million miles of empty space. It's wirelessly distributed across half the planet at any point in time, and it hasn't missed a day on the job in billions of years. It's 94 million miles away, yet it feels warm to the side of your face and is too bright to look at. Every day, the sun delivers 14,000 times more energy than the human economy uses. I'd like to show you some of the ways that energy flows around us and how we can make use of it as it flows from a high-quality source to a high-entropy sink. A high-quality source is a source of energy, like the sun, that is at a high temperature relative to its surroundings and is capable of doing many kinds of work. A high-entropy sink is where energy leaves the system, no longer able to do any useful work. I'm not saying that all of these are practical methods for generating useful amounts of energy. I just want to expand your thinking about energy. Here's our first one. Let's say that I'm living in a remote cabin and I want a little energy to run an MP3 player and an LED light. I look around and I find a potato, a galvanized nail, and some copper wire. What good will that do me? Well, let's see what happens if I hook these up and measure it with a meter. Do I get any energy from this? I do. I see I get about 0.8 volts per potato. If I hook 2 potatoes together, I can get 1.6 volts, about the voltage of a AA battery, enough to run my MP3 player and maybe an LED light. It's also enough energy to run this clock. Okay, let's try another way to generate energy. And this one has actually been used in some really interesting ways. A thermoelectric device uses the junction between 2 different materials to generate electricity. Heat one side of the junction and cool the other, and you get electricity with no moving parts. When you put electricity to the device, one side gets hot and the other gets cold. It's a weird sensation to have something this thin between your fingers that is simultaneously hot and cold. Ouch. But if I heat one side of this and I cool the other, it'll make electricity. This has been used to generate energy in some innovative ways. During World War II, the Soviet Army was looking for a silent way to generate electricity to run radios. Generator noise allowed Germans to find them. They developed silent thermoelectric generators, which were used after the war on the chimneys of kerosene lamps in order to power radios in remote cabins. The generator that runs the electronics and lights in your car eats up a mile or two per gallon of your gas mileage. One company has figured out a way to eliminate the generator in cars and trucks by using a thermoelectric device on the exhaust. With billions of miles driven every year, this could add up to a lot of energy saved. What if your clothes were made of this material? One side would be heated to 98.6 by your body and the other would be cooled in the atmosphere. It could generate energy from the temperature difference between your body and the environment. You could charge your cell phone from the difference between room temperature and your body. Have you ever been up on a hot metal roof in the summertime? You could make thermoelectric metal roofing to put the temperature difference between a hot roof and the atmosphere to use. Some crystals make electricity when squeezed or stressed. This is called the piezoelectric effect. This lighter has a piezoelectric crystal that generates the spark that ignites it. When I pull the trigger, a little hammer hits the crystal, stressing it and creating electricity. In England, the parking lot of a supermarket uses piezoelectric material. The weight of cars driving over it stresses the material and it produces enough electricity to power the lights in the parking lot. This effect is responsible for some kinds of lightning during earthquakes and volcanic eruptions. Forces in the earth stress crystals in the earth's crust and produce lightning. A sustainable approach to life and community design focuses attention on the myriad ways in which energy is constantly and dependably flowing around us. There is energy all around us, flowing from source to sink in thousands of ways, and we can make use of it as it flows. We've really just begun to scratch the surface of all the ways in which we can harness all this energy. Now that we have an idea of the big picture of energy in the universe, let's talk about using it efficiently. It doesn't mean freezing in the dark. The goal is to use energy smarter, getting our hot showers and cold beer with far less energy than we do now. How much energy reduction is possible? With off-the-shelf technology, it's possible to reduce energy consumption by 75% or more and still provide the same or better services. My home uses less than 100 kilowatt hours per month. The average home uses 1,000. Even though I am somewhat of a geek, with a shop, music studio, large flat screen TV, and a full complement of kitchen appliances, I use 1/10 the energy of a conventional home, a 90% reduction. Let's talk about some ways you can begin to use energy more wisely in your home. The first step is to figure out how much energy you use. What percentage of your monthly bill goes to lighting, electronics, or the fridge? What percentage provides no useful service to you at all? This takes some detective work. I use a $20 device called a kilowatt to help with this. The kilowatt plugs into the wall, then you plug an appliance into the kilowatt. That's it. It measures the flow of energy into the appliance, and it's particularly useful for figuring the total energy used by things like fridges that turn on and off all day long. Heating, cooling, hot water, refrigeration, and lighting use about 75% of a typical home energy bill. These days, we use a lot of electronics, but electronics use only 10 to 15% of home electrical energy use. Here's a parable that illustrates the power of energy efficiency and how energy efficiency can be seen as a source of energy. Let's say that you're the mayor of a town that has a remote water supply that is connected by a set of leaky pipes, and only 10% of the water that starts toward town gets there. The rest leaks out. The town is growing, and you need more water. You could put in more powerful pumps to send more water to town, and even more water would be wasted as leaks. Or you could simply fix the leaks and have all the water you want without pumping any more water. Similarly, if we need new energy capacity, Energy efficiency can free up existing generating capacity for use by new customers. In this way, energy efficiency can be seen as a source of energy, what Amory Lovins calls negawatts. About 2/3 of the energy that flows through the economy is wasted. By using energy efficiently and putting the savings towards renewables, we can save enough money as a society to convert to solar energy, and we can do it at a profit. One way to maximize energy savings is to use an integrated design process. In an integrated design process, each element is evaluated for what it can contribute to the whole. In this way, larger energy savings sometimes cost less than smaller energy savings, cutting through the law of diminishing returns. Here's an example. Let's say that you're analyzing the cost savings of adding additional insulation. The first 3 inches of insulation save $100. Doubling the insulation to 6 inches cuts the heat loss in half, saving $50. Sounds good. Let's double the insulation level again from 6 to 12 inches. Again, this cuts heat loss in half, but now the savings is only $25. So let's take a look at this. The first 3 inches saved $100. The second 3 inches saved $50, and the next 6 inches saved only $25. The next 12 inches would only save $12.50. So conventional design philosophy would say that at some point, the cost of the additional insulation is going to be more than the savings, and you should quit adding insulation at this point. But we are only analyzing the insulation. If we look at the house as a whole, it might be that the final increment of 12 inches of insulation makes heat loss so low that you can eliminate the furnace. And the savings from downsizing or eliminating the furnace could pay for all of the insulation, saving more money with a shorter payback than just considering the insulation alone. Now that we know a little about using energy efficiently and wisely, let's look at generating electricity from renewable sources. There are 3 basic renewable energy technologies to consider for home use: solar electric, solar thermal, and wind. For most, solar electric and solar thermal have the widest application. Let's take a look at solar electric systems. There are 2 basic kinds of systems: grid-tied and off-grid. Grid-tied systems put solar energy on the grid, offsetting energy you would have purchased from the power company. 99% of the systems installed today are grid-tied systems. Energy flows from the sun to a solar panel, where it is converted into electricity. For a grid-tied system, in addition to solar panels, you need a device that matches solar panel output to the utility grid, called an inverter. The inverter plugs into your electric system like any other appliance, but rather than using energy from the grid, it produces energy from your solar panels and uploads it to the power grid. Grid-tied systems don't require regular maintenance or management, but they do have one disadvantage. When the utility grid is down, your system can't generate energy even when the sun is shining. If the main reason for installing solar is to have power during utility outages, you'll want a system that can operate independently from the grid. So let's look at grid-independent or off-grid systems next. Grid-independent systems require batteries that store solar energy for use at night and on cloudy days. In addition to solar panels and an inverter, you will need batteries and a charge controller. Off-grid systems are more expensive and require more management than grid-tied systems. But the solar power from an off-grid system isn't limited by existing infrastructure or the needs of electric companies. So you can get energy where utility power is not available. Where utility power is available, you can disconnect completely, or you can remain hooked to the grid. Staying hooked to the grid allows excess energy generated by your system to be used by others on the grid. The grid can also be used as backup when the sun isn't shining. Being off-grid connects you to the flow of energy in nature in ways that a grid-tied system can't. The disadvantage is that this requires more management and the careful use of energy in times when it isn't sunny. How much does all this cost? For years, we've been waiting for the price of solar technology to drop. But since 2010, the price of solar panels has plummeted by a factor of 3, and solar panels now come with 25-year warranties. The good news is that solar energy is now affordable for many, with 3 to 15-year paybacks. In some areas, companies will even install solar panels on your roof with no upfront cost. They make money by selling you power at a discount from utility rates. Solar panels convert energy from the sun into electricity with no moving parts. Nothing is used up in the process. Solar panels last a long time, and they often have 25-year warranties. The breakthroughs we've been waiting for are here. Solar energy is now cheap, reliable, and in use on millions of rooftops, even in areas of the world like Germany that only get half as much solar energy as the United States. For about the price of an overpriced daily latte, you can put enough solar electric power on your roof to offset your electric bill. And you don't even have to give up the latte. The solar electric system will pay for itself in utility bill savings. It's possible to save enough money on your bill through efficiency to pay for the monthly payment on a solar energy system. Let's use a thought experiment to illustrate this. Let's say that you want to power the lights in your house with solar energy. Let's say that it would take 10 $500 solar panels to power a home that uses incandescent lights. That's $5,000 worth of panels. A few years ago, incandescent lights were replaced by compact fluorescents, which use 1/4 of the energy and last up to 10 times longer. If you light your home with compact fluorescents, all of a sudden it only takes 1/4 the number of panels, or 2.5 panels. That's only $1,250 worth of panels. Solar's looking a lot better. Now, compact fluorescent lights are being replaced by LED lights, which use even less energy, last 5 to 10 times longer than fluorescents, and are easier to dispose of. And if you switch to LED lights, it would only take 1 panel, and the money you save on the energy by using the LED bulb would pay for the panel. This is an example of low-hanging fruit growing back. New generations of technology keep getting more efficient, enabling new rounds of retrofitting and money saving. Once again, sustainability is a process, not an end goal. Many people have installed systems themselves, and thousands of companies have sprung up to meet the demand for solar energy. If you don't want to do it yourself, chances are you can find someone qualified to set up solar near where you live. So let's figure out how much solar you need. Doing a preliminary assessment to see if solar makes sense for you involves just a little basic math. Let's take a look at a design for Austin, Texas. Once you understand this example, you should be able to use the map and do a back-of-the-envelope analysis almost anywhere in the U.S. The process involves figuring out how many kilowatts of solar you need to meet your annual energy needs, pricing the system, and figuring a simple payback. The map shows that a kilowatt of solar in Austin would produce 1,300 kilowatt hours in an average year. Find out how much energy you used last year by looking up your electric bills or calling your utility. Let's say that you used 10,000 kilowatt hours last year, which is the national average. Divide 10,000 kilowatt hours by 1,300 kilowatt hours per kilowatt, and you get 7.3 kilowatts of solar needed. A kilowatt of solar covers about 100 square feet, so the system would cover about 730 square feet of roof. Now let's assume solar costs are around $2,500 per kilowatt. So the system would cost 7.3 kilowatts times $2,500 per kilowatt, or $18,000. Assuming that you can take advantage of incentives like tax credits and utility rebates that cover 50% of the system cost, the net cost of the system would be $9,000. Incentives include a 30% federal tax credit. In some locations, incentives can pay 75% of the cost of the system. Incentives are constantly changing, and you will need to do some research to find out what the incentives are in your area. Assuming a cost of 12 cents per kilowatt hour, you pay about $1,200 per year for the 10,000 kilowatt hours of electricity that you use. Take the $9,000 system cost and divide by the $1,200 per year savings, and you get a 7.5-year payback. But after that, the energy is free. Paying cash for a PV system up front is like paying for 3 to 15 years of electricity all at once. With favorable financing and incentives, you can see savings from the first month panels are installed. After you've paid for the system in energy savings, you get free electricity for the life of the system, 25 years or more. Now, utilities charge a per-month fee to be connected to the grid, regardless of whether you consume any energy. So with grid-tied systems, it's sometimes not possible to completely eliminate your electric bill. However, your energy cost is fixed and related to the one-time cost of the equipment, not the future volatility of energy prices. You can use a different kind of solar panel to make hot water for things like bathing, washing, or to heat a pool. In the past, this was the most economical way to use solar energy. You got more energy per dollar with this technology than any other. With the drop in price of PV panels, it is not clear that this is still the case. Solar hot water systems use your existing hot water heater for backup, so you can have hot water when the sun isn't shining. Heating pools with solar energy often has a very short payback, 3 to 5 years. You can also use solar hot water or air panels to heat your home with the sun. Other ways to use solar thermal energy include water purification and solar ovens for cooking. Wind is solar energy. The sun heats parts of the earth differently, which causes winds to blow. Often when the sun isn't shining, the wind is blowing. Wind energy is an excellent complement to solar energy. I use wind and solar power in my off-grid home, along with enough batteries to power my home for about a day without sun or wind. I use a backup generator about 20 hours a year. Well, there's 8,760 hours in a year, so I'm running about 99.8% of the time on a combination of solar and wind energy. Wind energy is not as evenly distributed as solar energy, and you need a tall tower to capture the wind. Using a short tower is like putting solar panels in the shade. Some companies make wind turbines that operate like grid-tied solar electric systems. If you have a very good wind site, which is rare, you can sometimes get more energy per dollar invested with a wind system. Another disadvantage with wind turbines are their moving parts in an inconvenient location, high in the air. There are far fewer small wind turbines than solar electric systems, and there are only a couple of manufacturers that have built more than a few hundred machines. Most, but not all, wind energy machines on the market today are really prototypes that are bound to have reliability problems. I say this from hard experience. Here's a little story about one of my first off-grid wind turbines that illustrates the dynamic power of wind energy. I was so impatient and excited to see it run that I started it up without testing the controller. The controller gives a place for energy to go once the batteries are full. As soon as I turned the machine on, it started to spin and the wind began to build. In the next couple of hours, I was thrilled to see my battery bank fill with energy. Once the battery bank was full, I realized that the controller wasn't working. There was no place for the energy to go, and the wind was continuing to build. I had to turn on everything in my house and borrow electric heaters from neighbors in order to use up all the surplus wind energy and not overcharge my batteries. I ended up leaving everything on in my house for 2 days until the wind calmed and I was able to test and fix the controller. Some utilities offer programs that, for a fee, provide energy backed by wind power. The energy comes from large wind projects the utility has invested in. Using one of these programs to complement a grid-tied solar system means that even the energy you take from the grid supports the use of renewable energy. In Iowa, where I live, 25% of the state's electricity comes from large-scale wind energy projects, but the rest comes from coal and nuclear. If you want to ensure that your backup power supports renewables, subscribe to one of these programs. What if you rent, have a very shady yard, or can't put solar on your home for any one of a number of reasons? Here are a couple ways you could still use solar energy. For less than $500, you can build a small system that will power lights, home electronics, and a few appliances. The panels could be mounted outside a window or on a porch. You'll get maximum energy if it faces south, but it can still work well facing other directions. Avoid north because the sun spends most of its time in the south, east, and west. This is an excellent way to learn about the technology, and you can take it with you or sell it when you go. Here's another simple way to use solar energy. Charge your cell phone with solar energy. Connect a small 12-volt panel to a car cigarette lighter USB charger. Plug your phone into the USB port, then put the panel in the sun. You can even assemble your own solar panel. Look on the internet for directions. A second way for a home renter to support sustainable energy sources is to pay a special rate to the utility to support renewable energy, as I mentioned earlier. Some utilities allow you to pay a special rate for power, usually higher, that goes to support renewable energy. A third way is to join a community solar garden if you are lucky enough to live where they are allowed. This is a fantastic idea. Solar panels installed in a central location in a community. You can buy as few as one panel, and someone else installs and maintains it for you. You can sell it if you leave town. The output of the panel is billed as if it were installed at your house. It offsets what you would have purchased from the utility in the same way as if it was installed on your roof. Only a few places allow this. Colorado, for example, has a statewide policy allowing solar gardens. Some city-owned electric companies and co-ops, like Farmers Electric Co-op in Kelowna, Iowa, have solar gardens as well. You can even cook with solar. Here's a picture of a solar oven cooking my lunch. Other sustainable energy options to explore include solar building design, heating and cooling, transportation alternatives, and solar hot water. We'll explore all of these in future lectures. Energy is essential for sustainability, for regenerating and renewing the lost usefulness of things due to entropy. If we invest the resources needed for regeneration of nature and society, we can leave more and better options for future generations. Now I'd like to tell you a story about the power of renewable energy to create jobs and contribute to a dynamic economy. This is Troy Van Beek. He was a Navy SEAL team member for 9 years, and after he left the Navy, he went into private high-risk security. One of his jobs was as lead sniper, providing security for President Hamid Karzai, the president of Afghanistan. At one point in his life, he decided to shift from war to peace and became a student in the Sustainable Living program where I teach. As part of a program to bring renewable energy to Angoon, a remote Tlingit Native Alaskan village, he and his fellow students learned the basics of installing solar panels. On graduation, he, his partner Amy, and some of his classmates started Ideal Energy, a company that installs renewable energy systems. Last year, they sold $1 million worth of solar panels in our small rural Iowa town, and this year they are on track to install more than $3 million worth of solar. We even hired them to install renewable energy systems on the new state-of-the-art Sustainable Living program building, the Swartz-Guich Sustainable Living Center. Troy took this picture from 100 feet up on the wind tower that powers the center. As renewable energy ramps up, variations on Troy's story are being repeated thousands of times all across the country. Renewable energy technology is good enough and cheap enough so that you can create a solar-powered life today. Renewable energy has never been more affordable and reliable. Even after 23 years, I still get a deep sense of satisfaction and wonder when I listen to music, work on my computer, or read using energy that came directly from the sun. I save money. My system has paid for itself many times over. Investing in renewable energy gives peace of mind that comes from knowing your energy costs are fixed for the next 25 or more years. It's not a sacrifice to use renewable energy. It's participating in a better way of life. On average, Americans spend 90% of their time indoors. Buildings and cities have a huge impact on our comfort and well-being. Green buildings with lots of natural daylight, non-toxic materials, and superior levels of air quality and thermal comfort can have a big impact on well-being and productivity. Besides the impact upon those of us who live and work in the built environment, buildings also have a huge impact on sustainability through energy and material use. Buildings consume 50% of the energy and 75% of the electricity that flows through the U.S. economy. Buildings use 40% of all raw materials globally. 15 trillion gallons of potable water are used in buildings annually, about 14% of the total. About 40% of greenhouse gases are sourced from buildings. The good news is that we can design buildings that produce more energy than they consume, harvest rainwater from the sky, and are filled with natural daylight, and are built of non-toxic materials. Buildings can be designed to be recycled when their useful life is over. And we can do this for about the cost of building conventional buildings of the same quality. As I've mentioned before, the American Institute of Architects has adopted a plan called Architecture 2030, whose goal is to transform the built environment from the major contributor of greenhouse gas emissions to a central part of the solution to the climate and energy crises. Architecture 2030 calls for all new buildings to be net energy producers by 2030, and for the renovation of older buildings to conform to these standards. Net energy producer means that the building produces as much or more energy than it consumes on an annual basis. Let's talk about some of the features of green buildings I've helped design. This building meets the Architecture 2030 standards today. It's the Schwarzkowich Sustainable Living Center. This is the home of the Sustainable Living Program at Maharishi University of Management in Fairfield, Iowa. I'm the co-director of the program, and my office is in this building. It's designed to be a living laboratory for the principles of building design that we teach. The building was built of local natural materials like earth blocks, whole tree timbers, and natural plasters and paints. We did some filming in a couple of classrooms in the Sustainable Living Center. Let me show you what an earth block looks like, and then how we make a building out of them and other natural ingredients. This is an earth block. It's made of material that we just dug from the ground. We rented a special machine, put the earth in the machine, and the machine can squeeze out enough of these blocks to build a house in a day. If there's no other material in here, no concrete, no other filler, it's just earth compressed. All the walls that surround us in this building are made of this block. The students built 35,000 of these blocks for the construction of this building, and you can see them in the wall behind us right here. I'd like to talk a little bit more about how earth is used in this building. We saw in the big classroom how earth blocks create the walls of this building. And then we also cover those walls with an earth plaster. So this wall here is built of earth blocks, but then we've covered it with a natural earth plaster, which is earth we just dug up from the site here, mixed with a little bit of clay, sand, and chopped straw, and a little bit of manure from our local organic dairy. That's a traditional ingredient in a lot of earth plasters. Now, you notice this wall is dark. The clays we dig up here are dark, and the rest of the walls in this room are light. That's because we want to use daylighting in this building to light the building. There are ecological consequences for building solar panels and wind generators, and we want to use that energy wisely. The largest use of energy in this building is for lighting. So we can get all the light we need just by bringing light in from those high windows that you see here on this side of the room, and the high windows in the atrium that brings light into the center of the building. Light this classroom from both sides. We have low windows for views so that students feel like they're connected to the outside. In order to make the walls white, all we did was cover this natural earth plaster with a lime wash. So there's very little real paint in this building. It's mostly just earth, clay, sand, and a lime wash, so that we use mostly just natural materials. The Sustainable Living Center has a solar electric array, wind generator, solar hot water collectors, and a geothermal heat pump that produce 30% more energy than the building consumes annually. Let me show you around. First, the beautiful passive solar greenhouse. In ecological design, every major function in a system needs to be performed by many different elements. So in this building, we have 3 ways in which we heat the building and 2 ways in which we cool the building. The first way in which we heat the building is called passive solar design. In passive solar design, we have windows here that face south. We use all of the materials that you would use in a regular building, windows, concrete, steel, and we place them in such a way that we use our understanding of the flow of energy across the site and the different places that the sun finds itself in different parts of the year in order to heat the building almost for free, because it's all materials that we use in any building. So for example, these windows that face south, there's an overhang above them. And in the summertime, when the summer sun is very high in the sky, these windows are completely shaded so that there's no extra heat gain into the building in the summertime when we don't want it. But in the wintertime, in this latitude, the sun is only about 20 degrees off the horizon. It's just a little bit above the horizon, and the sun penetrates deeply into this room, hits against these walls, and heats the building. So that's the first way in which we heat the building. Now we're going to go talk about the second way, which is active solar design using collectors on the roof of this building. Now that we've learned a little bit about passive solar, the first way in which we heat the building, I want to tell you a little bit about the second way in which we collect and store solar energy for this building. It's called active solar. It uses one of 2 kinds of solar panels we have on the roof. 2 kinds, one that make electricity and one that make hot water. The ones that make hot water collect the sun's energy in hot water and store it in this 5,000-gallon tank. Then we have pipes in the floor that when the building calls for heat, we can take this hot water and we can store several days worth of solar energy in this tank and distribute that throughout the building. These devices back here are called controllers, and what they do is they monitor the temperature of the solar collector and they monitor the temperature of the tank, when the temperature of the solar collector is hotter than the tank, it turns on a pump that will circulate the fluid and collect the solar energy and store it in the tank. Then when the building requires heat, if the passive solar again isn't keeping up with the demand for heating for the building, then the thermostat in a room will turn on one of these pumps, which circulates hot water from the tank through the floor into the building. So this pump, for example, is the big classroom that we were in first. This pump is the middle classroom, this pump is the greenhouse, and that's how the heat is transferred from the tank into the building. If we have an extended period of cloudy, cold weather in the wintertime and the passive solar and the active solar weren't keeping up with it, we have a third way in which we heat the building, and that's with a geothermal heat pump, which we'll take a look at next. Now, if the passive solar and the active solar aren't keeping up with the heat requirements of the building, we turn to our third way of heating the building, which is with a geothermal heat pump. Geothermal heat pump takes 1 unit of electricity and uses it to pull 2 or 3 units of heat from the ground. There's a network of pipes, thousands of feet of pipes that are about 15 feet in the ground, and the temperature at 15 feet is always about 55 degrees. It takes electricity to do that, but we use our solar and wind power to power the geothermal heat pump. In the summertime, we can also use it for cooling because it's much easier to reject heat from the building to the ground at 55 degrees than it is outside when it's 100 degrees out. And overall, the building generates about 35–40% more energy than it uses, not just for electricity, for computers and lights and PowerPoint projectors and things like that, but also for heating and cooling. So all the energy requirements for the building are matched, plus about 30% is given back to the grid. The building collects water for free from the sky through rainwater harvesting. It supplies water for all uses in the building, including drinking. The building processes all of its sewage waste. No utility bills, no water pipes in or out. And finally, let me take you just a short walk outside the building to the power shed and show you how all the sources of solar energy come together. The first thing that happens is all the wires that go out to the solar panels and up to the top of the wind generator come in on this pipe. Believe it or not, all the solar panels and wind generators have individual wires that come in here and come in down through this pipe. And then what happens next is very simple conceptually, but there's a lot of complicated technology that goes on in this box. On this side is the solar and wind generated electricity, and on this side is the utility, and this box makes the connection between the two. It turns the solar and wind generated electricity into better than grid quality power. And this converts the energy from the solar panels that are just outside this building on the ground. This converts the energy from the solar panels that make the overhang on the greenhouse. This converts the solar energy for the panels that are on top of the building. And this box converts the energy from the wind turbine into better than grid quality power. And right now, it's generating 6,000 watts out of 12,000. It's quite windy today, but it's not very sunny. And that's the beauty of the combination of wind and solar. When it's not sunny, it's often very windy. And you get a very steady supply of energy between the two. Now we're up to 2,900, 3,000, 4,000, 5,000, 6,000, 6,700. A while ago it was up to 12,000, so it went up to half of it. And it varies because the energy in wind is related to the wind velocity cubed. So every time it doubled the wind power, we get 8 times the energy, not just twice the energy. So for example, that means if we get a 10-mile-an-hour wind and we get a gust to 20, we get 8 times the energy. So right now, it's still around 1,000, but a minute ago it was up to 12,000, and that's the maximum. Today we're actually getting the maximum out of this wind turbine. Now I'm going to show you how everything comes together. The solar and wind generated energy, the building energy, and the grid. What happens in this pipe is the solar and wind generated electricity comes in here, the building energy gets taken off here, and the energy from the power company is here. So let's use as an example, let's say that we're generating 10 kilowatts of solar and wind energy and the building's using 2 kilowatts. So 10 kilowatts comes in here. Of that 10, 2 go off here and service the building. There's still 8 that need to go someplace. So they'll go out here and actually spin the meter backwards and put power out onto the grid. Now let's say it's nighttime and the solar is not generating any energy and we're just generating maybe 1 kilowatt from wind, but the building's requiring 3 kilowatts. So 1 kilowatt comes in here from the wind energy. It services one of the 3. We still need to get 2 from someplace. So those come here from the power company and they actually spin the meter forward and we actually buy some power from the power company. So this system does this all day long. There's no storage on the grid. In other words, none of this energy is being stored anywhere. What's happening when I push it out onto the power grid is that somewhere there's a fossil fuel generator that's backing off and using less fossil fuels. So we're saving fossil fuel by putting this energy out onto the grid from solar. The system we looked at a minute ago was a grid-tied system, meaning that takes solar energy, pumps it out to the grid. But the grid has to be functioning, the grid has to be turned on, the grid has to be active in order for that to work. If the grid is down, then you won't have any power. Even though you've got solar panels and sunlight, you won't have any power. I'm going to talk about a different kind of system called an off-grid system, which can operate independent of the grid, whether there's a power grid or not, whether you're 1,000 miles from the power grid. As long as there's sunlight, this system will operate. It has a couple of basic components. It has solar panels that take the sun's energy and turn them into electricity, no moving parts, nothing to wear out. We store that energy in batteries so that we have energy for if we need more energy at the moment than the sun's producing, or if we need energy at night, we have that energy stored in batteries. Another device is a charge controller, and what that does is it takes the solar energy from the solar panels and it moderates the flow so that the batteries don't get overcharged. It controls the flow of solar energy, so if we're not using energy, the batteries don't get overcharged and get damaged from that. Then we take the energy out of the batteries, the solar and wind generated energy out of the batteries, put it into a device called an inverter. What that does is it converts the solar and wind energy into better than grid quality power from the batteries, and it provides power to run all the appliances in your house, whatever you might need to run at the time. And so it's as simple as that. Solar panels through a charge controller to the batteries, charge the batteries up, then take energy from the batteries through the inverter to power your house. You might have noticed in the video the sound level changed in the shed, in the power shed, because it was a very windy day. And you could actually hear, when it got windy, you could hear the sound of the energy being converted from wind energy into grid power. And that was the changing value of the sound in the shed that you heard in the previous clip came from that. So here's another building. It's my home in Fairfield, Iowa. It's a climate-responsive building. Every aspect of its design is tuned to the weather and climate of Fairfield, Iowa. It's off-grid and powered by solar and wind. I haven't paid an electric bill in more than 20 years. It harvests rainwater and treats its own sewage, so I haven't paid a water or sewer bill either. No pipes in, no pipes out. It's got high windows that flood the building with daylight. It's built of locally sourced materials like lumber and earth plasters. It's insulated with straw bales stacked up like bricks. I took everything I learned at my home and designed a housing project called Abundance Eco Village, which is powered by solar and wind, has a farm and edible landscaping, and uses rainwater for water supply. In Abundance Eco Village, the beers are cold and the showers are hot, but the homes, by design, use 1/3 to 1/10 the energy of a conventional home. We've found smarter ways to get better service from energy with Energy Star appliances, extra thick insulation, sun-catching greenhouses on the south side, and earth tubes for cooling and ventilation. Once energy demand is reduced, it's cost-effective and practical to supply the smaller energy demand with solar panels and wind generators. There are 15 homes in Abundance Eco Village now, but when it's fully built out, there will be 30. One way to lower the ecological footprint of a house is to make it smaller. This house is an example of the not-so-big house concept. The owners moved from a 5,000 square foot house to this 800 square foot, well-designed house in the Eco Village, and they prefer it to their much larger old house. Do green buildings cost more? Well, it varies widely. Typically, there is a 10 to 20% premium for building a high-performance building. Green buildings use better quality, long-lived materials that sometimes cost more up front. But that increased cost is paid back in terms of increased comfort, energy savings, water savings, and maintenance cost, just as with solar panels for solar energy. There are two basic approaches to green building: natural building and high-performance conventional building. Natural building uses locally available, lightly processed materials. High-performance building uses conventionally available materials and building science to create buildings that require very little energy to heat and cool. The best buildings are 100% solar heated and cooled. By design, they use 75 to 90% less energy than conventional buildings. Note that some natural buildings are not high-performance buildings. They take considerable amounts of energy to heat and cool, and some high-performance buildings are not made with natural materials. Let's look at natural building in a little detail. Natural building uses lightly processed, locally sourced materials like straw bale, cob, rammed earth, adobe, wood, and stone. Earth plasters can be used for walls and floors. Some combination of clay, fibers like straw, and sand are common ingredients in natural building. Often, these structures are owner-built or involve a community building effort. My friend Susan in Fairfield and her husband John are building their own home and using lightly processed, locally sourced materials like straw bales, local timber from their land, and earth plasters. The Great Courses crew and I visited her home to see how she mixes and applies her own homemade plaster to the outside of the home.
Hi, my name is Susan. Welcome to the farmhouse at Hickory Highlands. I'm going to do a demonstration for you of an exterior plaster on a straw bale wall. The base coat has already been applied and is dry. So we're going to wet the wall, and then we're going to do our skim coat of our last coat of 1 clay, 2 sand, and a half a part of a manure straw mix. The manure helps to add a little bit of fiber and water resiliency. So we start with water. I'm going to do about a half of a part. So I'm putting in 1 gallon of sifted clay. This is my own just subsoil here in Iowa. Our subsoil is pretty much pure clay. I put it through a hammer mill to get it all broken up like this. So that's 1 clay, and we'll do 2 of sand. Just going to do a little bit so I can get it mixed up a little bit. This is going to make some noise. So right now we have a half water, 1 clay, and 1 sand. Plaster recipes are quite variable. Depends on your subsoil and how much sand is naturally in your subsoil. You might be adding more sand or less sand to get a good plaster mix. And then we have some lovely cow manure from our sacred cows. And I'm just going to put in a little bit. The water varies, depends on how wet your sand was, how wet your clay was. I'm going to put in some chopped straw. This was also chopped in the hammer mill, nice and little pieces. About a half a bucket when I combine it with the manure. All right, now I'm going to apply it. I have a hawk. I have 3 different trowels. I have a metal trowel, a wood trowel, and a plastic trowel. Wet it. Sticky. So it's going to stick to the wall. You want to dampen your wall first so that your coat that you're putting on will stick. You want to start wetting your wall ahead of time so the water has time to soak in. Many different ways you can do it. You can take it from the front and go up this way. You can take it from the back and go this way. If you're not comfortable going like this, if you're new at it, you tend to drop more on the ground than you get on the wall. So what some people like to do is they just put their hawk right up against the wall and push. Doesn't matter. You just get it on the wall. So if this was a final coat, you would use a steel trowel to make it quite tight, especially if you're inside.
This is not a new or particularly unusual way to coat the walls of a house. About 50% of the people on the planet live in earth houses, and there are lots of examples from around the world. The town of Roussillon in southern France has long been known for the production of beautiful pigments from clay and earth deposits near the village. Both insulation and thermal mass are useful in sustainable building design, but they have very different functions and you can't substitute one for the other. Insulation blocks the flow of heat in or out of a building, and it is typically made from light, fluffy materials. It's like wrapping a building in a nice down comforter. Thermal mass stores energy as it rises in temperature and releases it as its temperature drops. It's used for keeping a space from overheating during the day, storing excess solar heat for release into the space at night. Thermal mass materials are dense and heavy like rock and concrete. In the Sustainable Living Center, the earth block interior walls have 10 inches of insulation on the outside. The earth blocks help keep the interior temperature constant, and the insulation slows the flow of heat in and out of the building. Now, on the other hand, high-performance building uses conventional materials that, for the most part, will be familiar to building contractors and available at your local building supply store. Most building contractors can adapt to the novel ways these materials are used in high-performance building, but it's best to find a builder that is educated about it and committed to it. High-performance building combines intimate knowledge of the climate, the site, the materials, and building science to create buildings that require very little energy to heat and cool. Here's what you should consider in creating a high-performance building. Start with green features that you can get for free. Passive solar design uses common building materials to collect and store energy, provide abundant natural light, and ventilation. Remember, it's passive solar because there aren't any pumps or fans used to move the energy. Common building materials like windows, wood, and massive materials like concrete can be placed in such a way that the building, by design, collects and stores solar energy in the winter and rejects solar energy in the summer. It makes optimum use of the energy that flows over your site in all seasons. It's mostly free because it's just a more intelligent approach to placing building materials that, for the most part, you would have used anyway. You trade more intelligence in design for less building energy use. It's important to consider passive solar in the early stages of design because obviously it's difficult to change the orientation, shape, window placement, and insulation levels of a building after it's built. Here are a few tips for passive solar. First, build a rectangular shape and orient the long side east-west. This maximizes solar exposure for winter and minimizes for summer. Favor window placement on the south to maximize solar gain. Windows need an overhang size to block high summer sun and allow low winter sun to penetrate deeply into the building. 10 to 15% of building floor area in south-facing windows is about right. You can overdo this and cause the building to overheat during the day and use too much energy at night, so pay attention to your measurements. Locate heavy materials like concrete and tile where the sun will shine directly on them to help store solar energy for use at night. The sun spends a lot of time shining on the west side of a building during the summer. Minimize windows on the west to avoid heat gain in the summer. Daylighting is the art and science of lighting buildings using sunlight. As you saw in the classroom video, for daylighting, windows need to be placed to allow indirect sunlight into the room. Direct sunlight is too intense. Daylight windows are often placed higher, with view windows at a lower level. You will have to spend a little extra money for insulation. For the colder parts of the U.S., you want about 12 inches of wall insulation and 20 inches of insulation in the ceiling or attic. Remember that the extra money you spend on insulation can often be recouped through savings in downsizing or eliminating the furnace. Seal the building tightly and provide fresh air using an air-to-air heat exchanger. Air-to-air heat exchangers allow the heat in exiting warm air to be passed by incoming cold air, allowing abundant fresh air with a minimum energy penalty. These guidelines apply mostly to new construction. I'd like to make a distinction between energy conservation and energy efficiency. Energy conservation is doing less with less, having a colder house to save energy, freezing in the dark. You might also want to consider modest lifestyle changes, these energy conservation measures, like wearing a sweater and adjusting the thermostat higher or lower. It couldn't hurt. But energy efficiency is doing more with less, having a more comfortable house that uses less energy, hot showers and cold beer, just being smarter about how we heat the water and cool the beer. In keeping with the theme of sustainable living as a radical redesign for a better way of life, we're going to consider some of those energy efficiency measures next. Start with a professional high-level energy audit. This is different than most free walk-through audits offered by utility companies. Expect the audit to take most of the day and cost $300 to $500. You'll get a prioritized list of options for improving energy efficiency and comfort, as well as an estimate of energy savings for each option. What can you do with what you got? How can you retrofit a home or apartment for sustainable living? I have to be honest with you. Retrofitting an existing home to a high-performance standard can be difficult and expensive. We talked about some ideas in our lecture on energy, and here are a few more. Cutting down air leakage. Do weather stripping. Often utility companies have incentives to help pay for this. Caulk around windows. Put on seasonal storm windows and weather strip around the doors. Seal the holes in your house. Seal around pipes, wires, electrical outlets, and other penetrations. The next thing to do is add insulation. Attics are easy places to add more insulation. Aim for R60 in the attic and R40 in the walls. R value is a measure of the ability of a material to block the flow of heat. Higher numbers are better. Cellulose, made from old newspapers, is a common attic retrofit insulation. Attic insulation is a good do-it-yourself project, and most places that sell cellulose insulation will loan you the machine that blows it into the attic. Be sure to seal up any leaks from the house into the attic before adding insulation. If your house is old and doesn't have any insulation in the walls, you can blow cellulose or foam into the walls. Unlike attic insulation, though, wall insulation is best done by an experienced installer. Replacing windows can be pricey, so consider insulation first. The next thing to consider is improving the efficiency of your heating and cooling system. Seal the heating and cooling ducts. Test to see if your furnace is operating at peak efficiency with a combustion efficiency test. It's also important to check that sealing air leaks doesn't trap combustion gases in your home. Retrofitting an existing home is not easy. The most efficient way of doing so is an area of continuing research. Now, speaking of furnaces, let's look at a couple of other heating systems. Wood is stored solar energy and makes a good backup heating source for passive solar homes. Modern wood burners are efficient and clean burning. I use a wood-burning stove as the only source of heat in my well-insulated straw bale home. If you use solar electricity, consider mini-split heat pumps. Mini-splits take 1 unit of electricity and produce up to 3 units of heat and provide efficient cooling as well. I'm designing a new home for my family, and it will be heated and cooled by a mini-split powered by solar electricity. Ground source heat pumps are expensive at the small capacities needed for low-energy homes, but can work well for larger buildings. Ground source heat pumps use the stable temperature of the earth at depths of 8 feet or more to provide heating and cooling. Buildings and cities have a huge impact on human well-being and sustainability. The biggest part of our ecological footprint comes from the built environment. Using the principles outlined in this lecture, you can begin to see how we can build buildings that are regenerative, that give back more than they take, that are sustainable. My wife and I ran a small organic farm for a few years. It was physically challenging, but it was also some of the most intellectually challenging work I have ever done. I had to understand and apply, in the moment, a wide range of fields, including biology, ecology, engineering, technology, and marketing. The farm would teach me new lessons every day, new observations of nature to integrate and understand. It was at least as challenging as the technology development work I'd done before in renewable energy, telecommunications, internet, and computers. Like my organic farm, creating sustainable landscapes is knowledge-intensive and multidisciplinary. In this lecture, we'll explore sustainable landscapes. We're used to thinking about getting food from a garden, but there is so much more that sustainable, functional landscapes can do. Sustainable landscapes are those that work within the natural cycles of soil fertility and rainwater, without toxic chemicals. Functional because they are not only beautiful, they also provide for human needs. Here are some of the things our landscapes can provide our households and those of our neighbors if we design them to do so. Herbs for use in teas, tinctures, creams, and salves. Craft materials like basketry and weaving materials, beading materials and soaps. Paints and dyes, glues and adhesives. Water services like infiltrating stormwater and purifying polluted waters. Perfumes and fragrances. Building materials like bamboo, willow, and lumber. A well-designed, functional landscape can also attract or repel wildlife, beautify your home surroundings, and help meld the inside living space with the outside, increasing the amount and quality of space in your home. They can also screen out unwanted views and noise. Geoff Lawton, a well-known Australian permaculture designer, refers to the regenerative power of biological systems when he states, "We can fix all the world's problems in a garden. You can solve them all in a garden. You can solve all your pollution problems and all your supply line needs in a garden." Permaculture is an attempt to design human habitats that have the stability, diversity, and resilience of natural ecosystems. It was developed by Bill Mollison and David Holmgren in Australia and has a strong emphasis on creating landscapes around homes and cities that meet human needs. George Washington Carver was an early pioneer in getting human needs met in a garden. Born into slavery in 1861 and educated at Simpson College and Iowa State University, Carver dedicated his life to improving the life of small farmers by enabling them to meet their needs from products from the farm without having to participate in the cash economy. Carver developed thousands of new uses for plants, including soap and ink from peanuts, a building wall system made from cotton stalks, and 75 products made from pecans. The first thing you want to do is to look at your soil. Soil is a complex mixture of minerals, organic material, water, and life. My microbiologist colleague Elaine Ingham named it the soil food web, and it is the foundation of the web of life. We're used to thinking of soil as a lifeless substrate for growing plants. We treat soil like dirt. Well, dirt is inert, but healthy soil is teeming with life. A single teaspoon of soil holds up to 1 billion bacteria, several yards of fungal filaments, several thousand protozoa, and scores of nematodes. These microorganisms are supplemented by larger creatures like worms and millipedes. Charles Darwin wrote this about worms. It will be difficult to deny the probability that every particle of earth forming the bed from which old pasture land springs has passed through the intestines of worms. When organic matter and soil pass through earthworms' guts, nutrients are put in a form that is readily absorbed by plant roots. Worm poop, or castings, are a mix of soil, beneficial microorganisms, and organic substances beneficial to plants. They're a great plant fertilizer and soil enhancer. Worms create tunnels that allow for water, air, and root movement in the soil. Worms incorporate organic matter deep into the soil and move buried nutrients closer to the surface. Darwin estimated that earthworms turn over the top 6 inches of soil every 20 years. An acre of land can contain up to 1 million earthworms. A ton of cows in a field depends on several tons of earthworms that are below the surface. Want to encourage earthworms in your soil? Well, provide plenty of organic matter for them to eat, preferably applied as surface mulch. Worms love newspapers, so recycle your newspapers in your garden as mulch or shred it for the compost pile. And worms need undisturbed soil. You can gently aerate soil with a broad fork, but aggressive tilling is not good for luring worms. Research on the soil food web in the last 20 years has demonstrated that plants get what they need to be healthy through their relationships with life in the soil. Plants take sunlight and create complex chemicals like carbohydrates. Soil microorganisms cooperate with plants by converting soil nutrients into forms plants need in exchange for complex carbohydrates the microbes need. Ever wonder why young trees can grow green and healthy in the shade below mature trees? Well, young trees have been found to get up to 60% of the photosynthetic products they need from the larger trees through the mycorrhizal fungi networks surrounding their roots. Some mycorrhizal fungi even penetrate the cell walls of the roots as part of their symbiotic relationship. The largest single living organism found to date is a fungi covering 2,384 acres of forest in Oregon's Blue Mountains. It's estimated to be at least 2,400 years old, but may be as old as 8,650 years. Mycologist Paul Stamets has some basis to his claim that fungi rule the world. The sustainable approach to soil fertility is to take care of the life in the soil, then the life in the soil takes care of the plants. What can you do if your soil is deficient in soil life? The simple answer is compost and organic matter. Learning to make good aerobic compost, teeming with beneficial microorganisms, is a key skill in sustainable gardening. Now, aerobic means in the presence of air, and anaerobic means that air has been excluded from the process. The majority of beneficial microorganisms are aerobic. Let's take a look at what goes into making good compost.
Hi, my name is Zach Wright. I'm the director here at the Living Soil Compost Lab in Fairfield, Iowa. And today I'm going to show you how to make a bacterial dominant compost pile. Now, why I'm choosing a bacterial compost pile is because we want to grow vegetables. And vegetables, they need something more bacterial versus fungal. My ingredients include comfrey and weeds chopped from around the area. This is my green material. This is my brown material, mulch. This was harvested from the local municipal mulch waste pile, so free and free. And my third and crucial ingredient, beer mash, which is our high nitrogen component. So basically, to make this pile, we have a recipe. And because we're going for this particular recipe, we're going to look at this in proportions. 20% high nitrogen, 30% woody mulch, and 50% our green material. This is going to achieve ideal conditions for a bacterial compost pile. So basically, I'm going to take 5 scoops of the green material, then 3 scoops of the woody material, and then 2 scoops of beer mash, which I'm going to sprinkle onto the pile. Once I have those all mixed together, I'm going to hydrate them. Now, something to be careful when hydrating and using tap water is tap water can be conditioned with things called chlorine and chloramine. Chloramine is a chemical that will essentially kill biology. Because we're after biology, we treat our tap water with humic acid, which is derived from the compost. We're going to continue building the layers of the pile until we reach our desired size or we've run out of materials. And this is called aerobic thermal composting. And we hope to have a finished product under 4 months. So I'm here with a 9-day-old aerobic thermal compost pile. And 9 days ago, we put our green material, our brown material, and our high nitrogen material together in a particular proportion. And 9 days ago, it was about this tall. And so already we've decomposed the organic matter down to, I would say, at least half, if not more than half of its original size in only 9 days. We have created an environment for the microorganisms to decompose as rapidly as possible and convert our organic matter into humus, essentially. In order to meet organic regulations, we have to monitor the temperatures and the moisture as well. So depending on your high nitrogen component, you're going to be turning this. You're going to be actively engaging this pile for the first 15 days. But this is to ensure quality, and this is to ensure safety, because we want to kill any sort of pathogenic organisms that might be in our material. So after our aerobic thermocompost pile has gone through all the necessary conditions that it's needed for decomposition, for rapid decomposition, we take a product like this, we take materials like this, wastes essentially, and convert them into a finished product such as this in as little as 3 months. Teeming with microbiology, aerobic microbiology, which is essential for plant life, and well, it trickles up back to us.
Compost and organic matter are the keys to healthy soil life and good soil tilth. Good tilth means that the soil has structure that encourages plant growth. Aerobic compost teas and extracts can make a small quantity of compost go a long way. Good compost tea can be sprayed on leaves to control diseases. The beneficial organisms colonize the leaf surface and outcompete the disease-causing organisms. Here's Zach again to show us how to brew a small batch of compost tea.
So basically we're going to be making compost tea now. So all we need is a 5-gallon bucket, a pond pump, and then a little apparatus or something to hold our tea bag inside of our brewer that we're aerating. So we fill our 5-gallon bucket with tap water. Now, depending on what your tap water is treated with, be it chlorine, chloramine, it is advisable to treat the tap water with some sort of carbon filter. We at the Living Soil Compost Lab use compost as our carbon filter. We basically run the tap water through the humics that are in our compost, and those humics complex the chemicals that are used to treat our water. Because basically treated water is sterilized water, so it actually works against the biology that we're wanting to promote. So once we've treated our water by running our tap water through our compost carbon filter, then we take 2 to 3 pounds of high-quality biological compost, and we put it into a tea bag, and we submerge it into the water for 24 hours. After 24 hours, we have 5 gallons of high biological compost that we can then apply to the foliage of any plant.
The compost process generates heat as a byproduct. It's possible to make use of this heat for hot water, buildings, or greenhouses. Ben Falk of Whole Systems Design has created a hot spring in the winter in Vermont using water heated with compost.
Good. This is our Vermont-style hot spring, powered by rotting wood chips and horse manure. Before running it into raised beds in the greenhouse, we're testing it in a little hot tub setup here, just to see how much hot water we're making. Here's the greenhouse at the Whole Systems Research Farm. We finished in the fall 2012. It's designed to be passively heated via the sun and earth coupling only via ground temperature, because the ground is a lot warmer than the air for nearly the entire winter here. That'll also help cool it in the summer. And then since we have a need for constantly growing soil anyways, and there's a lot of wood chips available for free nearby, people are always chipping up trees and dumping them. We take those chips, we pile them up, we compost them, and we also harvest a lot of horse manure that people give away for free. This is about 12 to 14 yards of wood chips and sawdust. The rest is horse manure, about 3 more yards of horse manure. We put 800 feet of 3/4 inch poly tubing in the mound as a heat exchanger. Pump water through all that tubing, it picks up the temperature, goes from about 45 degrees from the ground, where it comes from, which is our well. When it comes out of the mound, it's about 140 to 145 degrees. Wow, that is hot. Hot water coming out of compost. Just an amazing thing that there's that much biological heat coming out of this mound. And that there's all these compost piles and piles of wood chips rotting, wasting all of this heat. This is precious, amazing heat source. Tapping off of a compost pile. Being outside on a sunny day with 2 feet of snow on the ground, it's 20 degrees. There's plenty of warmth to go around. Multiple functions from single elements. Not a bad way to go, really.
Now that we understand the basics of the soil food web, let's explore some sustainable plant selections. You'll need to select varieties that can withstand the winter temperatures in your location. The USDA has established plant hardiness zones that range from 3, the coldest, to zone 10, the warmest, in the continental United States. Plant hardiness zone ranges are available for most plants from a variety of sources. Be sure you're planting from an up-to-date zone map. There are 2 basic kinds of plants for your landscape. Annuals, which need to be planted from seed every year, and perennials, which are planted once and then provide a yield for many years. There is also a kind of hybrid, annuals that self-seed heavily and come back every year like perennials. Now, most vegetables in the grocery store are annuals, and most fruits and nuts are perennials. Sustainable gardening puts a focus on perennials as a way to maximize results you get from the effort you put into gardening. The Land Institute in Lenexa, Kansas is working to develop perennial versions of all the main grain crops, including wheat, sunflower, rice, and corn. Perennial plants have deep roots compared to annuals. Deeper roots mean resistance to drought and the ability to access nutrients deeper in the ground. Deeper roots can take advantage of a wider scope of soil. Now, perennial grains would allow grains to be grown in perennial polycultures, mimicking the prairie. Polycultures are groups of plants that have a synergistic effect when grown together. For example, growing a nitrogen-fixing plant like clover along with wheat minimizes the need for nitrogen fertilizer. Monocultures or monocrops are plantings that feature just one species. Monocrops tend to be more susceptible to disease and insect problems. Most natural ecosystems are diverse polycultures. One of the problems with our commercial approach to agriculture has been its focus on monocrops and monocultures. It's a perfect example of working against natural principles rather than working with them. Sustainable agriculture focuses on polycultures for these reasons. Although most of the perennials that are familiar are berries, vines, fruits, and nuts, there's a surprising number of perennial vegetables. Some are more familiar than others, like asparagus, sorrel, and artichokes. Good King Henry's leaves cook up like spinach, and its shoots can be used like asparagus. With daylilies, the unopened buds can be sautéed with a little butter and salt. The flowers are good in salads, and the tuberous roots can be cooked like the buds or roasted with oil and seasonings. Jerusalem artichoke is a delicious tuber with no relation to the artichoke. Now, many herbs are perennials in most parts of the U.S., or they're self-seeding annuals, things like chives, garlic chives, thyme, and French tarragon. In addition to their return each year, another advantage to planting perennials is that they get a head start in the spring, extending the season. Trees can require a lot of work. They need to be mulched, fertilized, and protected against insects and disease. What if we could get the needs of the tree met instead by other plants? A group of plants that work together to meet mutual needs is called a guild. A guild typically has a central plant and a group of plants that cooperate to meet the needs of the central plant. Guild plants should include a nitrogen-fixing plant, which takes nitrogen from the air and makes it available to the main plant. Nitrogen-fixing plants include beans, clover, and trees like honey locust. A mulch plant provides mulch to conserve water and smother weeds. Comfrey can be cut back several times a season for use as mulch. Insectary plants attract beneficial insects and repel damaging ones. Members of the umbelliferae family, like fennel, coriander, dill, Queen Anne's lace, and wild carrot, attract predatory wasps. Grass border plants keep out grasses, which have a negative effect on fruit tree growth. Comfrey and daylilies can be planted in a ring around fruit trees to keep out grasses. And dynamic accumulators mine nutrients deep in the soil, and when you mulch with them, they make the nutrients available at the surface. Comfrey is a dynamic accumulator of calcium, which is an important in a grass border plant. The principle of ecological design at work here is to use biological systems rather than mechanical ones whenever possible, because biological systems can use sunlight to self-organize. There are a wide variety of unusual fruits for the home garden. Many of these fruits have superior flavor and nutrition than commercial varieties, but they have characteristics like not shipping very well that make them difficult to grow commercially. The only way you can enjoy many of these fruits is to grow them yourself. Let's talk about some of these lesser-known fruits. Pawpaw is the northernmost member of the sugar apple family. Pawpaw is a tropical fruit hardy to zone 4 and 5. The tree fruits reliably as far north as Madison, Wisconsin. Pawpaw has a creamy, custardy texture and an exotic tropical fruit flavor. It makes a delicious ice cream. If you try one, peel off the skin and discard it. The skin's really not good to eat. American persimmons are golf ball-sized persimmons that must be ripe before eating, otherwise they are extremely astringent. They're smaller than the persimmons you sometimes see in the grocery store. American persimmons ripen late in the year, October into November in Iowa. Fruits are sometimes improved by a frost. I've eaten them off the tree in late November after 5-degree temperatures. Jujube, or Chinese date, has a date-like fruit that dries on the tree. Supposedly hardy only to zone 6, they do well in town in Fairfield, Iowa, which is a cold zone 5. This is an example of the microclimate effect. You can manipulate areas of your yard so that plants technically outside of your growing area can sometimes survive. I can't make promises, but just as there are ways to situate a home for better use of solar energy, there are strategies for situating plants in your yard. Well, what if you don't have room for fruit trees, live in an apartment, or rent? You can grow a surprising variety of fruits in containers, and you can grow fruits that are tender for your climate and bring them inside in the winter. I do this with figs in Iowa. You can also consider supporting the planting of public fruit trees in your community if you want to cultivate fruit but don't have the room for trees. My community created a 2-acre community orchard in a public park. The benefits of this public orchard will be enjoyed by residents for decades. This project was spearheaded by our local city sustainability coordinator, who is also an Iowa State University extension agent.
Hi, my name is Scott Tim, and I'm a field specialist for Iowa State University Extension and Outreach. I'm the sustainability coordinator for the city of Fairfield, and my job is a partnership between the city and Iowa State University, and this is the Fairfield Community Orchard. Essentially, what we had to do is choose a site that was really had a lot of moisture in the soil. So we have this spot that's right next to the creek, and it has a marsh behind it, but yet the drainage here is really nicely, so we don't have pooling and ponding of water. We also chose this site because the Fairfield Loop Trail runs right along the edge of the orchard here. So there's a lot of traffic, a lot of people who are coming by who have access to the fruit and the nuts and the things that are being grown in this orchard. We also chose this site because there is a senior citizen center just uphill, and they have a lot of water that's coming off their roof. So what we've done is we are able to harvest the water that's coming from that roof into a large tank, and we have a drip irrigation system. So you can barely see some of the lines that are still here. We trenched and ran drip irrigation tubing, and then they call spaghetti tubing, that runs up to each of these trees. So in years when it's really dry, we can pull water and store it, and then use gravity to bring it down. Or if we want, like I mentioned, there's a creek that runs past here. We can also pump water up from the creek actively into all of these trees. These trees were all bare root trees, and so essentially we had to be very careful getting them into the ground and really care for them. There are a lot of deer in this area, so we also needed to surround each of these trees with posts and wire cages to keep the deer from grazing them too heavily. Every year now we're going to expand those cages so that the trees can get larger and larger. This site has quite a bit of slope to it, and so we've planted trees that need less water, that are much more drought resistant up high, and then trees that can handle a lot of water. Things like mulberry and pawpaw and persimmon, they're all down low where we may get some standing water if there's quite a lot of rain. So we thought not only about the traffic and the slope, but we also really wanted to be careful in the species that we selected to make sure that they would be able to survive specific to where they're planted in this site. We have 150 different fruit and nut trees. Apples, pears, we have chestnuts, persimmons, pawpaws, apricots, mulberries, peaches, plums. There's really an incredible variety of trees in here. And we also really wanted to plant a wide diversity because we're not sure what's going to do really well. And so having a wide variety of trees, whether you're planting an orchard or planting for energy efficiency, it's really important to plant a diversity. Once we cleared out this field and we tilled and planted all the trees, we then wanted to have a nice ground cover. What we have here is a lot of clover. It's a nitrogen fixing clover, and that really helps to encourage the fertility of the soil. In addition, we mulch heavily. So every year, twice a year, we come in and we mulch and sheet mulch around every one of these trees. That really helps keep and lock in the moisture over the winter, but it also is helping to build the richness of the soil.
Another community effort in Fairfield was the Edible Cityscapes project, which allowed residents to buy fruit trees at a discount. Over 3 years, 4,000 fruit trees were placed in backyards and along the street in my small community of 10,000 people. If you have a yard full of ornamental fruit trees, you should know that ornamental fruits can be grafted so that they yield full-size fruits. Here's the story of some guerrilla grafting that happened in Fairfield a few years ago. My community has a monthly art walk that draws thousands of people to the area near the Art Center. 3 students from a public fruit group, Avi, Dora, and Brian, dressed up to vaguely look like park rangers with khaki pants and a Smokey the Bear hat. They offered a grafting workshop that looked like it had been planned as part of the art walk. It hadn't. By the end of the evening, they had grafted a dozen or so scions of full-size pears onto the ornamental pear trees. Here's a short video of Brian demonstrating his excellent tree grafting technique. You will need a sharp knife and some grafting tape. You can buy special grafting knives, but the utility knife that Brian is using here works just fine. A diagonal wedge-shaped cut is made on the scion and on the tree branch. The branch on the tree and the piece that will be grafted, called the scion, need to be the same diameter. The cambium layer of the tree and the scion need to line up. The cambium layer is just under the bark. For successful grafting, the cambium layer of the tree and scion must grow together. A slit is made in the face of the wedge on both the scion and the branch. The 2 slits are slid together and interlocked, making a graft that has good physical strength as well as a lot of contact area. The graft is then wrapped with grafting tape. Grafting tape holds the graft in place and prevents it from drying out until the cambium layers have grown together. Now this type of graft is called a whip and tongue graft. Now here's what the graft looks like after a couple of years. The branch and the scion have grown together, and you now have one tree with 2 different varieties of fruit, maybe one that bears early and one that bears late. In this case, we have both ornamental and Asian pears on the same tree. Trees that are going to be grafted need to be closely related, so apples will graft onto apples, but not onto pears. While the details of grafting can be complex, the basic skills are pretty easy to pick up. Another way to connect with your food is to learn about the wild edible plants and mushrooms that grow where you live. Of course, you need to be careful with mushrooms, as some deadly species resemble edible ones. My wife is from France, and she liked to forage for mushrooms in the forest near where she grew up, about an hour outside of Paris. France has implemented a novel solution to the problem of identifying mushrooms. Just take them to a pharmacy. Pharmacists in France are trained to recognize mushrooms. Many people forage for mushrooms in France, and even small towns have a pharmacy. You may find useful plants right in your own neighborhood. While working on this course, I was surprised to find these linden trees in blossom just outside the great course's offices. The flowers of the linden tree make a great, relaxing herbal tea. Other common wild edibles include lamb's quarters, dandelion, cattail, and burdock. I suggest you look on the internet to research wild edibles for your area and how to use them. Landscapes can be designed to provide a wide variety of products and services for humans and wildlife. If we make our landscapes beautiful and functional, many of our needs can be met right where we live. In this lecture, we'll look at becoming part of the process of bringing your food to your fork. Eating is an agricultural act, and in this, we're all farmers. Some of us are just doing our harvesting at the supermarket. Sustainability is about making the transition from being a passive consumer to being an active co-producer of your food and other essential elements of your life. This transition involves learning about new gardening philosophies with new terms like eco-gastronomy. These new philosophies are behind new social movements like the slow food movement and growing food at home, whether home has space for an in-the-ground garden or plants in containers. I'll talk about simple methods of growing something fresh for your table 365 days a year, even if you live in an apartment in the city. I'll show you interesting ways to mimic nature to start productive gardens that require only a few hours of enjoyable labor per week to establish and maintain. We can't cover all the details of growing your own food in this course. For more detail, check out other great courses that cover gardening. First, let's talk about eating. Food is always better when it's fresh and local. The pleasure of eating is a basic human right. And Carlo Petrini, founder of Slow Food, says gastronomy is the other half of sustainable agriculture. I love Slow Food's approach to sustainability, environmental activism, and eating. The slow food movement goes about its work from the angle of enhancing pleasure, sensuality, and community by advocating for food systems that are good, clean, and fair. What do I mean by good, clean, and fair? Well, good, food should taste good, or what's the point? Clean, food should be free of poisons and shouldn't pollute the earth through its production. And fair, the producer should earn a living wage and its cost should be affordable. Pleasure at the table shouldn't be reserved for just the wealthy. Petrini describes eco-gastronomy and contrasts it with a more conventional understanding of gastronomy with the following quote: "I am a gastronome. I like to know the history of a food and of the place that it comes from. I like to imagine the hands of the people who grew it, transported it, processed it, and cooked it before it was served to me. I do not want the food I consume to deprive others in the world of food. I like traditional farmers, the relationship they have with the earth, and the way they appreciate what is good. The good belongs to everyone. Pleasure belongs to everyone, for it is human nature." This is from Carlo Petrini's book, Slow Food Nation. Pleasure at the table as a basic human right demonstrates a new approach to sustainability. Eco-gastronomy and sustainable gardening are examples of how living more sustainably, again, means a richer life, not a diminished one. The fact that agriculture is one of the most destructive forces on the planet yet is primary in sustaining human life, is a central paradox of modern life. It's why so much attention is placed on sustainable agriculture. But it can be confusing trying to sort through all the claims made about the food we eat. Here's a way of understanding the differences between those claims about food. I've adapted this from Eliot Coleman, an author and one of America's best small farmers. Locally grown organic food is like listening to great musicians perform live music in an intimate, informal setting. Cafe Paradiso is a small cafe in my hometown that seats just a few dozen people. I've had the opportunity to sit right next to world-class musicians at the cafe while they are performing. No microphones, nothing between me and these pure sounds. And I could practically nourish myself on it. That's locally grown organic food. If I listen to the same performer in a large concert hall through a sound system, that's California organic food that's been shipped in. If I listen to that same performer on a disc or MP3, that's canned or frozen food. And finally, if I hear that same performer playing the same music on a car radio with a fading station, that's fast food. Food isn't all the same, and the best stuff is grown at home. So how can you find time to become more involved in the food you eat? Remember, not long ago, email and the internet didn't exist. Yet we've all found plenty of time to devote to that. Our lives change as our worldviews and our priorities shift. You can start small, and even just getting to know someone who produces your food, maybe one of the regulars at a local farmer's market near you, just that starts to make you part of the cycle. So let's discuss this idea of getting more involved with your food. Want to grow some of it? It's one of the most satisfying activities that I have ever been engaged in. You learn firsthand about sustainability by engaging, even in a small way, in the cycles needed to produce some of your own food. Farmer Eliot Coleman argues that getting involved in growing some of your own food is like raising your children or developing and maintaining friendships, an essential human activity that you can't satisfactorily hire someone else to do for you. When I first started to grow my own food, I got all excited and wrapped up in the idea of a big garden with the goal of growing all my food. What I discovered is I didn't know what to do with a big garden. It was in an out-of-the-way location, so I had to make special visits to work on it. I didn't know how to manage the inevitable weed and pest problems that developed. I didn't have an easy way to water it during dry times. It became a drudgery, and before the season was over, I abandoned it. I still got a yield, but it was way out of scale with the work involved. One of the most important decisions you will make about growing food is what scale to start with. It's always better to start small and get a satisfying yield. This is another principle of ecological design. Start small and build on success. You can expand as your skill and confidence develop. Have a goal that you eat something that you grow every day. This might mean just a sprig of parsley for your soup or a handful of sprouts. What you grow should be located in a place you pass by several times a day, so it's in the flow of what you do and not something that requires a lot of extra effort. The ability to regularly observe what is going on in your mini farm is important to the pleasure you get and the overall success of the project. There's an old proverb that says the best fertilizer is the footprint of the farmer. This illustrates yet another principle of ecological design. Place design elements that require more attention in areas visited most often. So place your garden where you'll pass it by, maybe near the front door of your home or the door near your kitchen. There are many different gardening philosophies with strong adherence and good results. I'll discuss a couple of them next, and then I'll show you a unique method of low-work gardening based on what's called sheet mulching. The first philosophy I'll talk about is one developed by John Jevons and his colleagues at Ecology Action. They have spent 40 years developing an elegant, small-scale farming and gardening system called Grow Biointensive. When practiced correctly, it nurtures healthy soil, produces high yields, and conserves resources. Gardeners and small farmers have used it worldwide. And check out Jevons' book with the long title, How to Grow More Vegetables Than You Ever Thought Possible on Less Land Than You Can Imagine. His methods derive in part from the intensive market gardens that developed around Paris in the 18th, 19th, and early 20th centuries. Growing with the biointensive method requires a lot of work up front, digging to a depth of 12 inches and loosening the soil another foot. Digging 2 feet down, depending on the nature of your soil, is a lot of work. Might be a good idea to team up with a friend or neighbor, share the work, then share the yield. But the results are impressive. and it can all be done without power tools. Beds are typically 5 by 20 feet, and he has worked out the best plant spacing to maximize the amount of food you can grow on a given space. Jevons' method includes growing the compost crops you need to maintain the fertility of the soil food web as well as the food crops you eat. The soil food web is the complex relationship that plants have with the life in the soil. Compost feeds the life in the soil, and the life in the soil feeds the plants. Compost is made from decomposing plant matter, and if you don't grow something to make compost, you'll have to bring it in from outside. Jevons' method grows a lot of food on a small space. A full vegan diet for a person for a year, including compost crops, can be grown on about 4,000 square feet. In contrast, the average U.S. diet takes about 28,000 square feet. Another popular gardening philosophy and method is square foot gardening, explained in a series of books by Mel Bartholomew. But my favorite gardening books are those by Eliot Coleman. They are a pleasure to read and take a simple, no-nonsense approach to organic, sustainable gardening. In his book, 4-Season Harvest, he details his breakthrough methods for growing in what is normally considered the off-season, fall and winter. We'll talk more about this in the next lecture. He gardens in beds that are 30 inches wide, takes an approach that involves feeding the soil, not the plants, and focuses on plant health to minimize disease and insect problems. So let's talk about how you can get started with a small, low-effort garden. Many of you, no doubt, have a lawn with a lot of grass in it. Establishing a garden on what was previously lawn can be a lot of work. Here's a way to establish a garden in a couple of hours of easy work without pulling up the grass or digging. With this method of gardening, you may not have to water or weed for the entire season. It's called sheet mulching, mulch gardening, or no-till. It's also been called lasagna gardening because the bed is built in layers like a lasagna. Compared to conventionally tilled gardens, it's better for the life in the soil. That's because different soil microbes like different depths in the soil. Tillage mixes up the soil layers, causing microbes to have to reestablish themselves at their preferred depths. For a 4x8 garden, you'll need the following. You'll need cardboard to cover the area, including the 3 to 6 inch overlap between the pieces. This is a great way to recycle those cardboard boxes you receive in the mail. You'll need enough compost or manure to cover the area 3 to 4 inches deep. You'll need straw, hay, leaves, or other mulch material to a depth of 6 to 12 inches. There is some controversy about using hay instead of straw because hay may contain more weed seeds. Well, theoretically, straw is just the stalks of a cereal grain like wheat without any weeds. But where I live, straw often contains seeds of the grain and weed seeds, especially organic straw. Hay is typically a combination of grasses that includes the seeds of the plant that make up the hay. Either hay or straw works well. Use whatever you have available in your area. First, if the grass is tall, either push it over or cut it short. You can leave the clippings on the ground, don't bag them up. Cover the grass with 1 inch of compost. Next, cover the compost with cardboard, overlapping 3 to 6 inches, and then 2 to 3 inches of compost on top of the cardboard. Cover the compost with 6 to 12 inches of mulch. It will be really tall, but it will reduce down after a rain or two. And that's it. No tilling, just pile stuff on top of the lawn. It will suffocate the grass and enrich the soil. It's easier to use starts or seedlings rather than seeds in a garden like this. Once you have built the garden, you can actually plant in it immediately. To plant, pull the mulch aside, cut a hole in the cardboard big enough to fit your plant, and plant in that hole. Pull the mulch back around the plant and you're done. You'll want to water it well after you plant, but after that, check before you water. Chances are that the mulch and hay will keep enough moisture on the plants without watering. That's one of the benefits of this sort of gardening. Earthworms will eventually eat up the cardboard layer, tilling the soil for you as they do. The cardboard provides a barrier to weeds. If weeds do pop through, just smother them with mulch. Books of straw or hay are good for this. In the second year and subsequent year, just add 6 to 12 inches of mulch material to the top of the garden and plant right into it. You can use mulch gardening to compost your kitchen scraps simply by slipping them under the mulch layer. Ruth Stout popularized this method of gardening in a book called How to Have a Green Thumb Without an Aching Back. I love that title. She's used it for more than 30 years, into her 90s, on a large garden in Pennsylvania with no tilling, composting, fertilizing, watering, weeding, or poison sprays. The story is that she was inspired one spring while waiting for someone to come to till her garden. She noticed that the asparagus were doing just fine without the tilling. She wondered if the rest of her garden could do the same. It could. After that spring, she never tilled again and wrote a charming book about her method. Ruth Stout's approach is an excellent example of another principle of ecological design, learning by observing nature. Mulch gardening mimics the natural ecosystem of a forest floor. The forest, like the mulch garden, gets an annual layer of mulch that acts as a weed barrier, keeps in moisture, and does composting in place, adding nutrients that earthworms carry deep into the soil. Bill Mollison, developer of the permaculture system of ecological design, calls this process protracted and thoughtful observation rather than prolonged and thoughtless action. Conventional garden thinking often involves figuring out what more we can do in the garden to improve productivity. Stout and other no-till advocates like Masanobu Fukuoka take an approach to gardening that asks, what less can I do? For answers, these gardeners observe nature to see what additional garden tasks can be turned over to natural systems. It turns out that tilling is one of those tasks we can turn back to nature. I mentioned this before, but it's worth repeating. Start small with gardening, obtain a satisfying yield, and then build on your success. It's pretty hard to keep up enthusiasm for something unless you get a yield. If you've never gardened before, I suggest starting with a 4x4 or a 4x8 garden. Even a garden this small will yield something fresh for the table all summer long, and you can easily cover it with a simple greenhouse to extend the season into the fall and winter. So what should you start with? To obtain that satisfying yield, pick things that do well in your area and learn to like them. In my area, winters include greens like chard, kale, collards, lettuces except during the heat of the summer, potatoes, tomatoes, bush beans, herbs like parsley and basil, and eggplant. If you have trouble enjoying what grows best in your area, check out a few popular cookbooks and learn some new ways to prepare your garden yield. Often what we think we don't like is badly prepared. And remember, growing and eating fresh food is often an entirely different experience than eating preserved food or even produce shipped in and bought from the store. Once you've planted up a nice variety of plants that thrive in your area, how do you nurture them? Like Elliot Coleman, I take a plant-positive approach to insect and disease problems. Keep plants healthy with a vibrant soil food web, avoid monocultures, and rotate crops from year to year. These simple and sustainable practices go a long way toward minimizing problems. Pay attention to the amount of sunlight your plants get, and of course, make sure that they get the right amount of water. If you do get problems, then there are a number of organic remedies, many of which you can whip up in your kitchen. Water and soap will control aphids. A solution of water and garlic in a blender is good for a variety of plant problems. It's beyond the scope of this lecture to go into details on pests and disease, but many non-poisonous and natural solutions for specific problems can be prepared from herbs and other supplies in your kitchen. Here's an interesting tip from French gardeners. Build habitat for a wide variety of beneficial insects. I've seen these in gardens all over France. Your garden should include not only the plants you grow to eat, but also some plants that will attract insects for pest control and pollination. The herb dill, for example, will attract beneficial wasps, not harmful to people, but very helpful for controlling pests. You can dig a small pond and stock it with goldfish. If you don't feed them, they'll snack on mosquito larvae. The pond will also provide habitat for frogs and other amphibians that will patrol your garden for insects. Put up birdhouses and plant flowers to attract birds to your garden. They'll snack on insects as well as add beauty and song to your garden. Bats also help with controlling insect pests. Consider installing bat houses to attract bats to your garden. What if your space is limited but you want to start eating homegrown food? Here are some strategies for growing food in a small space. If access to a garden plot is limited, you can start growing in containers. You can grow a wide range of vegetables and fruits in containers. Here's a crop I grew in a container that required no planting, no fertilizing, and no watering. It's lamb's quarters, also known as chenopodium. It's a common weed. You can use it in cooked dishes in the same way you would use spinach, and it makes an excellent pesto. I originally planted a blueberry in this container, but rabbits ate the plant before I got around to protecting it. In the spring, the container was full of lamb's quarter. There must have been lamb's quarter seed in the compost I used in making the soil mix. I've had dozens of meals from this container of lamb's quarters. My colleague, Dr. Tim Amaya, who developed the organic standards for the country of Bhutan, says the goal of sustainable agriculture is to turn plants into weeds. In other words, food plants should be so healthy and robust that they grow like weeds with little extra care from us. Make a soilless mix. The soil in containers can get easily compacted, so it's important to have a loose, well-drained mix. I use 50% peat moss or coconut coir, at least 25% compost. We'll learn more about making compost later, and 25% vermiculite or perlite. Perlite is expanded, lightweight rock that keeps the mix well drained. Depending on the requirements of the plant, you can add lime, rock powders, and an organic fertilizer. In most cases, it's better not to use soil. Water properly. A common cause of failure in container gardening is overwatering. Use automatic watering systems when possible. Get creative with the use of containers. The lamb's quarter was grown in a container I made from a recycled plastic barrel. The figs are in containers I got used from a nursery, 4 for $3. You can recycle lots of things to use as plant containers. Grow kitchen herbs that are especially good fresh, like basil and parsley. Rosemary is another herb that works well in a container. Keep them close so that you can grab a handful and toss them into your cooking. Use containers to grow fruits that won't grow outside. I love fresh figs, but they are not cold hardy in Iowa. I have friends that get 2 crops a year from their potted figs. Here's a picture of figs for sale at the Jean Talon Market in Montreal, probably the best farmer's market in North America. These figs are far outside the normal range for growing figs. I've bought Iowa-grown grapefruit and bananas at my local farmer's market from someone who grows them in containers outside in the summer and brings them in the winter. Did you know that Louis XIV grew citrus in containers in Paris, which is further north than any place in the U.S.? These citrus trees are in a public park in Paris. Imagine my surprise when I discovered these papayas growing in pots as street plants in Des Moines, Iowa. Where can you find papaya seed? Well, you can buy a papaya at the supermarket, eat the fruit, and plant the seeds. I'd like to take a minute and talk just a little more about seeds. The modern food system is an illusion of choice. There are 35,000 products in your supermarket, but most of them are made from just 4 plants: corn, wheat, rice, and soybeans. But our human cultural heritage is more than 35,000 edible and useful plants. Our ancestors have been selectively developing and breeding these plants since before the dawn of settled agriculture 10,000 years ago. This is an irreplaceable heritage that we share with all humans on the planet. Getting involved in growing some of your food or developing relationships with farmers connects you to this heritage. As seed companies have consolidated in the global marketplace, the seeds of many varieties of food plants are no longer available in the marketplace. You can help preserve our cultural heritage of a wide diversity of food plants by getting involved with a seed-saving organization. Seed Savers Exchange has 15,000 amateur gardener members that are dedicated to maintaining the wide diversity of cultivated food plants. For example, some members grow hundreds of varieties of tomatoes every year and save the seeds. Seed Savers maintains a collection of 700 different varieties of apples in their heritage orchard in Decorah, Iowa. I often bring students to their annual gathering every summer, which brings hundreds of eccentric little old men and women who, again, save hundreds of varieties of tomatoes or potatoes or squashes every year and are just really passionate about it. And it's great to see young people get engaged with these older folks and pass this heritage along. But being a member of Seed Savers Exchange allows you to access thousands of unusual varieties of food plants that are available nowhere else. Getting involved in saving seeds and using heirloom vegetable varieties in your garden adds interest to your garden and a wider variety of flavors to your table. But there is another reason to get involved in maintaining a wide diversity of food plants. Have you ever heard of the Irish potato famine? One of the reasons it was so devastating is that everyone was using the same variety of potato, which lacked resistance to a blight that wiped out the crop in the entire country. We don't know which unusual variety of tomato, for example, might contain a gene that gives traits that may be essential in the future. For example, resistance to drought or disease. Having a wider variety of food plants makes our food system more resilient to the wide range of challenges that may come our way in the future, whether from climate change, disease, or other problems we can't foresee. Lettuce is a great example of a plant family with a wide diversity. There is a surprisingly beautiful range of colors in the lettuce family, ranging from neon green to deep wine red. Buy a selection of colors and plant them in a pot. Neon light Swiss chard is another beautiful plant to use in an edible landscape mix. Edible landscaping can compete for beauty with ornamental gardens and has the added benefit of providing something for the table. No place to put containers? Many cities have community garden space where you can rent a small plot for a nominal fee. Kansas City has a program that gets you a plot, organic fertilizer, water, seeds, plants, and support for $10 per year. Look for similar programs in your city or band together with friends and neighbors on a vacant lot. Can't have a garden or don't want to? Well, even if you live in the city, you can add richness to your life through joining a community-supported agriculture, CSA, or shopping at the farmer's market. In community-supported agriculture, you pay a subscription fee to a farmer in exchange for a weekly box of whatever is fresh and ripe. It's a partnership with the farmer where you share in the bounty of a good year and soften the loss of a bad year. And here's something you probably have never thought of. You can add agritourism to your vacation and travel schedule. Popular in rural Italy and France, it's catching on in the US. Visiting a small food producer or farmer adds richness to your vacation and travel plans. Some farms and producers provide a short tour and sampling of the wares, and others provide lodging and meals straight from the farm. My favorites are wineries, cheesemakers, field-to-table restaurants, and small vegetable producers. You can get ideas on who to visit by asking questions at the farmer's market. Many cities are creating new ordinances that allow small livestock like bees and chickens in urban areas. Bees help with pollination as well as provide honey. If you discover that you like growing food and are good at it, you may want to consider growing extra for sale at the market or even becoming a full-time farmer. Every year, my neighbors, who have a large 40 by 50 foot home garden, grow a little extra butternut squash to sell. This year, they had a bumper crop and sold 400 pounds of surplus squash to a local grocer, which paid for their garden supplies for several years. Jean-Martin Fortier is a great example of the new breed of successful full-time organic farmers. His 1.5-acre farm in southern Quebec grosses $160,000, and he and his family net about 40% of that. Check out his excellent book, The Market Gardener. We often think that large farms are what feed the world, but Vandana Shiva points out that traditional small farmers feed 70% of the world. We can use modern knowledge of organic farming to boost the productivities of these small farms so they can feed even more people. Maybe you will become one of the millions of new small farmers needed in the U.S. to meet the growing demand for local food. In this lecture, we've explored a wide variety of options for becoming more involved with your food as it travels from seed to fork. Food is always better when it's fresh, and the best stuff is grown at home. Sourcing food locally reduces the ecological costs of transporting food. An Iowa State University study found that the average bite of food travels 1,500 miles from farm to fork. The benefits of being involved in local sustainable food production are a clear example of how sustainability is about a better quality of life, not just minimizing ecological impact. I invite you to use the strategies that I've outlined in this lecture to get started with your own sustainable food revolution. In addition, you will learn more about sustainability and the potential for abundance by working with nature from having your own garden than from any other activity that I can think of. If you've got friends with gardens, are a member of a CSA, or regularly visit farmers markets, you know that summer provides an abundance of fresh local produce. But what if you want something fresh for the table in the off-season? Growing off-season in cold climates is one of the most stunning developments in growing food locally. Even in climates like those in Maine and Iowa, you can harvest something fresh for your table all winter long using simple technology that extends the season from fall to spring. In this lecture, we'll explore ways to put something fresh on your table all year long. You'll learn about what Eliot Coleman calls gardening on the backside of the calendar. Now, I've read hundreds of books on gardening and farming, and most are, to be honest, a little tedious. But Eliot Coleman's books are a real pleasure to read, and I highly recommend them. My favorite is 4-Season Harvest, in which he describes the simple but revolutionary techniques he developed at his farm in Harborside, Maine for gardening in the off-season, late fall, winter, and early spring. Eliot's book, 4-Season Harvest, is woven around an engaging story of a trip through southern France exploring winter vegetable production. He tells how he adapted these techniques to his farm in coastal Maine. During his work as the head of the International Federation of Organic Agriculture Movements, or IFOAM, in the late 1970s, Eliot noticed that places like southern France and northern Italy have a long tradition of eating foods available with the season, even in winter. Now note from the map that southern France is at 45 degrees north latitude, further north than most places in the US and about the latitude of coastal Maine, which is quite surprising. Coastal Maine is where Eliot's farm is located, and in fact, most of Europe is further north than the US. Therefore, the good news is most of the US gets more light in the winter than France and northern Italy. And that's good news for winter growing. However, Europe is warmer than the US at equivalent latitudes due to warming by the Gulf Stream. Well, Eliot reasoned that in cold climates we build structures for people, so why not build structures for plants to offset the colder US climate? Eliot's book tells the story of his development of this idea and his visit to France to observe and adapt long-established techniques for winter gardening there. Coleman also drew heavily on the work of Helen and Scott Nearing, and I'd like to tell you a little bit more about Helen and Scott next. Helen and Scott Nearing were pioneers in homesteading and self-sufficiency, early leaders in modern sustainable living. He was a PhD economist, she was a concert violinist. They began their experiments in self-sufficient living, social activism, and nonviolence in the 1930s on a derelict farm in Vermont. When development threatened in the 1950s, they continued on the coast of Maine, where in their 70s and 90s, they started over again, making a new set of buildings and gardens. They wrote a series of books about what they learned, including Living the Good Life, which became a handbook for the Back to the Land movement in the 1960s and 1970s. They developed techniques for building construction using local stone, grew much of their own food, and managed a thriving maple sugar business that provided cash income. One of their experiments was to extend the season in simple, unheated greenhouses. They published a book about their experience called Our Sun-Heated Greenhouse. They began their experiment by accident. One day in early January, they went to the greenhouse and noticed that a, quote, flourishing, lush, and sizable lettuce plant was growing in the ice-cold building. It had survived, untended, unwatered, through several months of outside freezing. Well, they asked themselves, if this could happen uncared for and unplanned, could more lettuces and other plants survive under better conditions without artificial heat? They went on to develop techniques that provided them with fresh, green food through 30 winters of freezing and sub-zero weather by the time they wrote the book in 1977. The Nearings have passed on, but you can still visit the Nearing farm on coastal Maine. It's preserved as the Good Life Center. You can even apply to be a steward, living much as the Nearings did, hosting visitors and tending gardens. The Nearings had discovered one of the great advantages of growing in the off-season: less work. In addition, there is little insect or disease pressure. Low rates of transpiration and high groundwater levels mean little or no watering. In summer, fresh local veggies are readily available from Friends with Gardens or from farmers markets. In the dead of winter, you really appreciate something green and fresh. With all these advantages, you may decide to focus on winter gardening and minimize the summer garden. You don't need a fancy greenhouse. I'll show you how to build a simple structure for under $100 that will allow you to harvest all winter long. Elliot Coleman became friends with the Nearings in the 1970s, and the Nearings sold him the land for his farm. He has become a leader in the organic and local agriculture movements and one of the best small farmers in America. This is an early example of an older generation of sustainability pioneers mentoring the next generation, and the next generation continuing to develop the work of the older generation. I had a chance to meet the Nearings while they were still alive in the late 1970s, and this was an influence on my life and career as well. This influence continues today with a tradition of young people learning the craft of organic farmers by interning on farms run by experienced growers. Elliot's books have gone on to inspire the renaissance in organic vegetable production by small farmers all over North America. Jean-Martin Fortier, as I mentioned in an earlier lecture, is an example of a new generation of organic agriculture inspired by Coleman. He's 35 and he's been farming for 12 years. He's making a good living for himself and his family on less than 2 acres in southern Quebec province. He grosses $160,000 and puts 40% of it in his pocket. If you are interested in becoming a farmer, check out his excellent book called The Market Gardener. Now let's discuss some of the highlights of Elliot's discoveries. I'm also going to give you some tips from my 13 years of experience with off-season gardening. There are 3 main factors to consider in growing in winter. The first is plant selection, second is light, and the third is heat. First, let's take a look at plant selection. You can't grow heat-loving, warm-season crops like tomatoes, eggplants, and peppers with these methods. Elliot and others have identified about 30 plants, mostly hardy greens, that do well in winter production. Here are a few of the plants just to give you an idea. Arugula, mâche, lettuces, escarole, leeks, carrots, tatsoi, and beet greens. Some of these may be a little bit unfamiliar, and we'll talk more about these plants and the planting schedules later in this lecture. It's possible to build more complex and expensive solar greenhouses that attempt to extend the season for warm weather crops. One approach to trying to grow warm season crops in the winter is the bioshelter concept. These greenhouses have insulation on the east, west, and north. Only the south is glazed. They often use compost or animals in the greenhouse to help raise the temperature. They are sunk in the ground because greenhouses that are sunk in the ground can use the stable temperature of the earth to maintain their temperature even on cold nights. Sometimes they are even designed for people to live in them. Check out Anna Eadie's book Sylviva or Daryl Frey's Bioshelter book for more details. There is a farmer that uses these methods in Nebraska that bills himself as Nebraska's largest citrus grower, which must not be very hard to beat. In the 1980s, Chinese farmers developed an unheated greenhouse that allowed them to grow warm season crops in the winter. These greenhouses now cover thousands of acres in China. Their application in the U.S. is an area of active research, and it's something that I'm interested in. My university is developing so that we can take these cold season techniques and bring them to the next level so that we can have a wider variety of crops grown all season long. These systems have a couple of things in common. They are expensive and they fight nature rather than working with it. Here's the first solar greenhouse I built in 1978. Here's a much simpler system I built in 1997, but in many ways more sophisticated, that uses the philosophy of working with nature rather than fighting it. Mulch garden techniques establish the bed without digging up the grass. You can see the cardboard poking out from under the wooden frame. Simple hoops, a sheet of plastic over the hoops, and a lightweight row cover over the plants are all it takes to grow year-round. In the simple systems I'll be showing you how to build in this lecture, we are not doing battle with the cold of winter as one thinks of doing in a heated greenhouse, trying to grow warm weather crops. We're creating a simple, protected microclimate, sufficient for the needs of plants that don't mind the cold. Hardy plants. In addition to heat, plants require a minimum amount of light for vigorous growth. The good news is that most areas of the U.S. have sufficient hours of daylight in the winter for successful winter growing. Let's take another look at the map comparing the U.S. and Europe. Believe it or not, southern France and the Ligurian coast of Italy are at the same latitude as Elliot Coleman's farm in coastal Maine, 45 degrees north. Note from the map that most of the U.S., again, is further south than Europe. Iowa, where I live, believe it or not, is at the same latitude as southern Spain, 40 degrees. What this means is that most of the US gets more hours of winter sunlight than most of Europe, where there is a tradition of winter growing. Elliott has found that when the number of hours of daylight drops below 10, as it does in Maine from November to early February, plant growth slows considerably. But if you get plants to a harvestable stage before then, you can harvest their leaves. Regrowth will be slow until day length goes above 10 hours, again early February in Maine. In this case, you're not extending the growing season in the same way you would with a heated greenhouse. What you're doing is really extending the harvest season. I'll never forget my first experience with off-season gardening. My wife and I were running the farm at Abundance Eco Village. We had visited Elliott's farm in Maine, but only in the summer. We invited him to Iowa to give a workshop on four-season growing, and we decided to give it a try. We were confident it could work, but it seemed too good to be true. Could plants really survive in an unheated greenhouse during a harsh Iowa winter? Instead of closing the farm down completely in late fall, we got one greenhouse ready to grow through the winter using the methods we learned from Elliott. It all seemed really counterintuitive. Instead of pulling plants out of the ground, we were planting seedlings. As it got colder, we covered them with row covers, a lightweight fabric that protects plants in winter while letting in light, air, and water. When the first hard freeze came, it looked like our experiment had been a big disaster. Early in the morning, the plants were frozen solid. We wondered what we had done wrong. Imagine our surprise when we came back a few hours later after the sun had warmed the greenhouse and discovered the lush, green, healthy plants ready for harvest. Years later, it still gives me a thrill to see a cold frame or greenhouse full of greens in the dead of winter, made possible by some simple protection methods and winter sunlight. In summary, there are two tricks to growing off-season. The first is a simple unheated greenhouse or cold frame technology supplemented with floating row covers. This can be done on a wide range of scales, ranging from small backyard structures that cost less than $100 to build to large commercial operations with acres of greenhouse. We do this at my university with our large commercial greenhouse. It's about an acre that feeds our cafeteria. The second factor to consider in winter production is the selection of plants and the timing of planting and harvesting. Let's talk about structures first. Here's one I designed that was built for less than $100. In a few minutes, I'll show you how to build one of these. Here's a 2-acre greenhouse in my town inspired by Elliott's work. A greenhouse like this can provide a good living for a family or small group of people. I'm part of a CSA that allows me to get a box of veggies in January in Iowa picked that day. Here's a greenhouse that was built by a friend of mine from a frame of an old trampoline for a few $100s. Once the outside gardens have stopped producing, it provides hundreds of salads through the fall, winter, and early spring. Just as we build structures for people in cold climates, we need to build structures for plants. The rule of thumb is that every cover over your plants moves them one USDA zone about 300 miles distance further south. But every cover also blocks light, so there's a trade-off. It turns out for most of the US, 2 covers are about right. The first cover is plastic or glass, and the second cover is a special lightweight fabric that rests gently on the plants or on supports just above. Floating row cover goes by several brand names. Unlike plastic, floating row covers let in moisture and air and transmit about 90% of the light. In the early stages, you can put the cover directly on the plants. They'll just lift it up as they grow. Once freezing weather starts, it's better to support the row cover over the plants with simple hoops so that the row cover doesn't freeze to the plant. Earlier, I showed you a wide range of structures for off-season growing. Let's build a simple structure to illustrate how to grow in the off-season, using parts you can scrounge or find at your local building supply store. We'll make a 4 by 8 foot mini greenhouse, but you can modify the size to meet the space you have available. Here's a list of materials and tools you need to build the structure. First, to build the frame for the bed, you'll need 2 boards, 2 by 10 feet that are 8 feet long. Then you'll need 4 boards, 2 by 2, that are 10 feet long for the pieces that'll hold the plastic down. You'll need a sheet of 10 by 10, 4 or 6 mil plastic sheeting. If you have to buy a bigger piece, then you've got a lot extra for future years when you have to replace the plastic, or you can share it with friends. You'll need 4 pieces of 1/2-inch electrical metal conduit, which comes in 10-foot lengths. You'll need 16 2-hole straps for the conduit to connect it to your garden frame. And you'll need about 12 2.5-inch screws, about number 8, and 32 1-inch screws. For tools, you'll need an electric drill, a wood saw, or you can have the lumber yard cut the boards to length for you. And you'll need a special hoop bender if you're using the 1/2-inch electrical conduit for hoops. You'll need a utility knife or scissors for cutting the plastic, and you'll need a tape measure. You'll also need a permanent marker to help you mark out the distances we'll need to mark out when we bend the tubes. Note that you'll have to buy extra of some items. They come in packs that often have more than you need. You can use the extra by getting your gardening friends together and having a mini greenhouse making party. You'll need hoops to hold the plastic over the plants. We'll attach the hoops to a simple raised bed frame. In a garden, you could put the hoops directly in the ground. Build the frame from 2x8 or taller wood. Next, let's build the hoops. You can use a wide variety of materials for hoops. If your garden is in a sheltered spot, you could use stiff wire. About number 9 wire is about right. Galvanized wire will resist rusting. You could also use plastic piping or conduit. But in Iowa, where I live, we have strong winds and violent weather, and I've found from hard experience that wire and plastic hoops don't stand up to the harsh Iowa weather. I use 1/2-inch metal electrical conduit, also called EMT. EMT is inexpensive, about $2.50 for a 10-foot length, and it's really easy to get at hardware and building supply stores. I bend the 10-foot lengths of EMT pipe into hoops with a special bender. The bender costs about $40 and could be used to make thousands of hoops. For this example, I'll use 4-foot wide hoops, but you can also get benders to make 3-foot wide and 6-foot wide hoops. Mount the bender on a sturdy table. A picnic table works, or a piece of plywood. Here we've used a small workbench. Place a mark 16 inches from each end of the pipe. Place the conduit in the bender and slide up to the 16-inch mark. Then bend until the conduit just reaches the holder at the other end of the bender. Pull the conduit out, flip it around, and slide it into the 16-inch mark on the other end and bend the other end around. And grab both ends and gently squeeze the ends toward each other to complete the bend. Sounds complex, but once you've got the hang of it, it only takes a minute or two to make a bend. It's easier to do than it is to tell you to do. Next, we'll attach the hoops to a frame using the 2-hole straps and 1-inch screws. Okay, now let's attach the ends to the mini greenhouse. First, mark and cut the ends out of the plastic. It helps to use one of the hoops as an aid for your marking. Then use special clips or make your own from plastic to attach the tubing to the end of the greenhouse. Put foam pipe insulation over the end greenhouse hoops to protect the plastic. Then finally, we'll put the plastic over the greenhouse. It helps to have 2 people for this part of the process. Cut a piece of plastic 10 by 10. Lay one edge of the plastic along the wood. Lay the second piece of wood on top. Holding the plastic tight, screw the 2 pieces of wood together every 12 to 18 inches. And then repeat this for the other side. This holds the plastic down in windy weather. Then place the plastic over the hoops. And now you can see your greenhouse is pretty much done. The weight of the wood will hold the plastic on the hoops. You can roll the plastic up on the hoops to vent the greenhouse on warm days. If you are placing the frame over grass, there is no need to dig up the grass. Simply place 1 inch or so of compost or manure over the grass, cover with cardboard, and fill the frame with soil or compost. You may remember this from our discussion about sheet mulching. It's amazing to see the rest of your garden dying and going to sleep while the winter garden is just getting started. If you've got the room, you can use a similar process to build a greenhouse you can stand up in. You can also buy kits that have all the parts included. Costs can be as low as $1 per square foot for materials. Now that you know something about structures for off-season gardening, let's look at plants that work well in an off-season garden. First, a review of general principles. The idea with these greenhouses is to work with nature, selecting plants that are cold hardy and adapted to growing in the off-season. Since there is no heat source, at night it will be almost as cold inside the greenhouse as it is outside. Plants for the winter garden need to be able to withstand freezing. As I mentioned earlier, day length is another important factor. Time your planning so that the plants are at the right maturity before day length drops below 10 hours per day and growth slows. Remember, what you're doing is extending the harvest season more than extending the growing season. Going into detail on the proper timing for all the possible crops you could grow is beyond the scope of this course. Check out Coleman's book, 4-Season Harvest, for details. Winter gardening is a solar-driven process. When the sun comes out, the temperature in the structure will quickly rise to the 70s, even on a 0-degree day outside. The amazing thing is that the plants that freeze at night will recover in the warmth of the structure in the next day and can be harvested. But remember, you can only harvest when the plants have thawed. You will be amazed the first time you see dead-looking frozen plants magically recover when the sun comes out. Now, there are a couple of exceptions to the harvest only when thawed rule. Both mosh and tatsoi can be harvested when frozen solid and look perfectly normal after they thaw. So can scallions and leeks, and of course sweet baby carrots, which are hiding in the soil. Spinach and parsley will also recover adequately after being harvested frozen. Most plants are somewhat cold hardy when they are small, so baby lettuces are a good choice. Plants with large fleshy stems, like mature chard, will deteriorate quickly with the freeze-thaw cycles of winter gardening, but baby chard works well. Some plants, like mosh, also known as corn salad, are well suited to winter growing as they are winter annuals and have evolved to complete their life cycle in the off-season. Here are some of my favorites in order of cold hardiness and winter dependability. Mosh, though relatively unknown in the US, is a common winter salad green in France and Italy. It is very cold hardy and you can harvest the whole plant, which is a bit like a miniature head of lettuce. It's one of the best suited plants for winter gardening. Coleman recommends the variety Vite. Spinach is very cold hardy. You can cut the leaves and they will grow back. A good variety for winter gardening is Space. Many Asian greens, like tatsoi and pak choi, are tolerant of cold weather. Tatsoi can be harvested when frozen. Endive, chicory, and escarole tend to be a bit bitter, but less so in the winter harvest garden. They add complexity of flavor to winter salads and are great wilted. Now, it's hard to get red color in winter greens, but the red tops of bull's blood beets are tender when young and make a great red addition to salad. Starchy vegetables like carrots go through a remarkable transition in cold weather. The starch gets converted to sugars, which act as a kind of antifreeze protection against the cold. Eliot calls his winter carrot harvest candy carrots and claims that children will trade candy bars for his carrots. They're that sweet. Here's a couple of other ideas for food production in the off-season. Growing sprouts is another great way to extend the season. You can do it in an apartment, and some sprouts don't even need light. Sprouting increases the nutritional value of a seed and makes it more digestible. Here's a couple of simple methods for growing sprouts at home. Tray sprouts. This is like mini farming. You use a small amount of soil in a shallow tray. Good candidates include sunflowers and buckwheat. Microgreens. These are baby versions of veggies usually eaten at larger stages of maturity. The method used is similar to tray sprouts, a tray with a little bit of soil. The seed can be expensive, and varieties suitable for growing as microgreens include lettuces and broccoli. Finally, you can grow sprouts in a jar. Home-scale sprouting systems are readily available. Consider perennial vegetables to extend your garden season. There are a wide variety of perennial vegetables, things that you plant just once that grow back year after year, sometimes for decades. Some, like sorrel and Egyptian walking onions, are the first green things in the garden in spring. A brilliant green potato sorrel soup is one of my favorite early spring meals. And if you keep the sorrel cut back through the year so it doesn't go to seed, you can actually harvest sorrel from early spring until late fall. Asparagus is a common perennial that provides a welcome early harvest in the spring. Here's a greenhouse that uses waste heat from a factory. The waste heat warms the ground in the greenhouse and keeps it above freezing all winter long. The extra heat makes the plants grow faster, and you can grow a wider variety of plants. The temperature 8 feet in the ground is always 55 degrees. This greenhouse uses tubes in the earth to help moderate winter temperatures and to store excess heat from sunny days. I harvested this salad for Thanksgiving dinner from this greenhouse after a frigid 8-degree night. This greenhouse is a new feature in my community, and it's also used for school children to learn more about growing food. And it works really great because the heat allows the greenhouse to have extended production throughout the time when students are in school. Salads that come out of this greenhouse are served in the cafeterias in our local schools in our community. At whatever level you get involved in the winter harvest, you will discover some of the best food and easiest gardening you have ever experienced. Remember, the winter work is mostly harvesting. In the colder parts of the U.S., off-season crops are planted in the second spring of September and October. Furthermore, there are almost no weeds. The pests have all left for warmer climes, and there is no watering because evaporation is low and soil groundwater table is high. As crops are harvested and empty spaces appear in your home greenhouse, sow more seeds whenever the Spirit moves you. This gives a wonderful sense of the home garden as an ongoing process or cycle, not the start and stop operation it is for people who garden only in the summer. And you can forget about the fall madness of canning and freezing. And remember, Eliot Coleman developed all this in Maine. Over 85% of the United States is further south than Maine, with more sunlight and warmer winter weather. From fall through spring, the amount and variety available from the winter harvest depends on where you live and the severity of your winter weather. Row covers, hardy vegetables, and a succession of fall planting dates is probably all Zone 9 and 10 gardeners need. In Zone 7 and 8, a mini greenhouse alone will work, but adding a row cover under the mini greenhouse will be even better. For Zone 5 and 6 gardeners, the double coverage of inner and outer layers will bring daily harvests that will amaze and delight you. If you live in the frigid mountains of Vermont, for example, in Zone 3, or in far northern areas of the US or in Canada, even the double-covered crops may get beat up a bit during the coldest weather, but the veggies will bounce back as the winter recedes. Before I close, I'd like to point out that growing things out of season is not really a new idea. French King Louis XIV's kitchen garden, called the Potager du Roi, was established in 1668. The head gardener, Jean-Baptiste La Quintinie, was a master at growing things off-season for the Sun King's table. He was able to produce asparagus and lettuce in January, strawberries in March and December, radishes in February, and figs in March, all without fossil fuels. In the 1700s, the gardens even produced 700 pineapples and coffee. Well, how did he do it? Well, he used many of the techniques we discussed in this lecture, but he also used the heat given off by composting horse manure, much like Ben Falk's compost-heated shower we saw in an earlier lecture. Give off-season gardening a try next winter. Start planting during the second spring and enjoy the freshest winter food you have ever eaten. Water is life. Sourcing clean water and using water wisely are key elements of sustainable living. The Earth systems that purify and distribute water are a marvel of nature's engineering. It takes roughly 100 times more energy than the global economy uses to operate these natural water purification systems. They are 100% solar powered, and they provide service free of charge. They're self-regulating, self-organizing, and have operated over billions of years without human oversight. We are interconnected to all the waters of the earth by these systems. The cup of tea you drink almost certainly has molecules that were once in Cleopatra's bathwater. The waters of the planet have cycled through this system countless times. Some of the molecules of water that flow in your blood once flowed in the mighty rivers of the earth. The Mississippi, the Ganges, the Nile, the Amazon, the Rhone. The hydrological cycle shows that the interconnectedness of humans and natural systems across time and space is not only a philosophical concept, it's a physical and biological reality. Collecting and using rainwater, fresh from the sky, celebrates nature's abundance and connectedness. In this lecture, I'll discuss how you can look to nature for inspiration in the design of systems that provide water for drinking, washing, irrigation, and other human uses. We'll also look at ecological approaches to handling stormwater. As we did with energy, we'll look at smart ways to get the same or better services from less water, and then look at sustainable ways to supply this lower demand. The hydrological cycle is powered by a daily input of solar energy, and as I said earlier, uses hundreds of times the energy flow that the human economy uses. It's got entropic elements, where water is distributed across the globe, collects various impurities, and loses some of its usefulness. It's got anti-entropic elements, powered by sunlight, where water is collected and impurities are removed. It's a core ecosystem service of what I call the economy of nature. If nature provides the hydrological cycle, why should we be concerned about sustainability in water? Well, water is a renewable resource, but that doesn't mean that its availability is unlimited. In a given period, precipitation is always limited to a certain amount. The same holds true for the amount of water that recharges groundwater reserves and that flows through a river. Rainwater can be used for agricultural purposes, and water in rivers and aquifers can be used for irrigation, industry, or domestic purposes. But in the long term, we can't take more water from lakes and groundwater reservoirs than the rate at which they recharge. A river can be emptied. We take so much water from the Colorado River that it no longer flows to the sea. We've also got to leave water for the rest of nature. Rainwater not used for agricultural production is left to sustain natural vegetation. The ground and surface water flows not used for human purposes or polluted are available to sustain healthy aquatic ecosystems. Now, domestic water use is only about 8.5% of the total water use, so there is really only so much that you can do at home to directly affect overall water use. But two of the largest U.S. water uses, power generation, that is, the need of large utility power plants to be cooled by fresh water, and irrigation, can be affected at home by generating or buying green power and by growing your own food or buying it locally. When you think about water usage, you need to understand that many products have embodied water, which is the amount of water it takes to produce the product. One tool for making embodied water visible is water footprinting. The water footprint of an individual, community, or business is defined as the total volume of fresh water that is used to produce the goods and services consumed by the individual or community or produced by the business. Let's look at embodied water in food. On average, it takes about 1,850 gallons of water to produce 1 pound of beef. But producing 1 pound of soy burger takes only about 295 gallons of water. In general, vegetable sources of protein take much less water than animal sources like beef. And it takes about 1,000 gallons of water to make 1 gallon of milk, which you might find quite surprising. Energy has embodied water, but water also has embodied energy. Energy and water are inextricably linked. Because water is heavy, it must move through many process steps before it reaches your tap. Public water supply and treatment is energy intensive. Water needs to be pumped from the source to the treatment facility, where energy is used to treat the water. Further energy is used to pump the water from the treatment facility to the customer. The energy intensity of water ranges from about 0.25 to about 3.5 kilowatt hours per 1,000 gallons. Even small community water systems can process billions of gallons of water per year, and this means a lot of energy. Energy is typically the largest cost for public water supply companies. Once in customers' homes, there is more energy used in order to heat water for showers, washing, and cooking. Finally, we use energy to treat and discharge wastewater. In many places, nature provides water for free. The cost of water is related to pumping, purifying, and distributing it. So if you collect and use rainwater, you bypass all that. Here's how water is used in a typical U.S. household. The water use per person is about 80 to 100 gallons per person per day. 70% is used indoors, 30% is used outdoors. There are 4 major considerations for sustainable water use in a typical household. The first is using water efficiently. The next is how we source the water. Third is treating polluted waters. And finally, stormwater management. Let's look at each of these in a little more detail. First, let's look at using water efficiently. As we discussed earlier, using water efficiently saves water and energy. There are a wide variety of technologies that allow you to get the same or better service with less water, like low-flow shower heads and water-conserving toilets. Horizontal axis washing machines, typically side-loading, use half the energy and 1/3 less water than a typical vertical access washing machine, and they also get your clothes cleaner. Here's an example of how we can save resources and have a better service at the same time. So roughly 27% of water used in households is used to flush the toilet, the largest single use. I find it a little ironic that we use a lot of energy and material resources to create fresh water that is ultimately flushed down the toilet. Composting toilets offer an alternative that uses little or no water and recycles waste into a resource, fertilizer for plants. For this reason, composting toilets have a lot of advocates in the sustainability community. Composting toilets can be as simple as the Jenks Humanure system, which uses a 5-gallon bucket with a toilet seat, sawdust, and an outdoor hot compost pile. This is a composting toilet system you can experiment with for under $10. Commercial composting systems come in two types. The first is small, self-contained units where the composting unit and the toilet are one unit. These are best used in remote locations like seasonal cottages that see occasional use by just 1 or 2 people. The second kind of composting toilet is a centralized system where the toilets and composting unit are separate. One composting unit can sometimes handle several toilets. These systems are often used in national parks where access to water is limited or where soils are not compatible with conventional septic systems. But I've seen systems used in the center of large cities like Seattle in current generation of green buildings, and they're allowed by codes there. So in some local governments allow composting toilets to be used in place of conventional septic systems. In summer, one of the largest household water uses is watering gardens. The best technology for reducing water use in the garden is drip irrigation. Drip irrigation was developed for irrigating large areas of the desert in Israel. Drip saves 60% of the water used by conventional systems and keeps plants happier. Drip systems are inexpensive and can be equipped with timers that automate garden watering. Pinpointing the water right to plants ensures the water is not wasted or used to promote weed growth between plants or on paths. A sprinkler, on the other hand, indiscriminately spreads water everywhere. Drip works well with low pressure and gravity-fed systems because water drips slowly from the emitters. Drip keeps a good mix of air and water in the pores of the soil, where overhead watering tends to saturate the soil with water, and when the water drains away, leaves a deficit until the next watering cycle. Plants like drip irrigation. We added a drip irrigation system to our homeowner's mini greenhouse and hooked it up to a rain barrel. Let's take a look at how that process went. The first step was to install gutters on the shed to collect rainwater. Next, we installed a rain barrel to store the water. We attached the drip system to the hose connection at the base of the rain barrel. The garden is lower than the barrel, so we can use gravity instead of a pump to move the water to the garden. 1 or 2 feet from the bottom of the barrel to the garden provides enough pressure to operate the drip system. The first element in the system is a filter to keep debris from clogging the drippers. The next element is a timer. The timer automates the watering process. Next, we ran the pipe to the garden bed and across the short end of the garden to form a header. The pipe we've used so far is solid. It doesn't drip. It doesn't have any holes. Now here comes the magic part. We're going to connect 3 runs of drip tubing to the mainline pipe across the end of the bed. Drip systems don't require glue, complex fittings, or complicated tools. You simply poke a hole in the mainline tubing header and then insert the drip fitting into the hole. We repeated this process for all 3 lines. Next, we turned on the water and opened the timer. The water flowed into the system and out the ends of the drip tubes. Success! We let the water run out of the ends of the tubes for a few minutes to flush out the tubes. Next, we closed the ends of the tubes with a plug, and presto, water began to immediately drip from the emitters built into the tubing. The magic is that the drippers automatically drip the same amount of water regardless of the pressure or distance of the pipe. The final step is to set the timer for the frequency and length of time for water. For example, you could set the timer to water every day for 20 minutes. Here's a drip system on a small commercial greenhouse. Note that it has many of the same basic components as the simple home system that we just built. Now that we've reduced the amount of water we need, let's look at how we can supply this water. As we mentioned earlier, water is critical for life. It's good design to have multiple sources of water to supply this critical need. This is another example of a principle of ecological design. Each major function, in this case water supply, should be served by several elements, in this case sources of water. Here are the major sources of water for household use in order of sustainability. The first is rainwater harvesting. Harvesting rainwater connects you to the flow of abundance and scarcity in the natural environment around you. Rainwater can be stored in tanks, ponds, and in the landscape. You can set up an inexpensive rain barrel, as we just saw. With good design and a bit of luck, you can use gravity to distribute the water. Our homeowner used cheap cinder blocks to raise the rain barrel and situated her bed and greenhouse at an incline below to use gravity for water distribution. The next is groundwater. Groundwater is typically accessed with a well. Groundwater comes from a variety of sources that are replenished at different rates. If we mine water from the ground at rates faster than it is replenished, eventually the resource will be used up. This is happening with aquifers all over the world. We're using fossil water that in some cases was deposited thousands of years ago. And then finally, in terms of sustainability, there's water from municipal water supplies. I mentioned this last due to the energy, materials, and chemicals used in municipal water supplies. Let's discuss rainwater harvesting in a little more detail. Rainwater collection can eliminate the need for costly central water systems that mine water from deep in the ground. I've used rainwater to supply all my water needs for more than 20 years. And my family uses water in the normal, conventional ways that most families use water. Really, there's no difference. I'll use systems I've developed in Fairfield, Iowa to illustrate the principles and practice of rainwater harvesting, and I hope you'll get some ideas for your household. The first step is to look at the total amount of rainfall available and how it is distributed throughout the year. In southeast Iowa, we get about 35 inches of rain per year on average, fairly evenly distributed through the year, although we get more rain in the summer than in the winter. In contrast, a place like San Diego gets only 10 inches of rain a year, and it sometimes doesn't rain at all for 6 months. However, even San Diego could supply its water needs from rainwater. A house in San Diego with uneven distribution of rain would need more water storage than a house in southeast Iowa, which gets rain throughout the year. Here's how to calculate the water available from your roof. First, the pitch of your roof doesn't matter. It's the footprint that the roof makes on the ground that's used in calculations. It will be just a little bit bigger than the square footage of one floor of your home due to roof overhangs. Let's use a building that has a 40 by 40 footprint, including overhangs, and let's locate it in Fairfield, Iowa. So first step is to calculate the area of your roof. 40 feet wide by 40 feet long equals 1,600 square feet. Next, look up the annual rainfall. Fairfield, Iowa gets 36 inches of rain a year. There are many places on the internet that you can easily find this. Conceptually, think about the annual rainfall like a box of rain on top of your roof that is as tall as the annual rainfall. In this case, you will have a box of rain that is 40 feet wide, 40 feet long, and 3 feet tall. To get the annual cubic feet of rain, calculate the volume of the box. So that's just 40 feet wide by 40 feet long times 3 feet tall equals 4,400 cubic feet of water that would hit the surface of that roof in a year. Then convert the cubic feet into gallons. A cubic foot of water holds about 7.5 gallons. So 4,400 cubic feet times 7.5 gallons per cubic foot will yield 36,000 gallons a year. A Fairfield, Iowa home with a 40 by 40 footprint, 1,600 square feet, gets 36,000 gallons of water per year, almost 100 gallons per day. The total amount of rainfall delivered across the landscape is really astounding. The city of Fairfield, Iowa, where I live, gets 3 billion gallons of water that hits the surface of the city for a population of 10,000. That's about 218,000 gallons of water per person. And Jefferson County, the county that my community is located in, gets 264 trillion gallons of water for a population of 16,000. That's about 16 million gallons per person. Now, of course, we share water with lots of other life forms, but in most places, there is plenty of rainwater for human needs if we use it wisely. Now, it's not necessary to have high-quality potable water for most uses. You don't really need to use clean drinking water to flush your toilet, for example. Each person needs only a few gallons of potable, that is drinkable, water a day. Abundance Eco Village, the housing project in Fairfield, Iowa that I designed, uses rainwater to supply 100% of the needs of 15 homes, a vegetable farm, and a plant nursery. Its surface area is about 15 acres, which translates into 15 million gallons of water hitting the surface of the project each year. It supplies 2 grades of water to each house, one that is used for drinking and other high-grade uses, and a lower grade that serves toilets, washing machines, and outdoor faucets. The high-grade water comes from rooftop rain catchment and is stored in a 50,000-gallon tank. The lower grade water is collected off the land and is stored in ponds. We have on the order of 1 million gallons of water stored in the ponds for this project. Here are some things you can do to collect, store, purify, and use rainwater. First, let's discuss collecting rainwater. The higher your rainwater collection area, the better, because you can use gravity to distribute the water you collect rather than pumps. It's an example of the entropy principle. Once water has reached the lowest point on your property, it's lost some of its usefulness. You can no longer use gravity to move it. And gravity works 24 hours a day, 7 days a week, never fails. I designed a gravity-based rainwater system for a toilet in Hawaii. I went to visit it 10 years later, turned the valve, and it still worked. It worked flawlessly for 10 years, requiring no energy or pump repairs because there was no pump. It may still be working. I haven't been back to check. Roof and garage areas work well and often already have gutters for rainwater collection. You can also collect rain off other hard surfaces like driveways and roads. Even gravel driveways are quite impervious to water, so factor them in too when looking for opportunities. It's easier to store rainwater collected off driveways, in ponds, or in rain gardens, and we'll talk more about that later. You can collect water in the landscape by building shallow ditches on contour. A contour line is a line that runs across the slope at a constant elevation. Ditches on contour are called swales and hold water in the landscape rather than letting it run off. Plant the downhill side of the swale, and your plants will be automatically watered by the water that infiltrates through the swale. Ditches with a slight slope, called diversion drains, can lead water to storage areas, ponds and wetlands, for example. You may be able to use existing ditches to collect water. Abundance Eco Village uses diversion drains to collect rainwater falling in the landscape to a storage pond. Let's talk about storing rainwater. Rainwater can be stored in barrels. You can buy a rain barrel like this one for about $100. You can also make one from a surplus 55-gallon plastic barrel. I get mine from a Kelowna, Iowa cheese factory, and last time I checked, they were about $5. You can connect a hose to a barrel with a male garden hose to 3/4-inch male pipe thread adapter. Find a wood spade bit the same size or just a little smaller than the 3/4-inch male thread and use it to drill a hole near the bottom of the barrel. Then you can screw the 3/4-inch pipe thread end of the adapter into the hole in the barrel. The metal adapter will cut threads into the plastic barrel and apply silicone caulking liberally to the inside and outside. Each barrel provides 55 to 75 gallons of rainwater storage, and barrels can be connected to get larger amounts of storage. If your barrel is higher than your garden, you can use gravity to deliver the water. Even a few feet above your garden is enough to run most drip irrigation on gravity. Keep the barrel screened against mosquitoes. A 55-gallon rain barrel connected to roof gutters will quickly fill and overflow even on a small house. 55-gallon barrels are good for learning about rain catchment. But to reliably supply household and garden needs, you will need larger tanks. Reasonably priced polypropylene water storage containers up to 1,500 gallons are available at farm supply stores. Polypropylene is the same material many water bottles are made of. The cost is about 75 cents per gallon of storage. Concrete tanks are excellent for storing water and can be buried. Precast tanks of up to about 1,500 gallons are commonly used for septic tanks, and these tanks can be adapted for use as rainwater tanks. Expect to pay about $1 per gallon of storage. My home rainwater tank is 8,000 gallons and costs very little because I built it as part of my basement. Rainwater can also be stored in a pond. For around $500, you can have a pond dug that will store hundreds of thousands of gallons of water if you've got the space to dig it. In a few hours, you can dig a pond by hand that will store thousands of gallons of water, even in a backyard. To ensure an adequate water supply for a typical family of 4, I recommend at least 8,000 gallons for a whole house system in a rainfall area like Iowa, 36 inches distributed throughout the year. Now that we've collected and stored our rainwater, let's discuss how to treat it. For many uses like flushing toilets, washing clothes, and bathing, it may not be necessary to do any treatment. Rainwater used for drinking should be treated, but remember that drinking requires only a few gallons per day per person from a 50 to 100 gallon per person daily water budget. For drinking, I use a gravity system with ceramic filters that can treat thousands of gallons of water before needing to be replaced. You can also use solar distillation, pasteurization, sand filters, reverse osmosis, and UV light. Here's the system that purifies the rainwater in the Swartz-Guich Sustainable Living Center where I work. This building, as you're beginning to learn, has a metabolism. It collects and stores solar energy, and it collects and stores rainwater. And that way it's kind of like a tree. It's a living building. Now we're going to talk a little bit about how the building processes and manages rainwater as a water supply for the building. So we collect rainwater off the roof. We store it in a 10,000 gallon tank that's buried outside to keep it from freezing. And we bring it into this room where it goes through a series of filters to make it ready for use in the building. First filter we go through is a particulate filter, which takes out any particles in the water. Then it goes through a sand filter, a carbon filter which takes out organic compounds like any pesticides that might be in the water, anything like that. And then it goes through an ultraviolet light, which eliminates any biological activity so that the water is safe to drink after that. As one further stage of processing at the water fountain, we actually put the water through a reverse osmosis unit. The rainwater system in our building has proven to be so popular that we've had to expand its capacity several times. People come from all over campus because it's the best quality water around. You'll find that rainwater is also great for showering and bathing. Unlike hard well water or municipal water in many parts of the country, rainwater is soft. Plants also like rainwater better than water company water, which has chlorine and other biocides added. Water often picks up impurities during use that need to be removed before using it again or discharging it in a yard, wetland, or stream. The second law of thermodynamics raises its head here. Once clean waters are mixed with pollutants, it generally takes energy and effort to clean them. In some ways, clean water is a very orderly form of water, and like more orderly forms of energy, it can do more work. You can do more work with it. As you pollute water, there is a kind of entropy of mixing. As water becomes polluted, as it moves through your life, it can do less and less until eventually it requires some form of energy and processing to make it able to do useful work again. So from a thermodynamics point of view, it's useful to match the quality of water with the use. Not all uses require potable water. Try to match the source of water with the use and use the water many times before purifying it for use again. Use biological purification systems rather than mechanical ones whenever possible. Sometimes called living machines, they integrate elements of biology and elements of technology. Biological water systems use solar energy and the intelligence of the biology to purify water. This illustrates yet another principle of sustainable design. Use biological systems rather than mechanical systems whenever possible. That's because biological systems, unlike mechanical ones, self-organize using solar energy to create order and structure. Abundance Eco-Village uses a constructed wetland living machine to purify sewage water. Sometimes the impurities in water are an advantage, and they can be used as food for plants. Gray water is water that doesn't have human waste in it, like the water from your sink, shower, or a washing machine. It can be used to irrigate your garden. The details of gray water systems are beyond the scope of this lecture, but Art Ludwig has a good series of books on gray water systems, including one called Creating an Oasis with Gray Water. Next, let's discuss dealing with stormwater. Urban landscapes are impervious, covered with hard surfaces like asphalt and buildings. Even small amounts of rain sheet off, pick up contaminants like oil, and have to be dealt with man-made storm sewer systems. In contrast, nature's way of dealing with stormwater runoff is with pervious surfaces that allow landscapes to infiltrate and purify water. Prairie, whose roots can be 30 feet deep, absorbs and stores heavy rain, then releases it slowly, minimizing or eliminating erosion. Millions of gallons of water per acre can be stored in the roots of prairie plants. In contrast, many human-built landscapes, like lawns, cannot absorb rainfall. Water gushes off, causing erosion, picking up contaminants, and becoming a waste product rather than the resource that rainwater really is. But if you design your yard to store and hold water in the ground, you'll provide an environmental benefit and at the same time minimize watering chores. One way to create a yard that infiltrates rainwater is to build a rain garden or swale. A rain garden is a garden in a depression with specially amended soil designed to store and infiltrate water. A swale is a ditch on contour that collects and holds rainwater until you can infiltrate it into the ground. Here's a rain garden that treats rainwater from a gas station in Fairfield, Iowa. Here are some design guidelines for rain gardens. Direct the water from hard surfaces to your driveway into a rain garden. A rule of thumb is to build a rain garden that is about 1/10 the area of the hard surface. For example, if your driveway is 500 square feet, then you need a 50 square foot rain garden. Place food-producing plants in and around the rain garden for even more benefit. Most rain gardens are longer than they are wide, perpendicular to the flow of water. Rain gardens have 3 planting zones. The middle, where water typically pools longest, should have vegetation that tolerates wetter conditions. The intermediate zone, between the middle and outer edge, features vegetation that tolerates occasional standing water. And finally, the perimeter of the rain garden will have plants that prefer drier conditions. The basin of the garden should be level. If you're working on a slope, you can use the soil you dig out to create a berm on the lower side. This keeps the water in, preventing overflows and allowing water to store up before it draws down slowly. Water can enter your rain garden in a variety of ways. Rain chains, downspouts, grass swales, creek beds, and driveways. Consider an outlet if overflow may be an issue for your lawn or neighbor. Permeable paving is available for driveways and walkways, allowing water to infiltrate directly from these surfaces. I hope this lecture helps you begin to rethink water as it flows through your life. We've explored water from source to sink. You can start small by building the rain barrel or drip system I showed you how to make in this lecture. You can build a beautiful, functional rain garden. Even a dense city landscape can be made into a permeable, hydrologically functional landscape. By developing a relationship with water, you'll be ensuring supplies of clean water for future generations and for nature. Water is essential for life and essential for sustainability. So far in this course, we've been exploring individual elements of sustainable living, like high-performance buildings, renewable energy systems, and local food production. But these elements don't exist on their own. They're embedded in a settlement pattern: rural, urban, suburban, village, and city. Cities are the biggest things that people make. Redesigning them as eco-cities is one of the biggest factors in global sustainability and in improving human welfare. In this lecture, we'll explore how these settlement patterns affect sustainability. We'll explore eco-city design. Settlement patterns in city design define transportation requirements, and transportation system decisions in turn define options for city design. We'll also look at transportation alternatives. In the past, cities were designed around the size and velocity of the human, and today's best cities, like Florence, Italy, still are. Most of today's cities, however, are designed around the size and velocity of the automobile. which has huge consequences for sustainability. By design, housing, shopping, work, education, and recreation are all segregated in separate districts, requiring cars to access them. Cars, however energy efficient, and regardless of the fuel you use, are 10 times faster and 10 or 20 times larger than humans. So the infrastructure required to accommodate cars is inherently in conflict with human scale, human-centered urban design. In a society designed around the car, large segments of the population are disenfranchised. The young, the elderly, the sick, the poor, the blind. These are just a few categories that can't participate directly in car culture. Better and better cars allow us to push suburban sprawl further and further out. So the better car can often make for the worse city. As an example, look at Los Angeles. 50 years ago, Los Angeles was choking in air pollution caused by automobiles. We solved the problem by fixing cars rather than fixing the city, using a technological fix rather than a comprehensive design solution. Fixing cars meant adding catalytic converters and other pollution control devices to individual cars. This was remarkably successful in addressing smog. Today, in 2014, even with many more cars, the air is much cleaner in LA than it was then. Other cities were then able to emulate LA in urban sprawl design. But we contributed to another set of problems by making it tenable to continue using cars on a large scale. Global warming. Transportation emissions are responsible for 30% of U.S. greenhouse gas emissions, and 60% of that comes from cars and light trucks. Cars cause a lot of damage, destruction, and death. They pollute, they are noisy, they take up a lot of space, time, and money, they destroy natural beauty, and they are a major cause of death for humans and other animals. They have taken natural landscapes and turned them into cement jungles. Yet we still idolize them, and we have designed our cities to prove how much we worship them. Advertising has encouraged us to turn our cars into status symbols. So instead of designing cities around community and accessibility, cities are designed to permit a car to go anywhere. The more efficient the car, the more justified we can feel for driving more. Better cars lead to more driving. But is that really what we want? What we need? Now don't get me wrong here. If we drive, we should drive the best, greenest cars we can, powered by renewable energy sources. And we can't put people in environments that were designed for cars and take away the cars. Later in this lecture, we'll talk about better design for cars. Improving cars and making better buildings are still good things to do, but we shouldn't let that get in the way of the more fundamental work of reimagining and redesigning their context, the city. What's an alternative to making better cars? Well, we need to design cities from the ground up for people rather than cars. Cities can be designed so that basic human needs like food, education, jobs, entertainment, and access to nature can be accessed without cars. Eco-city theorist and designer Richard Register calls this access by proximity, making the necessities and niceties of everyday life accessible by walking or biking. Another element of eco-city design is to rethink single-family home design. It's difficult to get the kind of density needed for access by proximity in a car-free environment if everyone has a suburban-style single-family home. In addition, larger multifamily buildings have a more efficient shape than single-family homes, with less heat-losing surface area needed to enclose a given amount of floor space. Access by proximity is made easier if cities are built up instead of out, in 3 dimensions rather than 2. It's interesting to note that there are not any 2-dimensional living creatures. Nature creates life in 3 dimensions with lots of clever tricks, like crenellated and folded brain tissue, to create access by proximity. The metaphor for the city has been the city as a machine, or as the French architect and city planner Le Corbusier said, a machine for living. The metaphor for the eco-city is the city as a living organism, powered by solar energy, with a metabolism that fits within ecological cycles. Richard Register has created a series of images that illustrates one idea for transformation from big box, car-centric design to eco-city. Here's the conventional city, based around cars and the big box store. The first stages of redevelopment look pretty similar to redevelopment of any type, but you can see that the street is being dug out in what looks like the shape of a waterway. The third drawing shows what the new eco-city looks like after the transformation. It's a complex, multi-use, multi-story environment. Nature is an integral part of the design, with a restored creek, which had been previously buried under the street and has been brought back to the surface. There are trees on the upper floors of the buildings. There are multi-level pedestrian bridges connecting different elevations. This looks like an interesting, fun, and functional place. Of course, there are many ways in which the eco-city idea could find form. This is just to get you thinking about the possibilities. When human habitats are denser, then there's more land left for nature. Unmediated nature experiences and wildness can be close to cities, just a few minutes walking or by bike. Typically, cities are designed with consideration for buildings first and for the space between buildings last or not at all. Jan Gehl, a Copenhagen-based city designer and author of the books Life Between Buildings and Cities for People, recommends the following order for thinking about city design. First, life, designed for people in convivial human interaction rather than cars. Next, space, consider the use of public spaces and the space between buildings. And finally, buildings, consider how buildings fit into space and life. Here are the principles of eco-city design developed by my colleague Richard Register, author of the book Eco-Cities and founder of the nonprofit Eco-City Builders. Many of the ideas in this lecture come from my discussions with Richard. Build the city the living system that it is. Put waste into cycles. Integrate food production. Power it using solar energy and harvest rainwater. The form is a well-integrated, complex, three-dimensional shape, facilitating access by proximity. The design metaphor is living systems rather than the machine. Make the city's function fit within the patterns of evolution. Go beyond sustainability to regeneration of natural systems in the human spirit. Support and express creativity and compassion. As the universe evolves, its entities like stars and planets spawn beings like animals and plants. Some of these invent wings like those of insects, bats, and birds that never were before. And so people invent, among other things, justice, truth, beauty, and the techniques of law, philosophy, and art to embody them. These and future inventions not yet imagined are what cities should support. Cities can be a powerful force for human cultural evolution. Start with a foundation of land use planning that supports the eco-city. Land use pattern should support the healthy anatomy of the whole eco-city. Land use infrastructure has to be ecologically tuned from the start. Reverse the transportation hierarchy. Transportation choices support or subvert much of what is healthy about cities. Plan for pedestrians first, followed in order by bikes, rail, on-road buses or flexible transit, cars and trucks. Generally, we plan for those first, and notice in this hierarchy it's last. Build soils and enhance biodiversity. Compost and cycle organic wastes. In Havana, Cuba, 90% of the city's fresh produce comes from local urban gardens and farms. It is grown organically with fertilizer supplied by composting waste organic matter from the city. In 2009, there were 85,000 acres of land being used for agricultural production in Havana, with more than 44,000 people employed. We could create millions of new farmers in America with urban and peri-urban farming. We're used to urban infrastructure that doesn't work. The existing urban infrastructure makes it difficult to imagine something different. To paraphrase Winston Churchill, first we shape cities, then they shape us. Making these kinds of complex urban environments the most attractive places for people to live, rather than the least attractive places, is a central challenge for sustainability. City design has an impact on the efficacy of green technologies and the parameters of personal choice. Let's look at how city infrastructure and land use decision affect ecological impact and ecological footprint. What's the greenest place in the U.S.? Well, even though New York City is not an eco-city, David Owen, in his book Green Metropolis, contrasts Vermont and New York and argues that New York is the greenest place to live in America. Why? Well, because it's compact, and most people live in smaller apartments that are energy efficient by virtue of their small size and shared walls. The key to New York City's relative environmental benignity is the very thing that to most Americans make it appear to be an ecological nightmare: its extreme compactness. Moving people and their daily destinations close together reduces their need for automobiles, makes efficient public transit possible, and restores walking as a viable form of transportation. Dense urban cores are among the few places left in America where people still routinely go around on foot. In the suburbs, you seldom see anyone walking who is actually traveling to a destination, rather than merely moving between a building and a vehicle or trying to lose weight. But New York is not an eco-city. It's efficient because of its compactness, but much could be added by rethinking New York on eco-city principles. Eco-cities go beyond compactness to build in sustainability from the start, providing the proper substrate for the application of green technologies and design strategies. Adding eco-city design to a place like New York City is a way to make change on a large scale, complementing the sustainability efforts we make with our personal choices. How can we transition from current urban infrastructures to eco-cities? Well, we've got to think about new eco-city infrastructure, and we've got to think about retrofitting the old infrastructure. These are mostly long-term, multi-generational projects, like building a medieval cathedral. There are several problems with making the eco-city vision the rule rather than the exception. First, in America, we've got a dearth of inspiring good examples of car-free design. Many of them are in places around the world that few Americans have visited. In a minute, I'll show you examples of popular vacation destinations that were built before cars and maintain a pedestrian focus. Second, eco-cities are inherently large-scale undertakings, mostly beyond what a person can do on his or her own. And third, large, complex public infrastructure tasks require the leadership of government. And in the U.S., there has been a focus on individual solutions for sustainability, which are important and necessary, but not sufficient in dealing with the biggest things that people collectively make: cities and their corresponding transportation infrastructure. A little more than 100 years ago, all cities were car-free. The few cities that still are, like Florence, Italy, are some of the most popular tourist destinations in the world. We're looking to learn from the past, not recreate it. I've shown you these images so that you can see that dense human settlements can be very attractive places to live. What are some modern experiments in eco-city design? Well, one of the most ambitious is Arcosanti, designed by Paulo Soleri. Paulo Soleri was a student of Frank Lloyd Wright, who had a vision for cities and ecology living in harmony, which he called arcology, a combination of architecture and ecology. He looked at cities as centers of innovation and evolution of the arts, culture, science, and technology, as centers of human progress. He felt city design could either enhance this evolutionary trend or stifle it. His goal was to discover those design elements that would bring out the best of humanity through city design. He designed massive arcologies, eco-cities to house millions of people. In 1970, Paulo began building a new city called Arcosanti in the desert about an hour north of Phoenix. His goal was to build an eco-city for 5,000 people on 25 acres. He taught and influenced generations of architects and urban designers who studied and worked with him there to build the town. Arcosanti continues to offer 5-week internships on eco-city design and construction, and as of 2012, more than 7,000 have taken the workshop. Curitiba, Brazil, under the direction of Jamie Lerner and others, became one of the most advanced ecological cities in the world. As Bill McKibben notes in his article exploring sustainability in Curitiba, the Brazilian city of Curitiba is a global model for development that both respects the earth and delights its inhabitants. Curitiba is an example of how sustainability is a key to a better way of life. Curitiba has built parks instead of canals to reduce flooding, used parks to make the city more livable. It pedestrianized the downtown area. They invented and built bus rapid transit, a bus system that works like light rail systems, but is 10 times cheaper and 100 times cheaper than a subway. They started a massive recycling scheme that included giving people bus tokens in return for waste. The story of the creation of the pedestrian area is a great example for showing us the challenge of moving to a car-free infrastructure and an innovative solution. Lerner wanted to create a pedestrian mall in the center of the city as an emblem of his drive for a human-scale city. And he knew that he would be in for a big fight with store owners unfamiliar with the concept. He and his public works office carefully planned to do the work, which would normally take a month or more, over just one weekend. The pedestrian mall was an immediate success. By midday on the Monday after the mall was created, store owners who had been threatening legal action were petitioning the mayor to extend the mall. The next weekend, when offended members of the local automobile club threatened to reclaim the street by driving their cars down it, Lerner didn't call out the police. Instead, he had city workers lay down strips of paper the length of the mall. When the auto club arrived, its members found dozens of children sitting on the former street painting pictures. The transformation of Curitiba had begun. 99% of Curitibans are happy with their city and wouldn't live anywhere else. Even 70% of the people who live in Sao Paulo would rather live in Curitiba. And they did all this with an average annual income of $2,500 per year. Curitiba proves eco-cities and sustainability are not just for wealthy societies. In my town, there is only one pedestrian street. It's the most photographed place in the whole town. Despite this, there is fierce opposition to expanding the car-free area. Efforts at building eco-cities will be mostly long-term efforts. In the meantime, we can spark public imagination by building what Richard Register calls eco-city fractals, small pieces of eco-cities that can serve to help people imagine what entire eco-cities could be like. Villa Verde, which opened in the Bronx, New York in 2012, is an example of an eco-city fractal. It's a $100 million project with 500 residents, rooftop veggie gardens and fruit trees, access by proximity, and renewable energy. The building is tall on the north side and steps down as it goes further south. This optimizes the availability of solar energy for the complex. Other strategies that some communities have explored to transition from car-centric to people-centric design are placemaking and traffic calming. City Repair, a Portland, Oregon nonprofit, has created a process for making public spaces more convivial called placemaking. Placemaking is a process for getting neighbors together to imagine and design a better public space and then create it. It can involve elements like painting colorful designs on intersections, installing simple outdoor book exchange boxes, benches, and public tea stations. Placemaking was first done as a below-the-radar guerrilla action, but is now approved by Portland city government and has spread to other cities. City Repair hosts the Village Building Convergence, an annual conference in Portland, Oregon, featuring a hands-on approach to sustainable city design. There are a wide range of innovative design ideas for slowing traffic and giving preference to pedestrians, like Woonerven in the Netherlands and the shared space intersection designs inspired by Hans Monderman. Woonerven were developed in Holland to slow traffic on small streets in residential neighborhoods. They push unexpected elements like tables to the edge of the street and sometimes even into the street, forcing drivers to slow down and be more aware. Monderman is an innovative Dutch traffic engineer that creates intersections that merge pedestrians, bikes, and cars all into the same system. His intersections are so well designed that they don't need street signs or traffic signals. In fact, that's one of the ways that they work. No street signs or signals force cars to slow down and be aware of the pedestrians and bikes that share the road with them. Now, this sounds dangerous, but research shows that Monderman-style shared space intersections are safer than conventional intersections. We don't have time in this lecture to go into the details, but I encourage those who are interested in eco-city design to explore these ideas for traffic calming further. We've explored the drawbacks of car-based city design. But in most cities today, we still need to use cars. Let's look at some car options we can use today. There is a revolution in car design going on. Quality electric cars are available from major manufacturers. In 2014, electric car range is 80 to 100 miles, adequate for most commutes and around-town driving. Many people find that acceleration and overall driving experience is actually superior to gas vehicles. Bill Herlin, a resident at Abundance Eco Village, says that his electric car is the best car he has ever owned. Hybrid cars combine a conventional gas or diesel engine with an electric motor generator and batteries. This combination allows the conventional engine to run at higher efficiencies, dramatically increasing miles per gallon. One of the most popular hybrids gets 51 miles highway, 48 city miles per gallon. Most manufacturers have hybrid models available. The generator and batteries work with the conventional engine to convert energy normally wasted during coasting and braking into electricity, which is stored in a battery until needed by the electric motor. The electric motor is used to assist the engine when accelerating or hill climbing and in low-speed driving conditions where internal combustion engines are least efficient. Hybrids automatically shut off the engine when the vehicle comes to a stop and restart it when the accelerator is pressed. This prevents wasted energy from idling. Hybrids also are typically lower in weight and they have better aerodynamics, which helps fuel economy. Now, plug-in hybrids offer the ability to drive on electric power only. You can use the car as an electric car and plug it in to recharge it. Running on electric power from the grid is typically 1/4 the cost of driving using gasoline. And if you don't plug it in, you can still use the car in conventional hybrid mode using gasoline. Range as an electric vehicle varies from about 11 to 38 miles. On the cutting edge of vehicle performance is a hybrid that gets 261 miles per gallon from its hybrid diesel-electric drivetrain. Now, cars sit idle more than 90% of the time, and this presents us with an opportunity to use the battery in an electric car as a way to even out peaks and valleys in electric grid usage, and as a way to store surplus renewable energy for times when it's needed by the grid. Owners of electric cars that are left plugged in when parked could get paid by the utility company for this energy storage service. This concept is called vehicle-to-grid, or V2G. There aren't any cars or grids that have this capability yet, but it's an area of active research. If electric cars were widespread, the storage capacity of their batteries could be several times the generating capacity of the entire grid. We could provide ample storage for excess solar and wind energy from a smart grid connected to smart electric cars. I run my diesel car on fuel my students make from waste vegetable oil. The product they make is called biodiesel, and it can be used as a direct replacement for diesel fuel. Let's take a look at how that process works.
Hi there, my name is Rich Dana, and I'm here today to share some information with you about biodiesel and biofuels. Ethanol is commonly made from corn, and biodiesel is made from a number of different things, but primarily it's made from vegetable oil. It's a super simple process, and I'm just going to show you today just how easy it is to make biodiesel from vegetable oil. And I'm going to be using just some regular grocery store cooking oil. I'm going to be using some methanol, which a lot of you probably recognize as a cold weather additive for your car. And I'm going to be using potassium hydroxide. Potassium hydroxide is a common agricultural fertilizer. It's also known as caustic potash. And you can also use regular lye that's used as a drain cleaner, but we like to use caustic potash because the byproducts are biodegradable and we can compost those when we're done with the processing. So I'm going to show you how we make a catalyst with the methanol and the caustic potash. We're going to add it to the vegetable oil, and you're going to see a chemical reaction that strips away the free fatty acids and breaks down the oil into a diesel fuel that's easier for diesel vehicles to run on. And so what I've done here is I've measured out the potassium hydroxide. I'm going to put this into a mixing vessel, and just to show just how simple the process is, I'm using a regular peanut butter jar. I'm using a household measuring cup, and we're taking 250 milliliters of, and I'm spilling a little bit of it, which is the way it always works, 250 milliliters of the methanol, and we're going to start agitating that and getting the potassium hydroxide to dissolve in the methanol. This is going to be our catalyst for producing the biodiesel. We're going to continue to agitate that until all the potassium is dissolved. It takes a little bit of time, but while the chemical reaction is happening, this is getting warm to the touch. You can tell that there's a pretty serious reaction happening here. This is the most dangerous part of the entire process, is handling that methanol and that caustic potash. So we need to be careful with that. I'm going to set that aside and let that dissolve for a little bit. And in the meantime, I'm using a regular liter bottle here to measure out 1 liter of vegetable oil. And like I said, it can be any kind of vegetable cooking oil. Canola oil is particularly good, soy oil, any of the regular common household oils. So we're going to take that, we're going to use this large mason jar to mix the whole thing. And we're going to put our cooking oil into the mason jar. And to that, we're going to add our catalyst. So now that the potassium hydroxide is completely dissolved in the methanol, we're going to add that catalyst to our vegetable oil. You can see even now it's starting to react with the oil, and it's starting to break it down a little bit. And now I'm going to agitate this, make sure that it's completely mixed and that the oil is getting completely interacted with the catalyst. Because it takes a little while for that chemical reaction to take place, I've prepared some earlier in the day just to show you how the reaction starts to look as the oil starts to break down. Okay, so you can see that the biodiesel has started to clear up, and down here at the bottom you can see a layer of separation between the biodiesel and the byproduct, which is glycerin. And this is a common biodegradable byproduct. It's also commonly used in soaps and cleaners. A lot of you have heard of glycerin. We're able to drain that off the bottom in our larger tanks, and that leaves us with just the biodiesel, and we've got the glycerin byproduct. So essentially, this is what you're buying at the pump when you're buying biodiesel. It's just as simple as that. We've also got some here that was made quite a while ago, and you can see how clear it's gotten. It's really completely clear, and it's gone through what's called a wash process to strip away any of that residual soap or any water or anything else that could be harmful to your injectors or other, otherwise damaging to your vehicle. This is perfectly safe to put in your diesel vehicle, as good or maybe even better than some of the stuff you'll buy at the pump. So that's, in a nutshell, is how biodiesel is made.
There is controversy about using plants for fuel. Most commercially available biofuels are made from corn and soybeans. The plants need to be grown in a sustainable way, and there is potential that biofuels can drive up the price of food. Next, let's consider transportation alternatives based on bikes. The first time I saw a bike system that's a real alternative to cars and public transportation was in 2008 in Paris. The Veylib bike sharing program makes bikes ubiquitously available for short-term trips. It's not designed for pleasure riding, although it's a real pleasure to use it. It's a kind of public transportation designed to complement or replace cars and buses, taxis and subways. Veylib consists of a network of 20,000 bikes available at curbside locations in all directions all over the city. For 30 euros per year, 8 euros per week, or 1.7 euros per day, you get unlimited use of the system. The first 30 minutes are free. If you go over 30 minutes on a single trip, there are increasingly steep charges to encourage you to use it for short trips. You bike to your destination and return the bike to a ubiquitous curbside station. When you are ready to go on to your next destination, you pick up another bike and repeat the process. Using the bikes is more like getting on and off the metro or bus than using a personal bicycle. The system didn't cost the city of Paris anything. The city doesn't pay for maintenance or operation of the system, and the city gets a payment of 4.3 million euro a year plus all the revenue from the system. Here's how they did it. The system was built and is operated by a Parisian ad agency. In return, they get exclusive use of 1,600 public advertising spaces all over Paris. It's a brilliant concept and hugely popular. As of 2012, the system had 225,000 users, making 173 million trips per year. Motor vehicle traffic has decreased by 25%. It's been copied in other cities in North America. I've used similar public bike systems in Toronto and Montreal. Here's a bike I used in Montreal, loaded down with purchases from the farmers market. I think a team of bright young entrepreneurs could adapt this and roll it out all across America. City road infrastructure was built for cars, but can be adapted for widespread bike usage. This would require working out some new city infrastructure for utility biking as opposed to recreational biking. Things like showers at work, covered bike parking, buses and subways that accommodate bikes, separate traffic signals for bikes, and separate roads for bikes. The best bike infrastructure separates cars from bikes. The provision of separate cycling facilities appears to be one of the keys to the achieving of high levels of cycling in the Netherlands, Denmark, and Germany. Here's an example of an innovative way to arrange a bike lane. Note that instead of the cars parking next to the sidewalk, the bike lane is next to the sidewalk, and the parked cars shield the bike lane from road traffic. In this lecture, we've seen how cities can be transformed into eco-cities. This has to do primarily with design for access by proximity, retrofitting our transportation systems for more foot traffic and bike traffic and less dependence upon cars, powering cities by solar energy, and having a metabolism that includes producing food, recycling waste, and harvesting rainwater. We've looked at energy-efficient cars that use renewable fuels, and we've explored the widespread use of bikes for practical, everyday transportation needs. A key challenge of sustainability is transforming our cities from the least desirable and ecological places to live into the most desirable. Many of these initiatives we need to do collectively. They are beyond the ability of one individual to implement. We need to support the courageous leaders that imagine, create, and advocate for these initiatives. But it's important to know, as individuals, that desirable alternatives exist and to support them when asked. I'm sure that many of you are aware of a growing trend towards green products. And I'm sure that you won't be surprised to learn that sustainable living includes being mindful of what you support with your purchasing choices. Each dollar you spend is a vote of support for a product and the company that makes it. Whether you're shopping for groceries, personal care products, cleaning products, even home improvement products, many companies are offering greener alternatives to the items that have been available in the past. In this lecture, I will try to help you navigate a greener course through some of the choices you make every week as a consumer. First, make sure that you really need what you're about to buy. The greenest product is the one you don't buy. Can you share the item with someone, borrow the item, or would it really ruin your life to do without it? The developing sharing economy, where the internet is connecting people that want to share things like cars or rent a spare bedroom to a traveler, will help with this process. Let's define what a green product is. Of course, some products are greener than others. For example, some lip balms are made with petrochemical waxes and come in non-recyclable plastic packaging. Other lip balms are made with organic ingredients and come in biodegradable packaging. Some products are green by their very nature. Natural building materials like straw and clay are inherently green. They take very little energy to process, they are easily recycled, and they don't contain any toxic materials. On the other hand, some products are very hard to produce in an environmentally responsible way. For instance, a computer or a cell phone requires rare minerals that can only be mined in a few remote parts of the world. They require a lot of energy to manufacture. They use electricity to operate and are made primarily of plastic, which is a petroleum-based product. Not so green, right? But there are some companies or cell phones that are greener than others. Some are more energy efficient, use fewer toxic substances in the manufacturing process, and can be recycled into new electronic devices when you discard them. The United States Environmental Protection Agency defines a green product this way. Generally, a product may be considered greener if scientific evidence demonstrates that human health or environmental impacts have been significantly reduced in comparison with other products that serve the same purpose. This comes from their Greener Products website. I like this definition because it reflects the fact that a product is considered green only in comparison to its competition. This implies that green is not an end in itself. It's a process where products can continually get greener as technology and the marketplace allow. In a rapidly changing world of consumer products, manufacturers compete for your shopping dollar by looking for trends in the marketplace. Some of those trends are short-term and superficial. We've all seen cereal boxes that feature a popular athlete or advertising that ties a product to a summer blockbuster movie. In general, these marketing trends don't reflect a change in the product, but just try to capitalize on current popular culture. Some companies look at sustainability like this, a short-term trend in popular culture. On the other hand, there are companies that recognize that sustainability is more than a fad and look to provide products and run their companies in ways that truly embody the principles of sustainability. These companies have long-term strategies for capturing market share that involve radically rethinking how and where the product is manufactured, packaged, and sold. When you look at the huge assortment of products on store shelves, it may not feel like your individual purchase could possibly make a difference in global marketing trends, but you are, in fact, voting with your dollar. If you choose a product with the Made in the USA label when shopping for, let's say, socks, the store where you shop is more likely to continue to stock socks made in the USA. You are actively supporting the American workers who make, package, and market those socks. The same is true for environmentally friendly or green products. By choosing to purchase a product that is made in an environmentally friendly and sustainable facility, packaged with a minimum of materials, and made without harmful chemicals, you are contributing to the growth of a marketplace that not only respects the environment, but also respects the consumer. So what makes so-called green products different? How do we know how green these products really are? And what are the advantages of switching to greener products? In order to answer these questions, we need to understand a few things about how the manufacturing process works within our current economic system. A few years ago, a delightful educational video called The Story of Stuff went viral on the internet. In the video, environmentalist Annie Leonard defines our system as a materials economy made up of the extraction, production, distribution, consumption, and disposal of goods. By this, she means that we extract resources, for example, oil or cotton or wood. We use those resources to produce a product, a computer or socks or a loaf of bread. We distribute the product to consumers, and when it has outlived its usefulness, we dispose of it. To this system, Leonard adds people, the government, and corporations. The Story of Stuff points out that this is a linear system, depending on finding places to source our materials and to sink our waste. Going back once again to the EPA's figures, in 2012, Americans generated about 251 million tons of trash and recycled and composted almost 87 million tons of this material, equivalent to about a 34.5% recycling rate. The Story of Stuff claims that 95% of the material that flows through our economy ends up in the landfill within 3 months. Despite our best efforts, the vast majority of what we buy and use every day ends up in the landfill. Leonard then contrasts this with nature, which uses a circular materials flow. The waste of one system is the input for another system. What we need to understand is that the road from the mine or the farm to the factory, the store, and the consumer, and then to the landfill, does not need to be a one-way street. We do not necessarily need to be continually extracting our diminishing resources and throwing them in the dump. We can turn the process into a circular path. We can design our goods so that the disposal step is not a trip to the landfill, but rather the creation of a new resource. In their groundbreaking 2002 book, Cradle to Cradle, Remaking the Way We Make Things, architect William McDonough and chemist Michael Braungart describe a new approach to manufacturing that works to eliminate the concept of waste and put the inputs and outputs of the industrial economy into closed cycles. Their slogan is waste equals food. What's waste for one process is the food for another. They propose that we move away from a cradle-to-grave approach to moving resources through the economy and into the landfill. By taking the view of waste as a potential resource, our consumer choices might actually give us the opportunity to leave a regenerative footprint, one that gives back more than it takes. McDonough calls this concept cradle to cradle, continually cycling old materials into new products. I'll get back to that idea in just a minute. There are health implications of using greener products too. We are spending an increasing amount of time indoors. The average American spends 87% of their time indoors. Our personal environment, where we sleep, where we work, where we eat, and where we get together with family and friends, are all made up of manufactured goods. From the carpet to the paint on the walls to your home electronics, furniture, and clothing, everything around us is a product of that old cradle-to-grave model. In many cases, these products provide us with a comfortable lifestyle, but they may be endangering our health as well. The materials and chemicals in the products that surround us, like the plastics and petroleum products, have been implicated in a wide variety of ailments. Air pollution from burning fossil fuels also has health implications. An extensive body of studies has found strong associations between respiratory health and concerns like asthma with direct exposure to motor vehicle pollution resulting from residing or attending school near major roads with high traffic levels. Increasing our use of greener products reduces our exposure to many of the harmful effects of petroleum products and tailpipe emissions. As an example, replacing diesel fuel with biodiesel in school buses could cut their emissions of the diesel particulates up to 47%. According to the American Lung Association, diesel particulates are a major cause of childhood asthma, and they are encouraging schools to make the switch to biodiesel, which is a diesel fuel made from plant sources, rather than petroleum. Using greener products can reduce wasted resources, reduce pollution, and help protect our personal health. So how do we choose which product we will support with our purchase? Well, let's start with the materials in your home. Whether you live in a new home, older house, or an apartment, chances are the materials are pretty similar. The walls are built with drywall over wood or metal studs, and the exterior is covered with siding of some sort, or a type of masonry like brick or stucco. Inside you'll have wood flooring, tile or carpeting, and you have kitchen cabinets, bathroom fixtures, and more. The style may be different, but in general, this is what you'll find in the standard American home. There has been a revolution in the availability of green alternatives to conventional building materials. Paints that don't off-gas toxins and sustainably harvested wood are some of the products you can find at big box building supply stores if you look. Some go beyond being less bad to being regenerative. One area that has gotten a lot of attention, as I mentioned earlier, is the carpet industry. Studies show that carpet is replaced every 7 years, despite the fact that most carpet, if well cared for, will last up to 25 years. That means that millions and millions of square feet of carpeting are going to the landfill each year. Nylon fibers from carpeting last virtually forever. Chemists estimate that nylon will last up to 250,000 years in a landfill. And what about all the energy that it took to drill for oil, process the oil, and produce the nylon in the first place? All of that energy is embodied in that carpeting, and it is lost to us once it goes to the landfill. The carpet industry is making huge moves toward a more regenerative model. Some companies are producing carpeting out of old plastic soda bottles. This is an illustration of upcycling, a term that refers to techniques that recycle materials into higher value products. Not only is this carpeting taking advantage of the energy already embodied in the plastic bottles, the carpet itself can be recycled again and again as carpet. Perhaps you have decided that rather than buy new carpeting, you will save money and reduce waste by simply cleaning your existing carpet. Can you keep the old carpet clean without exposing yourself, your family, and your pets to harmful chemicals? Well, there's a nice selection of natural carpet cleaning products available now that use plant-based cleaning agents rather than petroleum-based products. There are carpet cleaning services out there that now offer non-toxic carpet cleaning. But here's a thought. When it comes to household cleaning products, perhaps the best way to assure that your cleaners are truly green is to make your own alternatives to commercial cleaning products. Some of you out there might remember when white vinegar was commonly used as an all-purpose cleaner. In the old days, this was considered a frugal alternative to more expensive store-bought cleaners. This old favorite has the advantage of being completely natural and non-toxic. For instance, a simple recipe consisting of 1 quart of warm water, 1/4 cup of white vinegar, and 1/2 teaspoon of liquid soap or detergent will do as well as a glass cleaner as many name brand products. Some people use old newspapers to wipe the glass rather than paper towels, which leave lint behind. The vinegar-soaked newspapers can then safely go in the compost. We all know that baking soda is great for absorbing refrigerator smells, but is also a great mild abrasive cleaner for cleaning tile surfaces, tubs, and porcelain sinks. With a little research and experimenting, you can save money and go green by partially or completely eliminating commercial cleaning products. If you aren't making the products yourself, it can be difficult to determine which of these household materials and cleaning products are the greenest alternatives. Luckily, there are some certification agencies that now investigate the claims of manufacturers and make this information available to consumers. Any product can call itself natural, but if they carry the certification of a reputable, independent, third-party certifying agency, chances are much better that you are getting what you paid for. Many of you are familiar with the certified organic label on food products that indicates that no chemicals were used in raising the ingredients and that the facility it was produced in is also certified organic. There are similar certifications for buildings and building materials, appliances, computers, healthcare products, and household cleaning supplies. Let's look at a few of these. The U.S. government offers several certifications for greener products. They include USDA Certified Organic Label that I just mentioned, which covers food, health products, personal products, and some cleaning products. The USDA Bio-Preferred Label refers to industrial and household products other than food that are composed primarily of plant-based materials rather than petrochemicals. Energy Star is the label that you see on household appliances, home electronics, light bulbs, and other energy-consuming devices. It indicates that these devices meet a minimum standard for energy efficiency. Other non-governmental certifiers include EPEAT, uses comprehensive criteria for design, production, energy use, and recycling. EPEAT currently covers computers, computer displays, televisions, and imaging equipment. It is managed by the Green Electronics Council. The Forestry Stewardship Council, or FSC, certifies forest products including wood and wood products like furniture, as well as paper, packaging products, and other timber byproducts. LEED, or Leadership in Energy and Environmental Design, is a green building certification program offered by the U.S. Green Building Council that recognizes excellence in new building and renovations. To receive LEED certification, building projects earn points to achieve different levels of certification, including bronze, silver, gold, and platinum. There are also international certification agencies, like the Institute for Building Biology and Sustainability in Germany. The IBN, as it is known in German, offers an extremely strict regime for testing, which includes indoor air quality, drinking water quality, and noise pollution. It even addresses more controversial issues like electromagnetic pollution. Most everything we do uses electricity, and the electric and magnetic fields generated by electrical devices completely surround us. There is some evidence that the electric and magnetic fields created by things like cell phones and power transmission lines and Wi-Fi can have negative health effects on some people. Building biology has procedures for testing levels of electromagnetic fields and mitigating them if they are too high. What other ways can we reduce our ecological footprint and begin to establish a regenerative footprint? There are sustainable ways that require a little less research and can be fun and rewarding. Some of these ideas include the following. Buying locally. Buying locally does not assure that you are buying a greener product, but at the very least, you are going to help maintain a sense of community. A community business is usually more likely to be concerned about local air quality and local water quality than a business that is owned by a faraway corporation. Farmers selling at a local market rely on their reputation for raising good, fresh, and wholesome food and for caring about his or her community's quality of life. For that matter, you might consider becoming more involved in making the stuff you need or developing relationships with the people that make the stuff you need. Thousands of people across the country are showing their entrepreneurial spirit by participating in a local value-added economy. They do this in a number of ways, such as raising food or making a product using locally grown produce. This could include baking bread or making pasta, preparing specialty meats or cheeses, brewing beer, processing wool, or any of a number of other products. Not all regenerative activities need to be agriculturally based, though. There is a growing movement of self-described makers that are using high technology to produce their own customized products, rather than relying on mass marketing and disposable consumer items. This might include anything from sewing their own clothes to using recycled materials to creating inexpensive electronic microcontrollers to monitor soil moisture and water the garden. Maker spaces are popping up all over the country. They are a great place to find a community of like-minded people. Repair is once again on the rise. Once, everybody took a TV in to be repaired, but now we usually just throw it away and get a new one. But that trend is changing. Websites like iFixit.com provide free instructions for repairing a huge range of things from cars to cell phones. In cities across the U.S., repair salons or repair cafes are popping up. Weekend get-togethers that are designed to allow people to share their skills with others, learn new skills, and get their stuff fixed for cheap. Finally, buying used items is easier than ever. Nice consignment shops are now a fixture in every trendy neighborhood, and websites like eBay and Etsy make it easy to find good quality, gently used stuff. After all, the greenest products are those that we use again and again, rather than buying new. Another revolutionary idea that is popping up across communities and neighborhoods all over the United States is sharing. Yes, I know it sounds crazy, but after decades of living an American dream that includes owning your own lawnmower, people are discovering that most of the time, that lawnmower is sitting unused. So are the chainsaw, the weed whacker, and the rototiller. It just makes sense for neighbors to share these items. Not only does it make environmental sense, but it also saves money and builds a stronger sense of community. Even car sharing services are gaining in popularity. Right now, we are at a great place in the discussion to go back to the ideas of recycling and upcycling. Obviously, repairing items rather than throwing them away and buying used items are both related to recycling. What are the bigger implications of converting what would otherwise become waste into reusable resources? Let's talk about some new trends in recycling. Returning to ideas put forth by William McDonough and Michael Braungart in Cradle to Cradle and in other writings, what we generally think of as recycling might more accurately be described as downcycling. By this we mean that used products like scrap paper can be shredded, pulped, and made into toilet paper. Glass bottles can be crushed and added to asphalt to make paving materials. What we are doing here is getting one more use out of the raw materials before they flow on down the waste stream and eventually end up in the dump. On the other hand, materials like aluminum or steel can be recycled back into new aluminum or steel using far less energy than it takes to mine ore and smelt new metal. We have already talked about cradle to cradle and upcycling a little, but let's look at how McDonough and Braungart define it. They propose two systems for cycling materials, a biological metabolism and a technical metabolism. The first is based on nature's biological nutrient cycling systems. It's for materials like biodegradable packaging that can safely be returned to the environment to nourish living systems. The second is a closed-loop system where high-tech synthetic and mineral resources like steel and aluminum circulate in a perpetual cycle of production, recovery, and manufacture. These cycles mimic the Earth's cradle-to-cradle systems, like the ones that cycle calcium and carbon. Both these cycles are closed loops, constantly breaking down and recombining our materials rather than allowing them to be lost in the waste stream. In nature, the sun powers these cycles, and it can in the human economy too. The concept of entropy is at work again. Sustainable upcycling uses solar energy to continually create products of the same or better quality. For example, electronic components that are continually cycled into electronic components. As I mentioned earlier, conventional recycling is often downcycling, getting a few more uses from something before it eventually goes to the landfill. Nylon carpet becoming a speed bump that eventually ends up in the landfill is an example of downcycling. Now don't get me wrong, it's still better to recycle and get a few more uses out of the materials and energy embodied in a product than to simply throw it away. But the more sustainable goal is to develop a cradle-to-cradle economy. You can actually buy cradle-to-cradle certified products now. The Cradle-to-Cradle Products Innovation Institute has a website with a registry of cradle-to-cradle certified products. Before moving on, I want to add one more term to our list of recycling techniques. Repurposing refers to reusing waste materials for new and different purposes without melting them down, grinding them up, or otherwise turning them back into raw materials. In the old days, rural folks used to turn worn-out tires into tire swings, planters for flowers, or other folk art decorations. In a very simple way, this is repurposing. Colored glass wine bottles can be stacked with mortar to create beautiful garden walls. Old doors can be made into colorful painted fences, or old license plates can be made into purses. Creative people are finding a plethora of materials to create new products that are both functional and unique. Another way that innovative people are learning to establish a regenerative model in their communities is through the use of local currencies. Local currencies establish a way to trade value within a community without the use of the national currency. Local currencies create a more flexible system than one that is based simply on bartering. The value of goods or services can be exchanged within the community, but the value stays within the community. Sometimes different mechanisms are used to keep the currency circulating. For example, negative interest rates may be used to encourage holders to spend their currency before it devalues. If the currency isn't used, it loses a percentage of its value every month to encourage you to use it. In some communities, the system is based on an exchange of hours, in which individuals can, for example, trade their time as a house painter for the services of a lawyer. These systems are called time banks. The lawyer may not need painting services, but he can choose to take his payment in time from, say, a physical therapist that also has chosen to participate in the time bank. All of these systems can work well, build community, and keep value local. But I have to raise a caution here. Local currencies must not be in any way mistaken for US dollars. That's what's called counterfeiting. It's not illegal to print money. You just can't make it look like US dollars. Local currencies must be clearly marked as what they are and cannot be used as money outside of the designated community. When it comes down to it, though, how much are we going to spend to transition to a more regenerative lifestyle? Fancy organic food costs a lot of money, right? And buying a new hybrid car is not cheap. I know. Well, let's look at some of the personal economic implications of adopting a more regenerative lifestyle. When it comes to things like food, cleaning products, soaps, body care, organic costs about 20% more than the non-organic equivalents, according to the Organic Consumers Association. But a report published by TechSci Research predicts that the United States organic food market revenues are expected to grow at an average rate of around 14% between 2013 and 2018, despite these higher prices at the checkout counter. Why are organic groceries more expensive, and why are people willing to pay higher prices for organics? To answer the first question, greener products are often more expensive for several reasons. First, the market for organic and green products is smaller, but as demand and supply rise, prices drop. So if the SciTech report is correct, we should see prices of greener products falling. Organic and green products are usually more labor-intensive to produce. Chemical shortcuts like harmful herbicides and pesticides cannot be used in the growing or processing of organic products. Another reason that organic foods cost more is that they receive relatively few subsidies compared to conventional commodity agricultural crops. So processed foods may be artificially cheap, while healthier fresh fruits and vegetables cost more. So why are more and more consumers choosing to pay more despite the higher price tag? In some cases, the products are of better quality, provide better service, and are therefore worth more. In other cases, people are willing to pay more for the health benefits and satisfaction that come from being part of creating a more sustainable world. For example, organic foods often have superior taste and nutrition, have no agricultural chemical residues, and are grown in ways that increase the fertility of the land over time rather than diminish it. Another reason that people are willing to pay a higher price for their food is concern about animal husbandry, the practices of large-scale confinement agriculture. Again, these practices are cheaper for the producer. However, more and more shoppers are looking for eggs from humanely raised chickens and meat and dairy from animals raised in pastures without antibiotics and other drugs. Many organic food buyers are also concerned with the welfare of workers and want to support local workers and local economies. Because these products are produced on a smaller scale with less mechanization, they often create more jobs than conventional products. According to the UN Food and Agriculture Organization, organic agriculture creates new jobs in rural development not only in the US, but in other countries as well. So now, let's review a few keys to moving toward a sustainable personal economic model and establishing a regenerative footprint. First, always remember to make informed choices. Don't trust that a package that says all natural is really sustainably made. Do your own research. Look for third-party certification. Then, evaluate your priorities. Consider where and how you want to vote with your dollars. Sometimes that means spending a little less for something. Sometimes it means spending a little more. Look for opportunities to shop locally. Buy used. Share and repair when appropriate. Upcycle and repurpose. Grow and make your own. By becoming an informed consumer, reducing waste, and actively participating in your personal environment, you can move toward a healthier, cheaper, and more regenerative lifestyle. In 1930, economist John Maynard Keynes wrote an essay called Economic Possibilities for Our Grandchildren. In it, he predicted that the productive power of the industrial economy would solve the economic problem of humanity within 100 years. Then, he said, humanity would go on to the permanent problem of how to live wisely, agreeably, and well. In many ways, the sustainability movement is the quest to learn how to live wisely, agreeably, and well. Living well is the material dimension of sustainability. We are material beings and need food, shelter, and other necessities of a good life. But contrary to what many economists would have you believe, it's not all a matter of economics. Economics is important, and it's how we obtain the material requisites of a good life. But we are also social beings. We need to love and be loved. Living agreeably is this social dimension of sustainability. Living wisely relates to the ethical and spiritual dimension of sustainability. We are spiritual beings. We need a sense of purpose and meaning. Keynes was pessimistic. In wealthy Western countries like the US, we reached the point where we had the capacity to solve the temporary problem, the material requisites of a good life, in the 1950s. Research from the growing field of happiness studies indicates that below $10,000 to $15,000 per capita income, increases in wealth lead to corresponding increases in human well-being, like you would expect. But beyond $10,000 to $15,000 per capita income, increases in well-being and satisfaction have more to do with better social relationships and a sense of meaning in life. People need to believe what they are doing is significant and that their actions are, in some sense, right and good. Once essential human needs are met, human happiness or quality of life depends far more on cultivating the social and spiritual dimensions of life than on acquiring more income or wealth. In this lecture, I'll introduce the emerging field of sustainable economics. We'll explore why sustainable economics involves more than simply putting a price on social and environmental damage caused by economic activity and letting the market work it all out. Economics is about how we get our individual material needs met. Throughout most of history, material comforts were the limiting factors to a good life. It made sense to focus on material, economic values as the way to improve human well-being. Today, however, for many people, material comforts are no longer the limiting factor in a good life. We lack time for rewarding relationships with other people, to pursue our interests, and to give back to others. We lack a sense of purpose and meaning. Sustainable economics recognizes the importance of relationships and a sense of doing what is right and good as forces that should drive economic policy, not the other way around. Economies are not capable of creating anything of value. They simply facilitate the process of extracting things of value from natural and human resources. Economies are necessary when we go beyond individual self-sufficiency. If we could get all of our needs met directly from nature, we wouldn't need an economy. What does a sustainable economy look like? What I present now reflects the work of ecological economists like Herman Daly and borrows heavily from the pioneering work of my colleague and sustainable economist John Eichard. Here's a definition of sustainability we've been working with, put in terms of economics. Economic sustainability is meeting the economic needs of the present without diminishing the economic opportunities of the future. Sustainable economics works to ground economics in the real world, including the physical sciences, physics, chemistry, and biology. Sustainable economics says that people must obey nature's laws. Unlike abstract concepts like money, real objects like people and cars and trees cannot grow exponentially forever. In nature, things grow, they have a period of stable functioning, and then they die. Sustainable economics recognizes limits imposed by nature on how much of the resources of the earth can be dedicated to serving human needs. In the lecture on energy and sustainability, we looked at energy and the deep and somewhat mysterious role it plays in the development of order and structure in the universe. Let's review it again in the context of economics. Energy isn't destroyed by use. However, each time energy is used, it becomes less concentrated, less organized, and thus less useful than before. Eventually, all energy becomes unable to produce anything of economic value. This lost usefulness is a result of the physical law of entropy. An economy that depends on non-renewable sources of energy like fossil fuels is not sustainable. As fossil fuels become increasingly scarce, their ability to produce things of economic value will diminish and eventually be lost. Even as such an economy continues to grow, the energy needed to meet the needs of future generations is unavoidably diminished and will be depleted. Society requires energy too. People are born as helpless babies and need to be educated and socialized to become productive members of an economy. All this takes energy. Even our thinking and inventing takes energy. 20% of the energy used by the body is used by the brain. There is also a kind of entropy of social energy. Relationships and social structures need to be renewed and refreshed regularly. From this perspective, an economy is a system for optimizing the conversion of low entropy energy and materials to high entropy energy and materials, extracting usefulness in the process. The production and consumption of goods and services inevitably leads to the conversion of low entropy energy to high entropy energy. Thus, economies inherently lead to the degradation of materials and energy, in other words, to the production of waste material and wasted energy. Anything of use to people is ultimately derived from nature and society. If, in the process of getting our economic needs met, we use up the usefulness of nature and society, then there is no place else to get anything of economic value. To offset this, physics tells us we need a high-quality source of energy and systems that will use this energy to recycle and renew the usefulness of materials. In nature, biology uses sunlight to offset the effects of entropy. We can use nature as a model as we work to develop an economy that regenerates and renews. In this sense, a sustainable economy is all about sustainable energy. The source of sustainable energy on Earth is solar energy in all its forms. Solar electric, wind, hydroelectric, biomass, and more as we've been discussing. Now here's a diagram that's often used to describe the relationship of the environment, society, and the economy to sustainability. The place where the economy, society, and the environment intersect is considered the sweet spot of sustainability. From this perspective, the only parts of nature and society that are useful to the economy are those that can be assigned economic value and move to the sweet spot of this intersection. Here, the goal is to assign economic value to the environmental and social damages so that market forces can recognize and can deal with them. There are a couple problems with this diagram. First is that it would lead you to believe that some part of society isn't part of nature, and some part of the economy is not part of nature or society. But that isn't true. Societies are embedded in and a part of the larger environment of the earth, and economies are a creation of societies and are embedded in them. The second problem is that it leads you to believe that we can ameliorate the social and environmental damages caused by economic activity by assigning them dollar values and letting the market work it out. Social values can have an economic element. Doing business with people you know and trust reduces transaction costs. But purely social relationships are inherently different than economic relationships. You can find a new friend, but you can't trade friends with someone. Once a purely personal relationship ends, its value disappears. There is no product left that can be traded, rented, or sold to anyone else. There is no way to monetize social relationships and turn them into marketable goods. We can also assign an economic value to some kinds of ecological damage and make the polluter pay. But the ethical relationship we have to care for the environment is inherently different than an economic relationship. Like social relationships, purely ethical relationships produce nothing of economic value that can be exchanged or traded to anyone else. There are social and environmental things that we need to do for sustainability that don't lend themselves to market solutions. Another problem with putting a dollar value on social and ecological damage is that those with money can simply pay to continue to do damage. Now, don't get me wrong. We can use market economies to help some environmental and social problems, but we can't rely solely on market economies to deal with problems of social and environmental sustainability. We don't have time to go into detail on all the differences between economic, social, and ethical relationships and values. I hope I've given you enough here so that you can begin to see some of the problems with trying to use economies and markets to deal with these essential elements of sustainability. If you are interested in exploring these further, I recommend the work of economist John Eichardt. He's developing the core theory for a sustainable economy that works for everyone. Now I'd like to show you another diagram that I think paints a more realistic view, an ecological, sustainable worldview. Here you can see that the economy is entirely bounded by society and is structured by the laws and policies of society. And society is in turn entirely bounded by nature and is structured by the laws of nature. This type of relationship is called a nested hierarchy, what economist John Eichardt calls the hierarchy of sustainability. Within a nested hierarchy, purpose is derived from the next highest level of organization, and lower levels define the possibilities for the higher levels. For example, if we think of the human body as a nested hierarchy, the purpose for the heart is defined in relation to the body as a whole. And the heart affects the potential of the body. By beating faster, it provides the potential to exert extra energy, and quitting the heart stops function of the body. Like this, the purpose of the economy is derived from society, and the economy affects the potentials for society. The purpose of the economy being derived from society suggests that the economy should be put in service to society and the environment. Currently, it's the other way around. We do things that are good for society or the environment only if they don't negatively affect the economy. To respect the hierarchy of sustainability, the order should be, is it good for the environment? Is it good for society? And finally, can we afford it? The idea that the economy affects the potentials of society suggests that we need to make enough surplus from the economy to cover the economic costs of the non-economic things we need to do for society and the environment, such as funding the essential functions of government. There are economic costs for ensuring social equity and justice, protecting the environment, and conserving natural resources. This diagram also suggests that one of the roles of society is to put constraints on the economy so that society and the environment aren't exploited by the economy. Sustainable economics is about putting economic value in proper relation to social and environmental value, respecting the hierarchy of sustainability. Let's talk about sustainability and economic growth. The mantra of the industrial era is growth is good. We've created an economy where improvement in the human condition is predicated on continuing growth year after year in throughput of materials and energy. This kind of growth is called compound growth. Let's look at some examples of how compound growth affects sustainability. One of the basic principles of economics is that humans have a preference for the present. The future is inherently uncertain, and if we give up the use of something today, there's a chance that we will not be able to enjoy it in the future. A blunt way to put this is there is no way to get anything of economic value after you are dead. That's why we have interest rates. At an interest rate of 7%, $1 10 years in the future is only worth 50 cents today, because that 50 cents could grow at a compound rate of 7% and yield $1 10 years later. And $1 100 years in the future is worth only a tenth of a cent today. That's why something that has a big payoff or the potential to cause a big expense for a future generation has very little economic value today. Investments for the benefit of future generations cannot compete with investments that promise returns next year, next week, or even next decade. The corporate world expects rates of return of 15%, which means $1 5 years from now is worth only 50 cents today. That's why many corporate planning horizons extend only 5 to 7 years into the future, because any value or expense occurring after that is rapidly discounted to zero today. Because economic value is inherently short-term, economic incentives alone are inadequate to ensure the long-term investments in nature and society that are absolutely necessary for sustainability. Remember our definition of sustainability: meeting the needs of the present without diminishing the ability of future generations to meet their needs. We've just seen that there is no economic value to doing things that provide a benefit solely for some future generation. There's no social value in doing so either. You won't know anyone, and you may not even have any descendants. Doing something for the sole benefit of future generations is an ethical value. We do so because it is the right and good thing to do. So economic values are important for sustainability, but ethical and social values are also necessary. According to many, the growth rates of the industrial era were an aberration, and such growth rates do not seem to be sustainable in the future. Nothing in nature grows at compound growth rates for very long. To get 1 million times bigger requires only 22 doublings. Very few things double in size more than 10 times. If an economy grows at a compound rate of 2.5%, modest by industrial era standards, it will double every 30 years. If this keeps up over time, then eventually the economy overwhelms all the systems of the earth. Here's a little thought experiment that illustrates this. Let's say that the output of the global economy 2,000 years ago was $1. If it grew at a rate of 2.5% per year until now, it would generate an economic output of $3.6 sextillion today. That's 3.6 followed by 20 zeros. This is the equivalent to 7 billion people spending nearly $1 million every minute of every day of the year, and it would more than double over the next 30 years. Obviously, the economic growth rates of the industrial era will not be sustainable into the future. Stocks of fossil energy have allowed a period of compound economic growth, but those stocks are finite. The global economy of the next century must be sustained by the daily inflow of new solar energy. Solar energy available for economic use is large and relatively constant, but it is finite too. The sustainable level of economic wealth on Earth is ultimately limited by the quantity of economic value that can be extracted from the daily inflow of solar energy without degrading the capability of the natural systems of the Earth to provide their essential services, like assimilating waste, maintaining the fertility of the land, and purifying water. Well, what to do then? Well, it's the concept of a steady-state economy that provides a logical conceptual foundation for the development of a sustainable economy. In nature, an organism that grows forever is a pathology. People are born, go through a period of rapid growth, go through a period of stable functioning, and then they die. A steady-state economy is like a mature forest ecosystem. At any given time, there are areas of the forest that are going through cycles of growth and expansion, areas that are in a period of stable functioning, and areas that are dying. Overall, the flow of energy and materials through the forest is constant. Like that, a steady state economy will have organizations being formed, organizations going out of business, and organizations in a period of stable functioning, but the overall flow of energy and materials will be constant. Let's look at the idea of steady state economies in a little more detail. In 1848, the classical economist John Stuart Mill proposed the stationary state economy in reactions to assertions by other classical economists like Adam Smith and Malthus that the end of growth must result in catastrophe. Neoclassical economics, which replaced the classical economics of Mills and Smith, was in a large part an effort to refute limits to economic growth. In the developing era of sustainable economics, people like Herman Daly, Peter Victor, and John Eichert have revisited the idea of a steady state economy and updated it for sustainability. A steady state economy is defined as an economy that maintains a constant population, a constant supply of labor, and constant stocks of natural and financial capital. Sustainable energy sources are sequestered from the daily inflow of solar energy, leaving enough solar energy for the other living creatures on the planet. Materials are put into cycles that mimic nature's biological and mineral cycling systems, the cradle-to-cradle systems proposed by McDonough and Braungart. The concept of waste is eliminated, and the output of one system becomes the input of another. Does a steady state economy mean the end of innovation, evolution, and improvement in the human condition? A steady state economy does not imply stagnation of creativity and human development. In John Stuart Mill's words, it is scarcely necessary to remark that a stationary condition of capital and population implies no stationary state of human improvement. There would be as much scope as ever for all kinds of mental culture and moral and social progress. Let's go back to our mature forest ecosystem analogy. Even though the flow of energy and cycling of water and nutrients is constant or steady state, there are always parts of the forest going through rapid growth and development, other parts that are maintaining their current state of development, and other parts that are dying. There is innovation and evolution going on, and these could be at a higher level than in a pioneer stage of forest development when most resources are tied up in physical growth. As in an ecosystem, the pioneer growth phases of an economy suck up a lot of resources. A steady state economy could actually have more resources devoted to innovation and creativity than a growth economy. Next, let's look at employment and sustainability. Many of our current employment policies are a throwback to an early industrial era when the Earth's resources seemed unlimited, workers were few, and the basic material needs of people were many. The objective was to increase total production by increasing productivity per worker, so that each worker would be able to earn more and spend more and promote even greater economic growth. At the same time, technology was used to replace workers whenever possible. Today, the Earth's remaining natural resources obviously are limited. There are more workers than employment opportunities, and material well-being is no longer the limiting factor to the happiness or quality of life for many people in the world. Today, in 2014, the need is to create more employment opportunities from less material and energy use. What about using technology to put more people in satisfying work rather than using technology to employ fewer people? Full employment of a growing population would not require returning to labor-intensive production or human drudgery. It would only require turning the attention of the economy to producing things that depend more on uniquely human thinking, creativity, imagination, insight, and intuition. Industrial mass production seemed a logical vision for the past when people were few and resources were many. But it is less a logical vision for the future with lots of people and relatively fewer resources. One innovative way to handle the problem of cyclical unemployment is to share the available work. If there is 10% unemployment, send everybody home at noon on Friday. This would provide jobs for more people by reducing working time by 10%. This could also leave more time for family and other non-economic pursuits, leaving people enjoying life more by working less. It wasn't always this way. In his landmark book, Stone Age Economics, anthropologist Marshall Sahlins studied the economies of Stone Age hunter-gatherers. The myth is that pre-industrial life was short, brutish, and hard. What Sahlins found is something quite different. Stone Age societies were the first leisure societies. Material needs for food, clothing, and shelter were met by working as few as 15 hours per week, with many of the tribe not gainfully employed at all. The rest of the time was spent in social engagement and developing art and craft. There is a growing trend in some industrialized countries to put the benefits of productivity gains toward working fewer hours. France and Germany have 30 to 35-hour work weeks and mandated 6-week paid vacations. In 1930, the Kellogg Company successfully experimented with a 30-hour work week. Productivity gains from a shorter work week allowed Kellogg to pay essentially the same wage for a 30-hour week as for a 40-hour week and to employ hundreds of new people. Working less means you could dedicate more time to producing the goods you previously bought, like garden produce. We'll return to this idea when we discuss the maker movement in a few minutes. There is even a political party dedicated to promoting the benefits of less industrial work. It's in Canada, and it's called the Work Less Party. One of the keys to a steady state economy is low or no population growth. Progress is beginning to be made in curbing population growth. Some wealthy European countries like France are experiencing negative population growth. The UN estimates that global population will stabilize at about 9.2 billion people by 2075. If the global population were stabilized, the Earth would quite likely have more than enough resources, including the daily inflow of solar energy, to meet the basic needs of people in both developed and developing countries. The world of the future will have enough energy to sustain a desirable quality of life for humanity, just not enough energy to sustain the same sort of economic growth seen in the industrial era. Many so-called developing nations of the world still need to focus on their economic problem, on producing enough to meet the basic human needs of all within their societies. However, these nations need not consume all of the Earth's remaining resources in the process of developing their economies. In addition, they can develop their economies without sacrificing their cultures, communities, and families. Such nations can balance their necessary economic growth with equally necessary social responsibility and ecological integrity. The degrowth movement advocates for a planned transition to a sustainable economy rather than one forced by ecological, financial, or social collapse. Degrowth advocates argue that, as a complement to building a steady-state, sustainable economy, we need to degrow the negative effects of the growth economy, things like poverty, homelessness, exploitation, pollution, carbon intensity, species loss, and work hours. Degrowth aims to maximize happiness and well-being through non-consumptive means, sharing work, consuming less, while devoting more time to art, music, family, culture, and community. Reimagining and reinventing the good life lies at the heart of any transition to a sustainable, low-carbon economy. High consumption lifestyles simply cannot be adopted by 9 billion people while keeping within the material, energy, and ecological limits of the planet. Degrowth advocates argue that an adequate response to these limits requires more than minor changes to current lifestyles. It will require a cultural paradigm shift away from high consumption lifestyles towards a way of life informed by principles and practices of material sufficiency, knowing when to say enough. Research indicates that high consumptive societies are misconsuming. Many people could reduce their consumption while increasing their well-being. The world is both starved and stuffed. People are suffering from obesity and people are starving. Countries suffer from excesses of overconsumption while other countries struggle with meeting basic material needs. There is the possibility for wealthier countries to cut consumption and improve lifestyles, making room for the many in the world that can still benefit from economic growth. Given that we don't have many policies in place for sustainable economies, what can we do now with our purchasing and investment decisions? We vote in the polling booth at election time, but we vote every day with our purchases and investment decisions. How we spend our private and public money is one way of voting for what kind of world we want to live in. How can we begin to make the transition to a sustainable economy using the collective power of our purchasing and investment decisions? First, respect the hierarchy of sustainability, not always choosing the lowest priced item without regard to social and ethical factors. Cost is important, but it should be considered in the hierarchy of sustainability. Something like this: do I get a sense of rightness and goodness? Is it good for the environment? What are the consequences for my social relationships? And finally, can I afford it? There are certifications that can help sort through these kinds of decisions and new forms of business organization that work to expand social and ethical values in business, like B Corp certification. There is a movement in the investment industry called socially responsible investing, or SRI. SRI has been around since the 1700s. One segment is mutual funds that are screened for a wide variety of sustainability criteria. For example, there are socially responsible investment funds that allow you to invest only in companies that are involved in renewable energy. You can also gather with your friends in an investment club that helps finance sustainability initiatives in your community. You can begin to go from passive consumption to co-production. One example is home food production. Learn skills that were once common, like fixing things and making stuff. In this lecture, we've explored the core concepts for a sustainable economy. We've seen that the economy is about meeting the individual material needs for a good life. Sustainability means respecting the hierarchy of sustainability, an economy in service to humanity and nature, and humanity functioning in harmony with the laws of nature. We've seen the limits to compound growth and explored the benefits of a steady-state economy, an economy that functions in balance with the flow of solar energy and cycling of materials like a mature forest, dedicating a significant portion of its resources to offset the effects of entropy, to regeneration and renewal for future generations. I'll close with a 1968 quote from Robert Kennedy that reflects this idea of putting the economy in its proper relation. The gross national product does not allow for the health of our children, the quality of their education, or the joy of their play. It does not include the beauty of our poetry or the strength of our marriages, the intelligence of our public debate, or the integrity of our public officials. It measures neither our wit nor our courage, neither our wisdom nor our learning, neither our compassion nor our devotion to our country. It measures everything, in short, except that which makes life worthwhile. In this lecture, we'll go from looking at the outer elements of sustainability, solar energy, eco-cities, and organic agriculture, to the inner elements of sustainability, spirituality, holistic health, well-being, and the good life. Sustainability is about connection, how sustainable systems for energy, food, water, and buildings relate. In sustainable systems design, resilience emerges from the number of connections between elements, not the number of elements in the system. We've seen how everything is connected in space and time by the great cycles of air and water movement on the Earth, driven by the sun. But there is a deeper level of connection. If you look at the writings of the early leaders of the sustainability movement, they often talk about an underlying unity that is at the root of the surface diversity of the universe. Here's a quote from Masanobu Fukuoka, author of One Straw Revolution. One thing is all things. To resolve one matter, one must resolve all matters. Changing one thing changes all things. And here's one from Ralph Waldo Emerson, often considered to be the founder of the conservation movement, a precursor to the modern environmental and sustainability movements. Every particular in nature, a leaf, a drop, a crystal, a moment of time, is related to the whole and partakes of the perfection of the whole. Huston Smith, one of the founders of the field of religious studies, saw that the world's wisdom traditions were linked by what he called perennial philosophy. Smith suggests that a common element of the world's religions is the understanding that the divergent outer aspects of life emerge from and are connected at a common source, which he and the writer Aldous Huxley called the divine ground. Others call it being, source, or pure consciousness. Smith found that another experience common across cultures is the direct experience of this underlying unity at the core of human consciousness, sometimes in the beauty of nature, sometimes during prayer, and sometimes during meditation. The perennialists go a step further and say that connecting with this source is the highest purpose of human life. Many of our ecological problems can be seen as a disconnect. Disconnect of people with the land, people seeing themselves as separate from nature, disconnect from the larger society, disconnect from a sense of purpose and meaning. Huxley, Smith, and the other perennialists suggest that the primary cause of all these disconnects is a disconnect with our own inner nature being. Here's Emerson again. The reason why the world lacks unity and lies broken and in heaps is because man is disunited with himself. Huxley goes on to suggest that humans can heal the outer disconnects by direct experience of this underlying inner unity, and that this experience results in a fuller and richer life. Deep sustainability explicitly recognizes a core unity of nature that is at the heart of the surface diversity of life. Sustainability is the intellectual understanding and practical application of the interconnectedness of human and nature. That's one way of looking at it. But the direct experience of this interconnectedness complements the intellectual understanding of it, and it leads to more holistic understanding of sustainability. How can we reconnect with something deeper than our surface life, the wholeness that underlies the surface? Well, some people do it through religion, some people do it by direct experience of nature, and some people do it with formal techniques of meditation. Whatever its form, I think some way of directly experiencing being is an essential part of a sustainability worldview. It's at the heart of creating a sense of purpose and meaning. The perennialists argue that people need this spiritual connection like they need air, water, and food. The unsustainable world around us is a direct result of a worldview where the experience of being is missing. For myself, having that connection to being through daily meditation is the single most meaningful and useful thing I do. I began meditation as a way to help me cope with college life as an undergraduate, and because I read a book called Cosmic Consciousness by Richard Buck. 20 minutes of meditation was promoted as being as restful as several hours of deep sleep, so I figured if I meditated, I could stay up and party longer. There was a Transcendental Meditation Center that I passed by on the way to the university every day. There had been a lot of scientific research done on TM indicating that Transcendental Meditation has a wide range of holistic benefits, so I decided to give it a try. I've since learned that not all meditations are the same. They use different procedures and have different effects. The meditation I do is a simple mental technique that allows the body and mind to naturally settle down to a state of deep rest. I meditate in the morning for 20 minutes before I start out in the world, and I meditate 20 minutes in the afternoon before dinner. My days are hectic and filled with activity related to my work as co-director of my academic department, teaching, and sustainability consulting work. I particularly enjoy my afternoon meditation as it allows me to reset before spending time with family and friends, or in a lot of cases, another round of work. The less important things dissipate and the more important things are seen in a fresh light. Even though I don't specifically think about solving problems during meditation, as my mind settles down and experiences deeper levels of awareness, I often have flashes of insight into problems I'm working on. Meditating film director David Lynch calls this diving deep to catch the big fish. Outside of meditation, I'm more relaxed and better able to meet the challenges of my busy life. There's a broad body of studies that confirm a wide range of benefits for this simple meditation practice. In a Scientific American article published in 1973, Keith Wallace argues that the state of restful alertness brought on by TM is a fourth state of consciousness, distinct from waking, sleeping, or dreaming. It is characterized by awareness without an object of perception. It's as if you have been watching a movie, and all of a sudden the movie stops and you see the screen the movie has been projected on. Over time, you begin to experience more clearly the underlying unity of consciousness that is at the source of your thoughts. And with continued practice, you begin to experience that same unity in the outside objects of perception. It's not so much an intellectual understanding as a direct perception. You can experience the unity of nature through intellectual understanding or observation on the outside, and you can also experience the unity of nature by going inside as well. It seems like a paradox until you have the experience of it, but this inner unity is the source of outer diversity. But what does all this have to do with sustainability? As I mentioned at the beginning of this lecture, sustainability is the intellectual exploration and practical application of the many ways in which nature and humans are interrelated. And this interrelation has its core in the underlying unity of nature. The meditation practice I do, Transcendental Meditation, is not a religion. People of all faiths practice TM, as well as people who are agnostic. But what do faith-based organizations have to say about sustainability? Let's explore that next. There are many flavors of all the world's major religions. One thing religious communities have in common is that most are interpreting their own ancient traditions and practices to encourage environmental awareness, sustainability, and the relation of humans to nature. The group Interfaith Moral Action on Climate, IMAC, includes leaders from Hinduism, Buddhism, Christianity, Judaism, the Sikh religion, the Islam religion, Native Americans, and more. Their mission statement reads, "Virtually all the world's religions and spiritual traditions proclaim that we have a moral obligation to be good stewards of the earth and all its creatures and processes, to disrupt the climate that is the cornerstone of all life, and to squander the extraordinary abundance of life, diversity, and beauty of the planet is a moral failure of the first order." Many of the religious and spiritual practices of indigenous people, including modern ones like the Native American Church, are explicitly grounded in an ethic of care of the earth and sustainability. Here's a quote from Black Elk. "The first piece, which is the most important, is that which comes within the souls of people when they realize their relationship, their oneness with the universe and all its powers. And that this center is really everywhere. It is within each of us. This is the real peace, and the others are but reflections of this." This is from The Sacred Pipe, published in 1953. The U.S. Conference of Catholic Bishops states, "Care for the earth is not just an Earth Day slogan. It's a requirement of our faith. This environmental challenge has fundamental moral and ethical dimensions that cannot be ignored." In Cedar Rapids, Iowa, not far from where I live, there is a group of Franciscan nuns that operate an environmental and spiritual retreat center called Prairie Woods. It uses a wide variety of sustainable technologies, including passive solar building design, straw bale construction, solar hot water, and organic food production. For many years, they had the largest solar array in the state of Iowa and have hosted a wide range of environmental events, including the annual Iowa Renewable Energy Expo. In the U.S., the Christian tenet of stewardship is seen in a concern for the environment and sustainability. Many work to educate against excessive consumerism. Churches operate a lot of buildings and vehicles. By implementing energy efficiency strategies, they can use the money saved to further their spiritual and environmental missions. Christian communities all over the U.S. are centers for organizing environmental initiatives, including energy efficiency, solar energy installations, and conservation and stewardship initiatives. Interfaith Power and Light works with congregations nationwide on energy efficiency and renewable energy policy initiatives. Many churches are centers for community gardening. A church near where I used to live in Hawaii sponsored a large community garden in the city of Pahoa. In Islam, core environmental concepts include a belief that all things in the world are related to each other, that balance in nature must be maintained or restored, and the fruits of the earth may be enjoyed, but its resources must not be wastefully exploited. Judaism has a wide range of green organizations, including the Green Zionist movement. Jews observe an annual New Year of the Trees holiday with tree planting and other ecological efforts, and celebrate by eating grapes, figs, pomegranates, dates, olives, and the grains of wheat and barley. Religion often explicitly refers to the interconnectedness of things, as we discussed earlier. The interconnectedness of things is at the heart of sustainability. The Reverend Martin Luther King Jr., in a speech given for Christmas 1967, says this about religion, sustainability, and the interconnectedness of things. It really boils down to this, that all life is interrelated. We are all caught in an inescapable network of mutuality, tied together into a single garment of destiny. Whatever affects one directly affects all indirectly. We are made to live together because of the interrelated structure of reality. Before you finish eating breakfast in the morning, you've depended on more than half the world. This is the way our universe is structured. This is its interrelated quality. We aren't going to have peace on earth until we recognize the basic fact of the interrelated structure of all reality. And this is from King's 1967 Christmas sermon on peace. So let's talk a little bit about health and wellness and a more holistic approach to medicine. I'm the co-director of the Sustainable Living Program at Maharishi University of Management. A few years after we started the program, I noticed that many students double major in sustainable living and physiology and health. They recognize that the health of the individual and the sustainability of the planet are intimately linked. Many of the same processes that compromise the health of the planet also contribute to an epidemic of diseases like obesity and diabetes. Just as sustainability has given us more holistic approaches to how we provision ourselves with food, water, housing, and energy, new approaches to medicine are taking a more holistic look at human health and well-being. Some of these approaches, like Chinese medicine and Ayurveda, which is from India, are based on traditional medical systems. These approaches, even though they're called alternative in the West, have been in continuous use by large numbers of people for thousands of years. Some approaches, like chiropractic medicine, are newly developed. Conventional medicine has remarkable successes. Deaths and trauma injuries, infectious diseases, childhood mortality, and many other afflictions have all dropped dramatically due to modern medical advances. But wealthy Western countries with extensive modern medical systems have seen an increase in diseases that have been stubbornly resistant to treatment, like heart disease, obesity, and cancer. These diseases are aggravated by the lifestyle demanded by the industrial economy, widespread use of toxic chemicals, and the foods delivered by industrial agriculture. John DeGraff calls the ills that continue to plague wealthy countries affluenza in a book he wrote with the environmental scientist David Wan and economist Thomas Naylor. The full title of the book is Affluenza, the All-Consuming Epidemic. It's also been made into a film. There is an old saying, an ounce of prevention is worth a pound of cure. Holistic medicine focuses on preventative practices, using measures like nutrition, diet, and lifestyle for prevention and treatment of disease. Holistic medicine looks to take maximum advantage of the body's natural healing responses. Here are a few approaches and strategies used in the holistic health movement. Ayurveda is a holistic system of health care that starts with analysis of your particular body-mind type and imbalances. Your body-mind type is then used as the basis for recommendations on diet, daily routine, herbal supplements, behavior, and exercise. Ayurveda is the traditional medical system of India and has been in use for thousands of years. Aromatherapy uses fragrant natural plant oils for the purpose of altering one's mood or improving physical and psychological well-being. For example, some people find the scent of lavender to be very relaxing and soothing. The deep rest offered by regular practice of meditation helps keep stresses of everyday life from accumulating. Stretching exercises like yoga and breathing exercises called pranayama are often used in conjunction with meditation. There are many approaches to diet and nutrition within the holistic health movement. Some common elements include eating fresh, lightly processed food grown without chemicals. Michael Pollan, in his book In Defense of Food, offers this common sense advice: eat food, not too much, mostly plants. Other holistic approaches include exercise, herbal and nutritional supplements, homeopathy, chiropractic medicine, and massage. Next, let's explore the relationships between work, leisure, quality of life, and sustainability. The industrial economy promised fewer working hours for higher wages, but the reality today is that most Americans are working longer hours. Wages for many have stayed stagnant for decades or gone down. It doesn't have to be this way. There are many countries that are opting for a shorter work week, including France and Germany at 35 hours per week each. These countries have found that worker productivity per hour rises with fewer hours worked. In 1930, in the throes of the Great Depression, cereal magnate W.K. Kellogg decided to conduct an experiment. He replaced the 3 daily 8-hour shifts at his plant in Battle Creek, Michigan, with 4 6-hour shifts. Employees worked 30 hours under the new system in contrast to 40 hours under the old. The results? The company hired hundreds of new people. Production costs plummeted, and employees operated more efficiently, learning to prioritize leisure over work. Productivity was so high that Kellogg was able to pay roughly the same wage for the 30-hour week as was paid for the 40-hour week. And vestiges of this system remained in place until 1985. My wife is from France, and the French have a well-deserved reputation for seeing more to life than work, for putting the workday in its proper place. I've learned a lot about the possibilities for a different pace of life from my wife and from visits to France. Outside of the big cities, everyone still takes 2 hours for lunch. In France, businesses and government offices are closed at lunch. The only thing you can do is hang out with your friends and eat lunch. And many people get subsidies from the company they work at to buy lunch at a cafe. People get 6 weeks paid holidays, even if they have a low-level job or work for an American company. Most take it in August when the weather is nice and all their friends are on vacation. For this reason, lots of restaurants, businesses, and shops in Paris are closed for August. There's also a lot of concern about food. People talk a lot about it, including how to best grow it for flavor. Even people who have never been on a farm have an opinion about the best way to grow something. I once heard someone selling cheese at a farmer's market argue that the Comté cheese he was selling had a special quality due to the time of year. The cows were eating grass that had frozen in the morning, which he claimed had a positive effect on the flavor of the cheese. The French look for special qualities that come from a particular region or method of growing. They put an official government stamp on the best of these, called an AOC, Appellation d'Origine Contrôlée. The best known are for wine and cheese, but the AOC stamp also applies to lavender, chestnuts, olive, pastured poultry, and much more. I once asked a 10-year-old kid where the best chickens come from, and he immediately replied, poulet de Brest, chicken from Brest, an AOC where farmers are well known for growing free-range chickens. The Appellation d'Origine Contrôlée is much more than a marketing gimmick. It defines an authentic product and its methods of production. For example, the rules that define Roquefort cheese include requirements that the milk must come from sheep within a limited area around Roquefort. The milk must be raw, and the cheese must be produced, processed, and aged in Roquefort. The French recognize the tremendous impact that one area, one environment, the weather, the water, the soil, has on a product. It's called terroir. This is not arbitrary snobism, but a recognition that food is being produced within the abundant flows of nature we've talked about before. These rules also specify methods of sustainable production. All these rules guarantee that Roquefort remains a unique product of the region and not just a marketing scheme. That doesn't mean Roquefort is a small business, however. 3 million cheeses, about 18,800 tons, were made in 2005. It employs 4,500 people on 2,100 farms. It's worth about $300 million at the retail level. Contrast this with American viticultural areas, or AVAs. The Upper Mississippi River Valley AVA includes Iowa, Illinois, Minnesota, and Wisconsin. If you've traveled through these states, you know that there is little in common with growing grapes and making wine at one end of the AVA and the other. The AVA designations are simply a useful designation for marketing a wine from a broad region, little more. They say nothing about sustainability. In France, fridges are smaller, people shop more often and eat fresher food. In the block or two around my mother-in-law's house in Paris in the 11th arrondissement, there are several shops that sell really fantastic cheeses and 4 or 5 great bakeries. They are not seen as elite, and people of every socioeconomic status frequent them. At the end of her street, there's a farmer's market, run by the city, at least twice a week. Cafe life is alive and well, and people spend a lot of time with friends at cafes and restaurants. They rarely invite friends home. Their apartments are small, and they value the privacy of home. Plus, if you all go out, no one has to clean up. These social and cultural aspects of a good life are not as seen as something that is elite, only for the upper classes. Efforts are made to see that everyone can participate in what is good in life. The French feel that people have a basic right to pleasure. Even when engaged in satisfying work, a balanced life means time for friends, the arts, culture, and civic engagement. The slow food movement is an approach to sustainable living with the philosophy that sustainability increases pleasure and sensuality in life. The organized versions of it, including Slow Money and Slow Cities, have come out of the slow food movement. The slow movement is an organization opposed to the commodification and industrialization of life. More than just opposition, it also offers a positive alternative. An Italian, Carlo Petrini, and a group of activists started Slow Food in the 1980s with the initial aim of defending regional traditions, good food, gastronomic pleasure, and a slow pace of life. The movement has evolved to embrace a comprehensive approach to food and life that recognizes the strong connections between plate, planet, people, politics, and culture. Today, Slow Food represents a global movement involving thousands of projects and millions of people in over 160 countries. Slow Food even has a university, the University of Gastronomic Sciences, founded in Bra, Italy in 2004 by Petrini. In 2008, Petrini was named one of the 50 people who could save the planet by the British newspaper The Guardian. In the US, Slow Food is sometimes confused with an elite approach to gastronomy that involves eating only the most expensive and rare of foods, indifferent to where the food comes from and the social and economic conditions of the farmer. In contrast, here is Petrini's definition of eco-gastronomy, which I repeat from an earlier lecture. I like to know the history of a food and of the place that it comes from. I like to imagine the hands of the people who grew it, transported it, processed it, and cooked it before it was served to me. I do not want the food I consume to deprive others in the world of food. I like traditional farmers, the relationships they have with the earth, and the way they appreciate what is good. The good belongs to everyone. Pleasure belongs to everyone, for it is human nature. One of the advantages of my work with sustainability is that I sometimes get to meet my heroes. Here's a picture of me with Carlo Petrini at Slow Food Nation, a national slow food celebration held in San Francisco in 2008. 50,000 people attended. Does the slow food philosophy of buying fresh and local always cost more? Well, let me tell you a story about how we dramatically increased the amount of local food in the university dining service where I work. Although the main purpose of the project wasn't saving money, we ended up saving thousands of dollars per month over the extra overhead by buying locally. Many local farmers grow to standards that meet or exceed the national organic standards, but can't call their produce organic because they do not want to pay for or go through the effort of certification. Some are Amish farmers who feel that organic certification involves too much red tape. Our goal in the project was to begin to develop long-term relationships with farmers we trust and that trust us. We developed a standard we called Fair Food. We had 20 or so farmers that participate in a local Amish produce auction fill out a questionnaire about their farming practices. About 15 of the 20 met our standards for ecological farming practices and care of the land. We had further conversations with these farmers and began buying their produce. An Iowa State University study found that the average bite of food travels 1,500 miles from farm to fork. In contrast, we recently had a meal where 98% of the ingredients were sourced within 100 miles of the university. It included cabbage, grapes, several varieties of heirloom tomatoes and peppers, cucumbers, yellow summer squash, dairy products, zucchini squash, basil and other herbs, sweet potatoes, kale, chard, black beans, green beans, and the exotic cushaw squash. Many weeks my university dining service is 50% locally grown. We've saved about $3,500 per month on the cost of food for the cafeteria after subtracting the cost for a local foods coordinator who continues to develop relationships with farmers. Carl Honoré, in his book In Praise of Slow, gives examples showing most areas of life can be improved by the slow philosophy. The slow philosophy is not about doing everything at a snail's pace. It's a cultural revolution against the notion that faster is always better. It's about seeking to do everything at the right speed, savoring the hours and minutes rather than just counting them. Doing everything as well as possible instead of as fast as possible. It's about quality over quantity in everything from work to food to parenting. Honoré realized that things needed to change when he found himself contemplating the purchase of a book, 1-minute bedtime stories, looking to cut precious time spent with his children at the end of the day. Slow money, founded by Woody Tash and described in his book by the same name, is a kind of patient green capitalism that looks to connect investors with projects that don't fit into conventional finance. Most projects are related to farms or building capacity in local food economies. Securities laws that make it easy to invest in a shopping mall halfway around the world make it almost impossible to invest in smaller local projects. Slow Money is working to change that with local investment clubs and other ways to connect local money with local entrepreneurs and nonprofits needing cash. The Maine-based No Small Potatoes Investment Club has generously agreed to put all of its agreements and research on legal structures for local investing online. Check out their website if you would like to find out the details of how local investment clubs can work. Although it's not often seen in this light, I think Slow Food, with its emphasis on a better way of life, has the potential to be one of the most powerful sustainability and environmental organizations in the world. So far in this course, we've been discussing the outer aspects of sustainability. Earlier, we discussed how everything in the world is connected on the outside, how sustainable approaches to food, energy, water, and building are interrelated, how the economic, social, and environmental elements of sustainability are related. Sustainability is the intellectual exploration and practical application of this connectedness. In this lecture, we've changed our approach and explored connectedness from inside to outside. We looked at some inner dimensions of sustainability, sustainability in spirituality, sustainability in holistic health, and moving away from an industrial-era mindset with the slow food movement. In addition to the theoretical and practical aspects of connectedness, there is an experiential element. Humans can directly experience the essential oneness of nature through spirituality and through observation in nature. You can even make it part of your daily routine with meditation. Sustainability is about creating a fundamentally better and more satisfying quality of life. What have we learned about sustainability in this course? Well, first, there's the conventional definition from the Brundtland Report titled Our Common Future, which was commissioned by the UN in 1987. Sustainability is about meeting the needs of the present without compromising the ability of future generations to meet their own needs. Next, we add the understanding about the central role of energy and the second law of thermodynamics. The law of entropy states that as we use nature in human society, we use up the usefulness of it. Therefore, if sustainability is about leaving something for future generations, it requires that we dedicate a significant portion of resources and energy to regeneration and renewal of the natural and human resources that present and future generations depend on. The central challenge of sustainability is to design a world based on regeneration and renewal of human and natural resources. To do this, we need a continuously renewed source of high-quality energy to offset the effects of entropy. The main source of energy we have for that here on Earth is solar energy. Like nature, sustainable societies are rooted in solar energy in all its forms. Plants take sunlight and create complex chemistry, which is the basis of order and structure on Earth. For example, the long-term stability of the composition of gases in the Earth's atmosphere and the temperature of the Earth are maintained by a complex interaction between geology and life. Life creates the conditions for life. Human society needs to be based on a new set of principles that work in harmony with the laws of nature. Sustainable living is about designing, building, and maintaining sustainable communities. In this course, we've looked at new ideas for systems that provision us with energy, food, water, and materials, systems that put our waste into closed cycles, systems for economics and governance. What else do we have to do? Well, everything. We've got to rethink and redesign every aspect of human endeavor for sustainability. We're at the beginning stages of a 50 to 100-year sustainability revolution, and everybody on the planet will be involved. It will likely be bigger than the industrial and agricultural revolutions that preceded it. Like the beginning stages of the other revolutions, we can begin to see the broad outlines of sustainability, but the details will come with time. Like the other major shifts, at the end, we'll wake up with a completely different relationship to each other and to nature, with a different worldview, with a different way of being and doing in the world. This way of being and doing will involve a much more celebratory and collaborative relationship with nature, as opposed to the relatively adversarial one we have now. We can start at our front door. Becoming more efficient, using solar energy, and using non-toxic materials and processes can save us money and make our lives healthier. We should all embrace efficiency and substitution. But is that enough? Remember the definitions of deep and shallow sustainability. Shallow sustainability is using efficiency and substitution to reduce the effects of the existing system, but without doing much to change the overall worldview that the system is based on. It's motivated primarily by economic value. Deep sustainability puts efficiency and substitution in service to radical redesign based on a new worldview that uses ecology as a metaphor rather than the machine, complements reductionism with holism, and values many ways of knowing. Deep sustainability is grounded in an experiential and intellectual understanding of the unity that underlies the surface diversity of the universe. Deep sustainability is a new worldview. Deep sustainability gives priority to ethical and social values while recognizing the necessity of economic viability. Shallow sustainability, efficiency, and substitution are necessary but not sufficient. We need to be careful that the necessary doesn't get in the way of the sufficient. We need to make sure that efficiency is in service to doing the right thing. We need to go beyond being less bad to a positive good. At the same time, we have to start small most of the time, with small steps, like asking questions, watching this course, and trying out some of the steps I've suggested for finding sustainable opportunities in your home, your neighborhood, and your place of work. If you are headed to Canada in a car at 100 miles per hour and you really want to go to Mexico, is it enough to slow down to 50? It's enough if you recognize that that's just the first step. To be effective, you need to move toward that point at which you can turn around and go the other way. Being efficient at the wrong thing doesn't make it right. It only means that you are better at doing the wrong thing. The real opportunity for improvement in the human condition comes when we go beyond tweaking the existing paradigm with efficiency and substitution to a shift in worldview that is deep sustainability, regeneration, and renewal. Worldviews lead to a set of supporting technologies, infrastructure, and institutions. And in turn, the technologies, infrastructure, and institutions reinforce the worldview that underlies them. The worldview creates and continually recreates the world. Let's contrast the current worldview with a worldview of sustainability. In the excellent video Story of Stuff, Annie Leonard states that within 3 months of manufacture, more than 95% of the materials that flow through the economy are in the landfill. From these perspectives, the major outputs of the industrial economy of today are wasted energy, wasted materials, and wasted communities. We need to change from a consumptive, throwaway society to a producing and conserving society. Here's some ways to start. Check out your local thrift store. You'd be amazed at the number of items you'll find that are new or gently worn. Many still have the tags on them. Organize yard sales or yard swaps. Get your food from your backyard or local organic growers. Use renewable energy and use it efficiently. Buy from local merchants in your downtown. Are these values conservative or liberal? It's probably a good thing that it is a bit difficult to tell. In this course, we've been exploring the technologies, infrastructure, and institutions that flow from a sustainable worldview. The sustainable world is powered by renewable energy. It works in harmony with the natural hydrological cycles, bases agriculture on ecological principles, including the life in the soil. It organizes humans across the landscape in eco-cities and eco-villages. It puts the economy in proper relationship to society and nature. It respects decisions that are not purely economic. It relocalizes the basic necessities of life: food, water, shelter, clothing, and livelihood. It puts significant resources into regenerating and renewing the human and natural resources that human well-being and the well-being of nature depend on. It's lived fully rooted in the abundant flows of natural systems for energy, water, soil fertility, and materials. It uses nature as a model and mentor for technology and systems. It puts technology in service to more people working, but working less at more enjoyable and satisfying jobs. It uses collaborative and inclusive governance and decision-making structures. We've looked at practical things we can do today: installing solar panels, making biodiesel from waste vegetable oil, harvesting rainwater, rain gardens, growing food at home for a 4-season harvest, becoming part of a CSA, voting with our dollars, building with local natural materials, and reskilling. When we put all of this together in the proper relationship, using permaculture principles derived from nature, we get designs for sustainable living. The permaculture design process creates wholeness from the disparate technologies of sustainability. Permaculture design is a formal method for designing human habitats that have the stability, diversity, and resilience of natural ecosystems. Permaculture seeks to create a permanent culture based on a permanent, sustainable agriculture. Bill Mollison and David Holmgren developed permaculture in the 1970s from observation of mature ecosystems. Permaculture is an ambitious and largely successful attempt to apply the principles that govern mature ecosystems to the design of human settlements. It's been used in climate zones all over the world, from temperate to tropical, from wet to dry. Permaculture design is functional design. Often the term design is used in the context of the aesthetics of an object, building, or landscape. Permaculture complements a concern with aesthetics with useful function in a landscape, building, or city. Permaculture is a practical method of designing with nature. Permaculture has a stated ethics, a set of principles, and a body of practice applying the principles. In this course, we've seen many examples of the application of these principles. There have been many formulations of principles over the years. The one below comes from Toby Hemingway, author of an excellent book on applying permaculture principles to gardening called Gaia's Garden. The principles cover 3 main areas: the principles of functional design, principles that are derived from energy or living systems, and principles related to attitudes. First, let's talk about the basic principles of functional design. Use protracted and thoughtful observation rather than prolonged and thoughtless action. Observe the site and its elements in all seasons. Remember and think about Ruth Stout's mulch gardening techniques, developed from observation of nature in her garden. Use relative location. Place elements in ways that create useful relationships and time-saving connections among all the parts. The number of connections among elements creates a healthy, diverse ecosystem, not necessarily just the number of elements. You can do this by locating the garden next to the kitchen. The kitchen garden is something you use every day. It's easy to step out for some fresh herbs. Food scraps can be brought to the compost pile when the compost pile is close to the garden, which is close to the kitchen. Another example of this principle is access by proximity from the lecture on city design. Access by proximity means that everything you need for your life, working, shopping, banking, recreation, schools, is located near where you live so you can get your needs met by walking or biking. Identify, collect, and hold the useful energy flows moving through the site. By saving and reinvesting resources, we maintain the system and capture still more resources. This is an application of the concept of entropy. We're working with the natural fact of entropy when we collect and store the renewable energy that flows around us. Another example is water use. Instead of using fresh, clean, potable water indiscriminately for every household use, we use water quality appropriate to the use, like using gray water for irrigation. Rain gardens and swales hold and store water in the landscape so we can get more use from it before it exits the property. Choose and place each element in the system to perform as many functions as possible. Increasing beneficial connections between diverse components creates a stable whole. Stack elements in both space and time. You do this when you plan your garden with plant guilds in mind, assemblies of plants that work synergistically together, each plant performing several functions in the guild. Each function should be supported by multiple elements. Redundancy protects when one or more elements fail. Once more, we can see this when we plan for multiple sources and storages of water. Make the least change for the greatest effect. Find the leverage points in the system and intervene there, where the least work accomplishes the most change. Sheet mulch gardening is an excellent example of this. What less can I do in my garden rather than what more can I do? Use small-scale intensive systems. Start at your doorstep with the smallest systems that will do the job and build on your successes with variations. We discussed this when we discussed garden establishment. Start with a 4x4 or a 4x8 foot garden. Develop skills and confidence and then move on to larger garden projects. Those are the basics. All right, now let's talk about principles based on energy or living systems. The edge, the intersection of two environments, is the most diverse place in the system and is where energy and materials accumulate. Optimize the amount of edge. This is illustrated by the diversity of people who gather around a successful makerspace. A makerspace is a great example of a complex connecting point where diverse people come together and share and learn from each other. Mature ecosystems are more diverse and productive than young ones, so use design to jumpstart succession. We can see this at work when planting guilds with fast-growing nitrogen-fixing plants and slower-growing fruit-bearing plants. The fast-growing nitrogen fixers are used to provide mulch and nitrogen in the early stages of the guild and are often removed later as the second-stage succession plants mature. We want to use biological and renewable resources. Renewable resources, usually plants and animals, reproduce and build up over time, store energy, assist yield, and interact with other elements. Planting a border of comfrey to keep out weeds is an example of this. As always, whenever possible, we want to recycle energy, nutrients, and materials. Supply local and on-site needs with energy from the system and reuse this energy as many times as possible. Using water as many times as possible as it flows through your system is an example of this. Use washing machine water to irrigate plants. Solar panels on your roof provide energy. The natural plaster demo we saw earlier used materials from the site to create beautiful plasters. These next principles are informed by certain sustainable living attitudes. Sometimes these attitudes precede our actions and choices, but oddly enough, sometimes they follow from actions we take and results we see. Think about turning problems into solutions. Constraints can inspire creative design. We are surrounded by insurmountable opportunities. In opposition to what we've all previously believed, weeds can become food, sources of compost, and indicators of nutrient deficiencies. Another thing we want to consider that's important in design is getting a yield. Design for both immediate and long-term results from your efforts. You can't work on an empty stomach is the slogan here. And another thing to consider is that design limits yield. The designer's imagination limits total yield more often than do the laws of physics. In other words, with strategies like guilds and plant stacking, you can always fit in another plant. Go for it. And remember that mistakes are tools for learning. Evaluate your trials. Making mistakes is a sign you are trying to do things better. After 35 years of working with sustainability, I am still trying new things and learning from my mistakes. One example, if I did Abundance Eco Village again, I would do it in a city to facilitate access by proximity. I'm in the process of designing a new home for my family. I am working to integrate everything I've learned in the 15 years since I last designed and built my home. We're moving from the countryside to the city so we don't have to drive as much. We're going to create an urban farm using the many sources of organic material for composting available in the city. We'll use rain catchment and solar energy. These systems have served us well. We'll make better use of building science than we did in our straw bale house to make the house easier to heat and cool. These are some things I've learned and I'm going to apply as I go forward. The next area I want to discuss is permaculture ethics. All design has an implied ethics. In permaculture, the ethics of the design system are stated explicitly. Permaculture ethics are not ecocentric or people-centric. They are co-centric, looking at people in the context of their relationship to the earth. There are 3 ethics. The first is care of the people. Design should meet the needs of people. For example, in designing with economic systems, put economics in service to people rather than the other way around. The second ethic is care of the earth. Design should enhance rather than diminish the capacity of the earth's systems and should consider the needs of all the creatures of the earth. The third ethic is share the surplus. Once your systems are set up and meet your needs and you have enough, and these systems are very abundant, share the surplus with others. Surplus may be time, knowledge, plant material, or any other surpluses from your system. Indigenous people like the Tlingit and Haida in the Pacific Northwest have used similar principles to live in the same place for thousands, sometimes tens of thousands of years. In contrast, in just 200 years, North American settlers have reinvented agriculture along industrial lines, and in the process have diminished much of the productivity of the rich soils that they found here. The broad-scale farming systems that indigenous people used created much of the fertility of these soils. Mob grazing of buffalo, controlled by fire, created the rich prairie soils of the Midwest. The fertility of the agricultural systems of the Amazon basin was maintained through the creation of terra preta and biochar by the people who lived there. A few years ago, I was asked to go to Angoon, a Tlingit Native Alaskan village on a remote island in southeast Alaska, to explore ways they might use modern concepts of sustainability, like renewable energy. The Tlingit and their ancestors had been there for 5,000 to 10,000 years. It's a richly productive ecological zone, and the Tlingit have a saying, "When the tide is out, the table is set." There are massive runs of salmon, so thick in the streams that they can be harvested by hand. There are ample whales and seals. There are abundant berries and other plants for wildcrafting. They could get their needs met for food, shelter, and clothing with just a few months of work per year and spent the rest of the time socializing and developing a rich culture of craft, art, and storytelling. The Tlingit have a custom called potlatch, where resources get redistributed on a regular basis. It's a big party where the most respect goes to the people who give away the most stuff. It was outlawed by both the Canadian and U.S. governments for a number of years. The governments wanted to integrate the tribes into a consumer culture, and the potlatch went against it. The potlatch system made it difficult for members of the tribe to accumulate long-term wealth. The Indian nations now have more autonomy in deciding their own cultural practices and values. Potlatches are now legal, and the potlatch is making a comeback. Many people in the tribe still do a lot of hunting and wildcrafting, referred to as subsistence activities, but they now also depend on the plane and the boat for the basic necessities of life. Even though Alaska has tremendous oil resources, energy is very expensive there. Energy bills are 10 times what people pay in the lower 48 states. So if you pay $100 a month, they pay $1,000. Elders are concerned that because of high energy costs, they may be the last generation to live in Angoon. The community responded by exploring renewable energy as a way to replace expensive fossil fuels and add another connection to nature, to the rich tapestry of connection that comes from their culture and way of life. Here are my students and I working with the community to install solar and wind energy to displace energy from diesel generators. Another great example of traditional wisdom is the use of canoe plants by the Hawaiian and Polynesian nations. I lived in Hawaii for 8 years and began teaching sustainability as I developed a small farm there. There is much to learn about sustainability from traditional Hawaiian culture. Thousands of years ago, the ancestors of the Hawaiian people developed the ability to regularly navigate thousands of miles over vast stretches of the Pacific in sophisticated double-hulled boats. They colonized the Pacific from Taiwan to Easter Island to Hawaii. And Hawaii is one of the most geographically isolated spots on Earth, thousands of miles from land in any direction. They did this by using a suite of technologies, including sophisticated wayfaring methods that were developed from deep observation of nature. Observation of birds, currents, and wave patterns can show the direction to land hundreds of miles away. They developed sophisticated methods for celestial navigation. They could travel anywhere in the South Pacific and recreate their culture using about 30 plants that they carried with them. These 30 plants, sometimes called canoe plants, include medicinal plants like noni and mamaki, building materials like bamboo, weaving materials like lohala, and food plants like taro, sweet potatoes, sugarcane, and breadfruit. All the plants had cultural significance, and some were used specifically for religious and cultural purposes, like tea and ava. Once they reached a place, they used the genetic diversity inherent in the 1 or 2 varieties of each plant they brought with them to develop hundreds of varieties suited to the new place. For example, Hawaii had no taro when Polynesians arrived, but now has 300 varieties of taro and is the center of diversity of taro in the whole world. Even today, hundreds of years after the start of colonization from the outside, you can find canoe plants in the landscape in Hawaii. Native Hawaiians and others still use these plants for a wide range of purposes, including food, medicine, building materials, and religious and cultural expression. Canoe plants are an excellent example of what we explored in Lesson 2 on getting our needs met through a landscape full of useful plants. Can we develop suites of plants that could be used to create a sustainable culture in a bioregion? The development of canoe plants and the exploration and colonization of the South Pacific by Polynesians is one of the most amazing things that humans have ever done, and may represent a technological achievement beyond putting a man on the moon if you compare along the lines of knowledge and other resources available. Unfortunately, colonization by outside forces has often suppressed valuable indigenous wisdom over the last couple of centuries, as we know from our history lessons. However, starting in the 1970s, there has been a renaissance in Native Hawaiian language, culture, and music. The use of traditional plants and the skill of voyaging across the ocean using traditional techniques have been revived, along with a burgeoning sovereignty movement and interest in sustainability. Perhaps such efforts can lead to the recovery of more ancient skills and their application to the contemporary issues of sustainability. Modern ecological design systems like permaculture borrow heavily from traditional wisdom about how to live in a place. Traditional wisdom is complemented with knowledge from modern scientific understandings about nature and the world. It's not an attempt to go back to something from the past. It's an attempt to create something new based on a new holistic understanding of science and traditional wisdom that has never existed before. With this combination of ancient wisdom, modern science, and a holistic worldview based on integrating the two, there's the possibility that the human footprint on Earth could be positive. As we've discussed, ecological footprinting tracks the impact of sourcing our materials and sinking our wastes, and helps guide efforts to equitably keep that impact within the regenerative capabilities of the Earth. But what if all the byproducts of human activity were wetlands, wildlands, and beauty? What if human activity acted in greater concert with the greater ecology of the planet? Well, then the human presence on Earth could be seen as a positive thing. One attempt to fit human technology into the larger systems of nature is the interdisciplinary study of biomimicry. Biomimicry is an emerging discipline that uses nature as model and mentor for the design of technology and systems. Currently, when people make things, we use high temperatures, high pressures, and toxic chemical processes. Contrast this heat, beat, and treat approach with how materials are created in nature. The abalone makes a ceramic for its shell that is tougher than the tiles on the space shuttle. It does this at ocean temperatures, at atmospheric pressure, and using the materials that it finds near it in seawater. Kevlar, one of the strongest man-made fibers, is made using vats of toxic chemicals reacted under high temperature and pressure. It requires large amounts of energy. Contrast this with spider webs. Spider webs are stronger than Kevlar, and spiders make them at room temperature out of the bugs that they eat. When spider webs have outlived their usefulness, they get turned into food for microorganisms and are cycled back into life. Pax Scientific Company has developed a water mixing device based on biomimicry that mixes 10 million gallons of water with the energy of 3 100-watt light bulbs. Pax founder Jay Harmon developed a Lilly impeller after studying fluid flow efficiencies in natural systems, such as air and ocean currents. Learning to base our chemistry and technology on these principles will likely occupy the work of several generations of scientists, engineers, and entrepreneurs. Becoming native to the place where you live, rooted in the abundant flows of natural systems, is a central part of sustainability. And we can look for inspiration on how to do this from both science and traditional cultures. Often we're led to believe that the solutions all lie with individual initiative. But there is much that can be accomplished through individual initiative. But some things we need to do, like eco-city design, are beyond our abilities as individuals. Here's an example illustrating the tension between the importance of individual and collective efforts. Municipal waste, which is basically everything that's put out at the curb, amounts to about 1,600 pounds per person per year. Let's say that you get really good at recycling and eliminate the entire 1,600 pounds due to you. Well, but municipal waste only accounts for 3% of the waste stream in the US, so you'd still have a long ways to go. As Derek Jensen points out in his article, Forget Short Showers, personal change isn't always sufficient for social change. Don't get me wrong. It's still a good idea to start at your front door and do everything you can personally for sustainability. But at some point, we need to address the larger societal systems that personal change can't address. Thomas Berry calls the effort of rethinking the world and our place in it in terms of sustainability the great work of the upcoming generations. I think it's going to engage everyone on the planet over the next 50 to 100 years. The changes we need to make are, for the most part, changes that make our day-to-day lives richer. It's a better way to live. It's not a sacrifice to live with an ethic of care of the earth and care of the people. It gives our lives a greater sense of purpose and meaning. In large part, we know what to do to power human society with renewable energy, to feed human society using organic agriculture, and to house people in sustainable buildings. While technology can improve, the exciting thing is that these technologies are good enough, cheap enough, and available at the household scale, making it practical to adopt them in your life today. We've known how to do these things in most cases for a long time. Here's a 100% solar-heated house that was built near cold, cloudy Boston by MIT researchers in 1939. Adoption of these technologies has been waiting for a shift in worldview, a shift in collective consciousness that would put them in service to a better world for all humanity. This world will likely be as different from the world we have today as the world of the hunter-gatherer or pre-industrial agriculturalist is from our world. This quote from Buckminster Fuller, one of the pioneers in ecological design, sums it all up beautifully. You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete. The goal of sustainable living is a better way of life. Material sufficiency with more time for family and friends. Human activity in harmony with the larger cycles of nature, and a sense of purpose and meaning. I invite you to begin imagining, creating, and advocating for sustainability today.